Research Institute. And this is a survey that he has conducted. It took him a year-long time to complete this survey, and he has surveyed some 579 institutes, research institutes, which do medical research, and of which he has derived that not all the medical research institutes are doing a lot of research. They are more into clinical problems, and there are only 4 such institutes which are contributing majorly towards research in our country. And very fortunately, the topmost institute which is doing that is All India Institute of Medical Sciences. And today we are very fortunate to have most of our key speakers from this organization, and we are looking forward to having a great day with them, understanding the biomedical research that is happening in our country. We are also very pleased to have with us Dr. V.M. Katoch, former DG ICMR, Dr. Manju Sharma, Principal Advisor for Biotechnology, Government of Gujarat, Dr. P.K. Ghosh, Advisor Biotechnology for Government of Gujarat, Dr. Amit Ghosh, who is former Director Intake Chandigarh, and currently he is member Technical Advisory Committee of GSBTM, Government of Gujarat, Dr. H.L. Trivedi, Director, Kidney Research Institute. May I request our Mission Director, Shri S.N. Tyagi, to kindly guide the dignitaries to the dais. We are very happy to have with us all the deans and very senior faculties from Biomedical College today here with us for this seminar. I would now request my team members to welcome the dignitaries on the dais with flowers. May I request Dr. Snehal Bakhtaria to welcome Dr. Manju Sharma with a bouquet of flowers. I request Dr. Anand Bhadal to welcome Dr. V.M. Katoch. Maheria. Request Dr. Jaishankar Das to welcome Dr. B.J. Shah, Dean, Biomedical College. I request Dr. Snehal Bakhtaria to welcome Dr. Kirti Patel, Dean, GCS Medical College. I understand he isn't there. I request Dr. Snehal Bakhtaria to then welcome Dr. R.K. Vyas, Director, GCRI. We would also want to extend floral welcome to our dignitaries who are off the dais. I request Dr. Madhvi Joshi to welcome Dr. Balram Bhargav. Request Dr. Jaishankar Das to welcome Dr. Nikhil Tandon. Request Dr. Snehal Bakhtaria to welcome Dr. Lalit Kumar. Request Dr. Anand Bhadalkar to welcome Dr. S.P. Agrawal. Request Dr. Madhvi Joshi to welcome Dr. Alka Sharma. request Dr. Jaishankar Das to welcome Dr. Amit Ghosh. Request Dr. Snehal Bakhtaria to welcome Dr. P.K. Ghosh. Request Dr. Madhvi Joshi to welcome Dr. Sunil Kumar, Director, NIOH. May I now request Dr. B.J. Shah to give the welcome address.
Especially on the today's occasion, where in the first time in the history of Biomedical College and Civil Hospital Ahmedabad, where biomedical research as a conference it is organized first time, I should welcome on this occasion the landlords and logistic of this, especially different on the stage and certain people who are off the stage from the different parts of India. We welcome on behalf of Government of Gujarat and Biomedical to all of you. See, on this occasion, previously we were thinking that research is only a part of certain people. Now, we as a doctor and with the help of engineers, we are doing so much research in different parts. If I have to say example today, because of the research facility available in the state and available in the college and hospital, our tuberculosis department or pulmonary department has done the advanced remarkable research, especially in resistance TB. I should congratulate them because of the VM Katot sir and others. We are in a position to get everything and we are now training the so much people of this research. So the advanced resistant tuberculosis has been now about to remove from our country. That is because of the research only. Even the today era, why this research is important. Suppose you want to, now Gujarat is a diabetic hub. At present, we get the different types of insulin resistance drugs and other things. Now, artificial pancreas is available. Now in this, artificial pancreas, biomedical, both are very much. Previously, the machine of artificial pancreas like this, now it is so small. At the same time, for cancer treatment, when we give radiotherapy, previously it is given in the different parts. Now, only at the specific part, radiotherapy has been given. With the advancement in technology, with the microscope, we can diagnose bleeding disorder very, very early stage. That is really useful for the patient in the treatment part. At the same time, stem cells, what the topics has been today covered, especially the urinary tract infection, dentistry, and radiotherapy in cancer patient. So this technique is really useful for us. Yes, now I should say, previously we in all Gujarat are very poor in research, but now because of the what heading is road ahead, it is road ahead, we agree, but with the seminar, it gives the different roads in which road we want to get, because see, the different people of different branches can go on the different roads to treat our patient. So this seminar is really useful for all of us to get the research in different fields, but I should say to the central government and also our state government is ready to give us the different types of help, especially those who want to do the real research. They should be given 100% possibility of the all financial and instrumental help to us so that our patients will get the real research for this. I should pray that this seminar is useful for our patient and ultimately it gives to knowledge to all of us. Thank you very much. Jai Jai Garvi Gujarat.
Thank you, sir. May I now request the dignitaries on the dais to kindly light the lamp. Thank you all for kindly lighting the lamp and taking the light of knowledge ahead. May I now request Dr. Maheria, Additional Medical Superintendent, to kindly give the opening remarks. Dr. M. Prabhakar, Medical Superintendent, he could not make it up for the program, and hence Dr. Maheria is here with us.
Good morning, everybody. All respected colleagues and friends, and this august audience, we are having now new horizons, and the bond which is becoming tightened between the biomedical and biomedical engineering as well as the research project, and that has linked the state, central government and now the medical institution also. This project we were planning since last 1 month, and today it has come to a truth, and now we have few projects to come in the future days. Now, dear friends, we know we have many experts from the various parts of the Indian states, and they will serve us a lot of knowledge and imparting their experience and widen the expectations in the coming days. And I am highly obliged from the Department of the State. That is they have agreed to keep this seminar in our hospital, especially Civil Hospital and Biomedical College. So once again, I thank all the persons who are with us joining and delivering lectures, and many of our friends from the various parts of the Gujarat state. So hopefully this message will impart, and ultimately what the sir said, that the whole society, the community and patients all are served for the better health. Thank you very much.
Thank you, sir. May I now request Dr. R.K. Vyas, Director GCRI, to say a few words.
Distinguished guests on the dais, distinguished speakers, respected senior colleagues, and dear participants. On behalf of GCRI, I welcome you all to this one-day seminar on biomedical research in Gujarat Road Ahead, organized by GSBTM, especially for the medical professionals. As I am from a cancer research institute, I wish to share my views pertaining to role of biotechnology in cancer care. As our Dean sir rightly mentioned about radiotherapy, that is one of the aspects of cancer management. Cancer is the fastest growing disease worldwide. Each year around 12 million people are diagnosed with cancer across the globe. In developed countries, cancer has become the leading cause of death, and in developing countries it is second only to the heart disease. In spite of all modern facilities for diagnosis and treatment, drug resistance or recurrence of tumor is still a challenging task for all of us clinicians. By 2020, the global cancer burden is expected to rise by 50% owing to the increasingly elder population. All this is likely to pose a challenge to the delivery of cancer care, as it will increase the need for more comprehensive and accessible cancer care management. Coordinated team-based cancer care will be essential to ensure value-based care. The increasing incidence and prevalence of cancer will place new demands on our healthcare system. With research being one of the important components, GCRI has 5 well-equipped research labs. If you get time, you can visit our institute. We have dedicated teams of research scientists working in various aspects of cancer research and clinical trials. Biotechnology has proved a boon for medical science and has become an integral part of medical world, with incorporation of new products and discoveries pertaining to diagnosis and therapy. It has largely influenced cancer care by providing small molecules, that is called NIPS, and monoclonal antibodies called MAPS based target therapies, which has increased the chances of particular cancer survival as well as control. Besides this early detection of cancer and metastatic using modern biotechnology biotechnology influenced studies such as next generation sequencing and microarray from cancer stem cells, circulating tumor cells, and liquid biopsy samples are of center focus in cancer research. I am delighted that this event is organized in our civil hospital campus with so many distinguished speakers of national and international repute, and wish it a grand success. Hope you all can take the best out of it and utilize in your future endeavors. Thank you very much.
Thank you, sir, for your best wishes. May I now request Mission Director GSBTM to kindly talk to us about the GSBTM initiatives in healthcare biotechnology.
दोस्तों, मैं बहुत समय नहीं लूँगा आपका। काफ़ी इम्पोर्टेंट लोग हैं जिनको हमने बुलाया है, जो हमारे अतिथि हैं और चिकित्सा से जुड़े हुए हैं। आप सब लोग शायद उनसे वाकिफ़ होंगे। मोस्ट ऑफ देम आर पद्म अवार्डीज ऑल्सो। मैं थोड़ा सा आपको रूबरू करूँगा सरकार के उस डिपार्टमेंट से जो कोशिश में है, लगातार इस कोशिश में है कि किसी तरह से संशोधन को हम किसी तरह से प्रोत्साहित करें। दोस्तों, विज्ञान और प्रौद्योगिकी विभाग जो था, जो साइंस एंड टेक्नोलॉजी डिपार्टमेंट था, सरकार में वो पहले नहीं था। उसकी ज़रूरत महसूस की गई और 2004 में विज्ञान और प्रौद्योगिकी का विभाग स्टेट गवर्नमेंट में भी अस्तित्व में आया। उसके बाद ये लगा कि विज्ञान का जो मतलब है वो खाली फिजिकल साइंसेज नहीं है, बल्कि जैव विज्ञान को भी उसमें हमें शामिल करना चाहिए। और दोस्तों, उसी वर्ष हमारी सरकार ने, गुजरात सरकार ने जीव विज्ञान के लिए, जैव विज्ञान के लिए, बायोटेक्नोलॉजी के लिए एक नए डिपार्टमेंट की शुरुआत की। वो शुरुआत एक मिशन मोड में हुई और उसमें एक मिशन डायरेक्टर की पोस्ट का क्रिएशन हुआ और उसके साथ साथ कुछ थोड़ा सा स्टाफ गवर्नमेंट ने हमको दिया। दोस्तों, उस समय से 2004 से हमारा ये सफ़र निरंतर चालू है और काफ़ी कोशिशों के बाद, काफ़ी प्रयासों के बाद आपको जान के खुशी होगी कि बहुत सारी इंडस्ट्रीज़ हमारे खुद के प्रयास से गुजरात में आ सकी हैं। कोई बहुत बड़ी इंडस्ट्री नहीं आई, लेकिन काफ़ी कुछ इंडस्ट्रीज़ आज गुजरात में हैं। हमने उनको सपोर्ट किया है, हमने उनको ज़मीनें दी हैं, जगह दी हैं, हमने उनको सामने से बुलाया है। दोस्तों, एक बहुत बड़ा पार्क, 1000 एकड़ ऑफ लैंड वी रिजर्व फॉर बायो पार्क, बायोटेक्नोलॉजी पार्क, एंड मैनी इंडस्ट्रीज हैव कम अप, they have established. We are looking for more industries also. It is near Baroda, it is in Manjusar, it is in GIDC of Savli. दोस्तों, बिजनेस के साथ साथ हमने ये सोचा कि खाली बिजनेस से काम नहीं चलेगा, हमें संपूर्णता में सोचना पड़ेगा, टोटलिटी में हमें विचार करने होंगे। हमने एंटरप्रेन्योरशिप को भी साथ में रखा। हमने सोचा कि क्यों ना, बहुत सारे ऐसे एरियाज हैं जिसमें एंटरप्रेन्योरशिप डेवलप हो सकती है। हमने एंटरप्रेन्योरशिप को डेवलप करने के लिए बहुत सारे प्रोग्राम बनाए और वो चल भी रहे हैं। और इसी के साथ साथ फिर हमने ये सोचा कि क्यों ना हम स्टार्टअप को भी प्रमोट करें, तो स्टार्टअप के भी प्रोग्राम हैं। गवर्नमेंट बहुत ईगरली, बहुत उत्सुकता से स्टार्टअप के प्रोग्राम को संबल दे रही है, एक ताकत दे रही है। और ये खाली हमारी ही कोशिश नहीं है दोस्तों, ये केंद्र सरकार की भी उतनी ही कोशिश है कि हम किसी तरह से इस देश को स्टार्टअप को हवाले रखें और कुछ नया संशोधन जो उनके पास है, नया प्रोडक्ट उनके पास है, या जो उनके पास कुछ नई सेवा है, उसको वो लेके आगे आएँ और किसी तरह से बिजनेस मोड में हम आगे चलें और हम ज़्यादा से ज़्यादा जॉब, ज़्यादा से ज़्यादा जो है रोज़गार हम उपलब्ध करा सकें। और ये ऐसा फील्ड है जिसमें रोज़गार की संभावनाएं तो हैं, लेकिन वो तभी हैं जब एक बड़ा संशोधन कोई हो और एक बहुत बड़ा कोई ब्रेक हमको मिले। दोस्तों, इस सब के साथ साथ संशोधन को हम शुरुआत के तबक्के से 2004 से हम प्रमोट करते रहे हैं। हमने करोड़ों रुपया यूनिवर्सिटीज को दिया है। शायद ही कोई यूनिवर्सिटी इस गुजरात की धरती पे है, शायद ही कोई यूनिवर्सिटी है, शायद ही कोई उसका ऐसा डिपार्टमेंट है जो बायो से संबंध रखता हो, चाहे वो माइक्रोबायोलॉजी हो, चाहे वो बायोकेमिस्ट्री हो, चाहे वो बॉटनी हो, चाहे जूलॉजी हो। दोस्तों, किसी भी डिपार्टमेंट को हमने छोड़ा नहीं है। हमने सबको सपोर्ट किया है, अपनी मर्यादा में सपोर्ट किया है, लेकिन धीरे 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 हम इस नतीजे पर पहुंचे हैं कि दोस्तों मेडिकल प्रोफेशन से लोगों का जो रिस्पांस है वो बहुत कम है। जितना भी हमारा फंड जा रहा है वो सब दूसरी यूनिवर्सिटीज को जा रहा है, दूसरे डिपार्टमेंट्स को जा रहा है। मुझे लगा कि अगर मेडिकल प्रोफेशनल्स को हम थोड़ा सा एक्सपोज कर सकें इस विज्ञान से और इस विधा से, इस स्पेशलाइजेशन से, इस सुपर स्पेशलाइजेशन से, तो ये काम बहुत आसान हो सकता है। और ये जो संशोधन है, ये जो भी रिसर्च है, ये बगैर मेडिकल प्रोफेशनल्स के अगर हम अपने हाथ से करेंगे, अगर हम मेडिकल प्रोफेशनल्स को इसमें शामिल नहीं करेंगे तो ये अधूरा ही रहने वाला है। मेडिकल प्रोफेशन में बायोटेक्नोलॉजी का इंटरवेंशन इतनी तेजी से चल रहा है, इतनी तेजी से आगे बढ़ रहा है, मुझे ऐसा लगता है कि शायद सर्जरी का कुछ और ही शक्ल होगा कुछ 10-15 साल के बाद। शायद वो सर्जरी जो आज की व्याख्या में हम जिसको सर्जरी बोलते हैं, शायद वो बिल्कुल बदल जाएगी। क्योंकि मैंने खुद देखा है कि जो केमिस्ट्री की हमारी केमिकल फैक्ट्रीज थी, उनकी शक्ल बदल रही है। आज डिटर्जेंट, आज हार्मोन, आज एंजाइम वो केमिकल फैक्ट्री में नहीं बन रहे हैं दोस्तों। उन सभी को एक बैक्टीरिया से बनाया जा रहा है और एक इंसान है जो उसको कमांड दे रहा है, और वो आपके मुताबिक, आपकी ज़रूरत के मुताबिक वो उस बायो प्रोडक्ट को बाहर ला रहा है। तो ये एक संगम की बहुत बड़ी ज़रूरत है, एक ऐसा संगम जिसमें हम सब शामिल हों, हम सब एक छत के नीचे हों और एक दूसरे को समझ सकें और एक दूसरे की मदद में आ सकें। ये समय की बहुत बड़ी ज़रूरत है और हम तत्परता से हम आतुर हैं, हम सामने से हम आने को तैयार हैं। कुछ आप अपने फील्ड में आप बहुत कुछ सोच रहे होंगे, उसमें कुछ ऐसा भी संभव होगा जो जैव प्रौद्योगिकी से, बायोटेक्नोलॉजी के सहारे से कुछ और अच्छा, कुछ और इम्प्रूवमेंट वाला कुछ आपको प्रोडक्ट मिल सकता होगा या सर्विस मिल सकती होगी। दोस्तों, आज उस पर विचार करने के लिए हम यहाँ बैठे हैं। हम लोगों ने कुछ इनिशिएटिव लिए थे, कुछ पुराने समय में कुछ इनिशिएटिव लिए थे। कैंसर के संदर्भ में हमने एक इनिशिएटिव लिया था। उसका सबसे बड़ा एक फायदा यह था कि यहाँ एक लैब थी, रिसर्च लैब थी, जो अक्सर मेडिकल कॉलेज में नहीं होती है। कैंसर इंस्टीट्यूट में एक रिसर्च लैब थी और उनके साथ जुड़े हम, और आपको ये ताज्जुब होगा कि 1000 से ज़्यादा कैंसर टिश्यूज का एक रिपोजिटरी उनकी मदद से, कैंसर रिसर्च इंस्टीट्यूट की मदद से आज जीएसबी टीम के पास है। दोस्तों, बहुत बड़ा पोटेंशियल है। हम उसको किस तरह से उसको यूज करें, उस रिसोर्स को, जो टिश्यू हमारे पास है, उसमें हम कैसे आगे संशोधन करें, दोस्तों आप सबको जोड़ने की जरूरत है। इसी तरह से जो जेनेटिक डिसऑर्डर्स हैं, एक बहुत बड़ा रिपोजिटरी उसका भी हमारे पास है। एक बहुत बड़ा डाटा हमारे पास है। 85% पॉपुलेशन हमने स्क्रीन कर रखी है सिकल सेल के लिए। बहुत बड़ा डाटा हमारे पास है, गवर्नमेंट के पास है। लेकिन उस डाटा में हम कहाँ इंटरवेंशन करें, किस तरह से करें, वो आज सुनने के लिए हम यहाँ मौजूद हैं। दोस्तों, स्टेम सेल के बारे में भी काफ़ी कुछ चर्चाएं हुई हैं, उसमें भी काफ़ी कुछ हम लोग कोशिश किए हैं, कुछ थोड़ा सफलता उसमें मिली है। लेकिन इस सबसे ज़्यादा ज़रूरत यह है कि हम सब सोचें, मिलकर सोचें। सरकार के पास फंड्स की कमी नहीं है, पैसे की कमी नहीं है, बिल्कुल नहीं है, मैं आपको आश्वस्त करता हूँ, बिल्कुल कमी नहीं है। लेकिन हमारे पास वो रिसोर्स नहीं है, वो उत्सुक रिसोर्स नहीं है जो सामने से आके कहे कि सब इसमें हम आगे आने को तैयार हैं और इसके सॉल्यूशन के लिए हम आगे बढ़ने को तैयार हैं। मैं 2 मिनट के लिए थोड़ा सा मैं माधवी को रिक्वेस्ट करूंगा, वो थोड़ा सा, चूंकि वो एसोसिएटेड है, शी इज सेक्टर स्पेशलिस्ट वर्किंग विद जीएसबी टीम, शी विल एक्सप्लेन यू इन few minutes what is going on and what we can do ahead. Thank you.
Thank you very much, sir. I think today is one of the most appropriate day to discuss what biotechnology mission has been doing up till now in the healthcare segment, because we have today with us most of the eminent speakers from All India Institute of Medical Sciences, Department of Biotechnology, Government of India, and our resident doctors, fraternities, superintendents and deans. Friends, you would be very happy to know that way back in 2005, with the help of our principal advisor, Dr. Manju Sharma, and our advisors, Dr. P.K. Ghosh and Dr. Amit Ghosh, who are the pioneer of our technical advisory committee, we had worked out a detailed plan through a brainstorming session on what biotechnological interventions could be done in the healthcare segment. Without duplicating the efforts of what our health department is already doing, we had identified 3 potential areas in which we would be taking the step further. One is we want to establish network of genetic diagnostic centers across the medical colleges and hospitals in Gujarat. Second was we also want to initiate the biobanking activities in collaboration with most of our surgery departments, because these repositories are going to take the way further in understanding the development of the diseases, how the medicines will work, and all sort of other information related to it. And the third is that the regenerative medicine, which is a very upcoming word, and it has most potential in the healthcare segment, where our doctors, we want to sensitize them about what is doable, what is not doable in the stem cell research area, and to give them some exposure on these latest development technologies. We have initiated the training programs. We have trained more than 100 medical doctors in genetic disorders and stem cells up till now from the government medical colleges across state. We have sensitized more than 1,000 doctors of RBSK for taking the training in some of the genetic counseling and genetic diagnostics. We have initiated some of the, as sir mentioned, detailed plan on how the genetic diagnostic at a district level can be addressed through the existing schemes of government, that is ICDS and RBSK, under which we have already screened the kids of 0 to 5-year age group from the Porbandar district. Apart from that, in muscular dystrophy, in association with Indian Muscular Dystrophy Society, we have screened more than 400 families for the muscular dystrophy, including the carrier status. And in biobanking, as sir mentioned, that we have a basic repository which has 1,000 tissue of 13 different cancer types, and we are enriching the repository day by day. Friends, the core objective is that when we have such an eminent people who can act as our mentor today, this is just a booster's initial starting session, With your help, we want to take all these initiatives to entire state so that it can benefit our population, and we can something together, initiate in the biotechnology in the healthcare segment. Thank you.
Thank you, sir, for motivating the gathering today here to take up research in biomedical areas. And thank you, Madhvi, for elaborating on the work that GSB team has been doing. Our next speaker, who is here to give the presidential address, does not need a lot of introduction because most of us know her, but still I will go ahead. She is Dr. Manju Sharma, former Secretary, Department of Biotechnology, Government of India, and a Padma Bhushan awardee. She has been instrumental in revolutionizing the biotechnology research in the country. Madam has been an institution builder in the country and has laid the foundation of many DBT research institutes. She has also developed the entrepreneurship and business wing of DBT in form of Biotechnology Consortium India Limited, BCIL, which now caters to many business needs of biotechnology in the country. And this amalgamation of both the wings that actually brings technology to the doors of the people is a very important aspect of driving science ahead in a society. May I now request ma'am to kindly give the presidential address.
Namaskar and a very good morning to all the distinguished invitees here, the dignitaries on the dais. My particular thanks to the speakers, very, very distinguished speakers who have come from outside and they have taken the trouble in spite of their very busy schedule. We have Dr. Katoch here, all of you know, he doesn't need an introduction. The former DG ICMR and Secretary DHR. We have Professor Balram Bhargav, Dr. Nikhil Tandon, Professor Lalit Kumar, Dr. SP Agarwal, and my very dear friend, Dr. Alka Sharma from DBT. So you know that you are going to listen to very important areas, particularly of interest to the state, and the purpose will not be served if you just listen to the lectures. What we want is that we should, in Gujarat state, realize that research is very important in all these areas, particularly the diseases which are prevalent in the state. And how are we going to make use of this particular event for our future plan of action? That's the critical point, which we will discuss certainly at the end. I generally don't like to start my talk on a negative note, but in this case, I'm compelled to do that, particularly because I want to bring some facts to your notice. Recently, a Times of India news report on 30th May 2016, it appeared that Indian medical colleges lag in research as per the Lancet report. It says, India's medical schools have neglected research as a focal point of academics and they produce few publications. As per a study which is cited in the report, over 332 of 579 medical colleges did not publish a single research paper between 2005 and 2014. It also refers to a very recent report from the Parliamentary Standing Committee. Now that's very important. Parliamentary Standing Committee on Health. The study has brought out many other facts. For example, only 25 institutions produce more than 100 research papers in a year. So it's not that none of the medical colleges are working, but a very small number, as this says, just about 25 or so. The study concludes as a drastic overhaul in Indian medical education is necessary, similar to that initiated by Abraham Flexner in US. One of the most renowned biomedical scientists, and I'm sure all of you are familiar with his name, Professor P.N. Tandon, who was supposed to be here today. He, along with the late DG ICMR, Dr. Ramalinga Swamy, Professor M.G.K. Menon, from the 6th plan period onwards, imagine that was 80s, they have been discussing this issue of how do we strengthen medical research in the medical colleges. So it's not an issue which has come up suddenly. It has gone on for many, many, many years. Fortunately, when Dr. Katoch became DG ICMR and Secretary DHR, Professor Tandon pursued the matter because he is one person who has this ability to pursue something and get ultimately the result. So he pursued it with Dr. Katoch, and they were able to strengthen the medical colleges to some extent, some of them for taking up advanced research. And you will hear all the details from Professor Katoch, who will explain to you and what he has done and how he has gone around and done it. The purpose of organizing this one-day meeting is precisely to consider a roadmap for improving the research scenario in the state medical colleges. That's the purpose. The present speakers, all the distinguished speakers, will point out the gap areas, some new initiatives, innovation-driven medical practices, and overall, the skill improvement, which is most essential. If you don't have the skilled human resource, who is going to do research? Equipment and facilities will not do research. Even if you create big buildings, big centers, lots of equipment. We have seen some places where equipments have been brought, the plastic covers have never been removed for years. The reason is there is no skilled human resource to do research. The Gujarat State Biotechnology Mission, Dr. Tyagi is the mission director, they are very keen to support relevant biomedical research. And Dr. Tyagi has taken personal interest in talking to the professors, the faculties, the dean in medical colleges, that they should formulate proposals and basically consider what are the steps to be taken to initiate this practice. So the very first step we have to take, and we have discussed this in a small committee, is that we must improve the infrastructure and quality manpower has to be recruited for research purposes, not just ordinary people who will just come and then do something and go away. Some really distinguished, well-trained manpower is required. Biotechnological interventions in medical research would go a long way to produce innovative research and technology. I want to quote here a visit of Harold Varmus, all of you know, a Nobel laureate and a very, very distinguished biomedical researcher. He said, and he had come and met the former Prime Minister Atal Bihari Vajpayee, and Vajpayee asked him, what is the most important area in the health sector we should take up? And immediately Dr. Varma said, without seconds waiting, it is epidemiological research. You must assess the disease burden. You must know what is the load. Then only you can think about how do we go about future. And then in one of the lectures he gave at one of the institutes in Delhi, he said, one of the crucial tasks to be taken up by health agencies is an assessment of proper disease load, statistics, and epidemiological work. Very critical. I'm sure today's lectures in all these areas, cardiology and diabetes and cancer and dentistry and ultimately stem cell research, they will really open new avenues for you. You will think that how much advanced biomedical research has become in the country, and these are all the people who will be speaking to you. They represent, they are coming from medical college, I mean, AIMS. I don't know whether you should call it a medical college or what, but AIMS is again a hospital also, where patients come. Their patient load is very heavy. In spite of that, each one of them who is here today to speak to you has conducted separately research, focused research, and the results, they will tell you, they are fantastic. Some of them have really shown what can be done while practicing medicine. You can also do research. Biotechnology and new biology, including bioinformatics, they have paved the way for frontline cutting-edge research and development. Just to give you one example, when the human genome map was completed and everybody was excited, the genomics was becoming a really important field, structural, functional, application-oriented genomics. All over the world, there was a sort of a wave of genomics. And at that time, its application in medicine, and what did Dr. Francis Crick said? In 5 years, the impact on medicine will be very big. In 10 or 15 years, it will be overwhelming. So one area where GSBTM has done very good work, they have good facilities they have created in the state, is genomics, genetics, and Madhavi mentioned about the need for genetic counseling units, etc. That's one very important area. I am very confident that today's deliberations, they will usher a new wave of thinking so that the faculty of medical colleges present here in large numbers, I can see they can start moving in this direction. It will take some time for you to get into that mode, to assemble all the structure, all the necessary inputs which need to be available for doing research, advanced research. GSBTM and many other financing agencies, I'm sure, will be able to support. GSBTM has been very keen, and we have been thinking that if 10 or 15 medical colleges will come up, we'll create some sort of a specific budget head for biomedical research in the GSBTM sector itself. Vaccines, diagnostics, new therapeutics, drug delivery systems, epidemiology, etc. All these, prevention and cure, of the prevalent diseases in this state. That is the whole objective, that we must look at these areas. We can't do everything. The country is too big, the state is too big, and there are so many things happening. But what exactly is required in the state, we can think of. One important thing which Dr. Tyagi was mentioning to me, that what type of facilities should we create in the medical colleges. And I'm sure when we listen to the various lectures, something of the type will be mentioned here. Dr. Alka Sharma and Dr. Balram Bhargava probably will talk about one very unique thing which the Department of Biotechnology has done, and that is to establish a biodesign center in collaboration with the Stanford University. And lots of medical devices have been developed. Many of them have been transferred to the industry, and that shows it is within the All India Institute of Medical Sciences. The engineers from IIT are involved, other places, and the scientists in AIIMS, they have all come together. And a very large number of people have been trained in development of biomedical devices. Maybe something like this can be thought of in one of the medical colleges here, because there are good engineering colleges in the state, and they can be all brought together. And both of these people will probably elaborate this aspect. Professor Balram Bhargava is the executive director of that Biomedical Biodesign Research Center. So I will stop here, and at the end of this day today, when we finish all the lectures, we'll have a small discussion. Of course, time will not permit us to go into the details of which area and how do we go about and how do we fund and which medical college. All that will come up later, and I will leave it to GSBTM along with the health care agencies here to evolve an action plan. And maybe sometimes after 6 months or so, we can invite the experts again to see what has happened, and is there a need to improve or give more suggestions and more advice. So once again, thank you very much for coming here in large numbers, and let's hope the purpose of our meeting will be served. Thank you.
Thank you very much, ma'am, for setting the context of the seminar today. I will now request our inaugural address speaker to come on the dais and give the inaugural address. He is none other than Dr. Katoch, who was the first Secretary of Department of Health Research, Government of India, and a key architect of medical research in India. He has been recipient of many awards and honors, key of which is Excellence in Science and Technology Award for the year 10-11 by Indian Science Congress Association. He has contributed a large number of research papers in national and international journals. Sir is also a fellow of all prestigious science academies of the country and is still supporting the shaping of medical research in the country. Sir, please. Maybe now I will invite Dr. Madhvi Joshi to give the vote of thanks so that we can go ahead and have Dr. Katoch's presentation.
On behalf of Gujarat State Biotechnology Mission, Department of Science and Technology, Government of Gujarat, I formally thank Dr. Manju Sharma, our Principal Advisor for Biotechnology and a key pillar in the development of biotechnology that is happening in the state, for suggesting and actually convincing all the speakers to remain present here for this session. Actually, she works like even a young lady today. I mean, don't go by her age. She is the motivation and she is the key person who has helped us in organizing this program today. I'm also thankful to Dr. Katoch for taking out his time and coming here. Apart from that, Dr. Shah, Dr. Maheria and Dr. Vyas, who are the local support for us in organizing this program. Thank you very much, sir. Our mission director who had the idea and the vision of initiating this program, Thank you very much, sir, for that. All the eminent speakers who have taken lot of pain and coming here for inspiring our young doctors for conducting research in the medical field. Thank you very much. There are few friends who would need a mention here. Dr. Prabhudas Patel, Dr. Rakesh Rawal, Dr. Charul Purani and Dr. Pillai, who have helped us in organizing this entire program and coordinating with various medical colleges here. Thank you very much, all of you. Participants who have come from across Gujarat, Jamnagar, Baroda, Bhavnagar, Surendranagar, Rajkot, and of course all the medical colleges and hospitals in this campus. Thank you very much, because without you this program would have no value. Our dedicated team of Biotechnology Mission, whose tireless efforts have made this program a success. Thank you very much, especially my colleague Mrs. Anasuya Bhadalkar and her team, Jitish Doshi and all. Thank you very much. Without taking much time, I think I'll request all the dignitaries to take their seat in the audience so that we can begin the lecture of Dr. Katoch. Thank you.
आदरणीय डॉक्टर मंजू शर्मा और बाकी सारे साथीगण जो बाहर से आए हैं और यहाँ के लोकल होस्ट, पहले तो मैं मैडम शर्मा का धन्यवाद दूंगा क्योंकि उन्हीं के इनविटेशन के कारण मैं यहाँ पे हूँ आपके सामने। इस मॉर्निंग सेशन में ऑलरेडी टोन सेट हो चुकी है, क्या एक्सपेक्टेशन है, क्या हम कर सकते हैं, क्या नहीं कर पाए या क्या करना चाहिए, ये सब कुछ नोन है फॉर ए लॉन्ग टाइम एक्चुअली। लेकिन पास्ट में जाने से फ़ायदा नहीं है, लेकिन रियलिटी सामने चाहिए। वी हैव टू बी रियलिस्टिक, ओनली देन वी कैन मेक ए प्लेज, वी कैन मेक ए एजेंडा। बायोमेडिकल रिसर्च कोई नया शब्द नहीं है, आई थिंक 100 साल से करीब से ज़्यादा से यूज़ हो रहा है ये। कभी हेल्थ रिसर्च, बायोमेडिकल रिसर्च, सभी वही टर्म्स हैं विच आर एक्सपेंडिंग। एक डेफिनेशन जो बहुत पुरानी सब्जेक्ट दिखती है इंटरनेशनल एजेंसीज़ के उनके फ्रेमवर्क्स के अंदर, बड़े ऑर्गेनाइजेशन के अंदर, इट इन्वॉल्व्स द फोकस इज ए डिजीज़ एक्चुअली। डिजीज़ की प्रोसेस की इन्वेस्टिगेशन, और वो इन्वेस्टिगेशंस चाहे वो ऑब्जर्वेशंस के ऊपर हों, लेबॉर्ट्री वर्क से हों, एक्सपेरिमेंटेशन पे हों, एंड अल्टीमेटली यू कंक्लूड समथिंग। तो जैसे मैडम शर्मा कह रही थी कि वो एवरीथिंग स्टार्ट्स विद द डिस्ट्रीब्यूशन डिटर्मिनेंट्स ऑफ ए डिजीज़ एक्चुअली, द एपिडेमियोलॉजी, द डिस्क्रिप्टिव एपिडेमियोलॉजी। कहाँ हो रहा है, कितना हो रहा है, कैसे हो रहा है, किस सीजन में हो रहा है, कितने लोग प्रभावित हैं, एंड देन अल्टीमेटली सिम्टमेटोलॉजी क्या है, क्या डायग्नोसिस के चैलेंज क्या हैं क्लिनिशियंस के सामने, और उसके बाद पेरिफेरी में, जो पब्लिक हेल्थ में आप जाओगे तो क्या करोगे आप वहाँ पे, डायग्नोसिस के लिए, ट्रीटमेंट के लिए, प्रिवेंशन के लिए। सो अल्टीमेटली ये बड़ी कॉमन सेंस वाली चीज़ें थी जो इवॉल्व हुई हैं ओवर ए पीरियड ऑफ टाइम। लेकिन धीरे धीरे जब हम देखें पुराना इतिहास, तब से भी एंशियंट टाइम्स के साथ डिजीज़, चाहे वो जेनेटिक थी, इन्फेक्शियस थी, वो लोगों ने ऑब्जर्वेशन से डिटर्मिन की हैं। धीरे धीरे माइक्रोबायोलॉजी बाद में आई, पैथोलॉजी आई, बाकी डिसिप्लिन्स आए जो सेल्फ कर रहे हैं, आज जीनोमिक्स मदद कर रही है उसकी। लेकिन ऑल हैज स्टार्टेड विद द ऑब्जर्वेशंस, एंड दोज ऑब्जर्वेशन नीड नॉट बी हैव बीन डन बाय द क्लिनिशियंस एक्चुअली, नॉट बाय द मेडिकल पीपल। कोलोरा का सब कुछ जानने वाला वकील था एक, ही वाज अ लॉयर, ही कुड फाइंड द सोर्सेज, कहाँ किस टैप से चल रहा है, कहाँ से चल रहा है, क्यों चल रहा है, कैसे लोग स्प्रेड किए। तो बेसिकली ये प्रिंसिपल्स हैं, जो प्रिंसिपल्स हर कोई फॉलो करे, हर कोई समझे, देन ओनली यू कैन बिल्ड ए मूवमेंट एक्चुअली। ICMR 1911 में क्रिएट हुई इस कंट्री के अंदर, उसका गोल था कि टू बी एन एपेक्स एजेंसी फॉर बायोमेडिकल रिसर्च। उसके शुरू के जो ब्रिटिश एक्ट ऑफ पार्लियामेंट से उधर MRC का स्टार्ट हुआ, ब्रिटिश रिसर्च फंड एसोसिएशन, और इधर इंडियन रिसर्च फंड एसोसिएशन, दोनों के अंदर एक ही गोल था, 3 लाइनें थी। अब वो चलते चलते कितने बायोमेडिकल रिसर्च में क्या कर पाए वो सब आपके सामने है, लेकिन DST, DBT, CSIR, DRDO, बहुत सारी साइंस एजेंसीज है जो उन्होंने सिलेक्टेड एरियाज को डील करा है और उन्हें काफ़ी कंट्रीब्यूट भी किया है। आई जस्ट टॉक अबाउट दैट लिटिल बिट। लेकिन आप पूरे पिछले पास्ट को देखें तो 90% के अंदर हमारी कॉम्प्रिहेंसिव अप्रोच नहीं है। वी आर नॉट टारगेटिंग ए डिजीज, वी जस्ट टारगेटिंग ए स्मॉल कंपोनेंट जो हमको इंटरेस्ट करता है। गुजरात देश का एक अभिन्न हिस्सा है, समस्याएं कॉमन हैं, लेकिन कुछ स्पेशल हैं। जैसे क्रिमियन कॉन्गो हेमरेजिक फीवर का मैंने उदाहरण दिया, अभी तक गुजरात के अंदर ही है, थोड़ा सा पेरिफेरी में पहुंचा है, लेकिन गुजरात स्पेसिफिक इशू है ये। कैसे ब्लास्ट की तरह फैलेगा, कब फैलेगा, नहीं फैलेगा, हमको नहीं मालूम, लेकिन आप लोगों की अलर्टनेस से ही जल्दी पिकअप होकर कंटिन्यू हो पाया। अब उसको आगे क्या करना है आपने, उसके ऊपर क्या उसके लीडर बनना है या नहीं बनना है उसकी साइंस के लिए, वो आपके ऊपर है, लेकिन बाकी समस्याएं कॉमन हैं। सो दैट मीन्स व्हेन यू लुक एट दी गुजरात, आपको कंट्री की स्ट्रेंथ्स देखनी है, कंट्री की अपॉर्चुनिटीज देखनी है, गुजरात की स्ट्रेंथ्स देखनी है, गुजरात की अपॉर्चुनिटीज देखनी है। तो दोनों चीज़ों को आप अलग नहीं कर सकते। तो मैंने जब मैडम शर्मा के फ़ोन आने के बाद जो अपनी विचारों को थोड़ा केंद्रित किया, इन्हीं के राउंड किया, क्योंकि जब हम कोई डिटर्मिनेशन के साथ स्टार्ट कर रहे हैं तो वी हैव टू बी रियलिस्टिक, एक्चुअली वी हैव टू अंडरस्टैंड वेयर वी स्टैंड, दोनों तरफ पे, गुजरात स्पेसिफिक भी और इंडिया स्पेसिफिक भी। अब देखिए, जब इंडिया के ट्रांसफॉर्मेशन की बात आती है, पार्टिकुलरली आज़ादी के बाद, इंडिया एक सक्सेस स्टोरी है। हमारी डिफ़िकल्टीज़ हैं, हेल्थ में भी हैं, लेकिन वी आर ए सक्सेस स्टोरी। बहुत सारी इशू है आजकल इक्विटेबल डिस्ट्रीब्यूशन ऑफ सर्विसेज का, क्योंकि वही मेडिकल नॉलेज, उसी मेडिकल नॉलेज की अप्रोप्रिएट यूज़ के बाद बहुत सारे हमारे राज्य जो हैं उन्होंने 20 साल पहले यूरोप के बराबर के अपने हेल्थ इंडिकेटर्स अचीव कर लिए। तो नथिंग रॉन्ग विद द टेक्नोलॉजी, नथिंग रॉन्ग विद द नॉलेज, इट वाज द अप्रोप्रिएट यूज़ ऑफ द नॉलेज बाय आवर ओन मेडिकल पीपल, पब्लिक हेल्थ पीपल एंड द पॉलिटिशियंस एंड दैट स्टेट्स, बैक्ड बाय ब्यूरोक्रेसी, जो कामयाबी मिल चुकी। कुछ जगह नहीं मिली, आई थिंक क्यों नहीं मिली वही बात हमको देखनी है। गुजरात सक्सेस स्टोरीज के अंदर है, लेकिन गुजरात के चैलेंज भी हम सबको पता है, रियलिस्टिक होना आवश्यक है। अब बात आती है कि रिसर्च करनी क्यों है। बेसिकली इज टू इनोवेट, एक्चुअली इनोवेट, बेटर डायग्नोसिस, बेटर ट्रीटमेंट एंड बेटर प्रिवेंशन, तीनों गोल हैं। अब उसमें चाहे सुश्रुत चरक के ज़माने से आप ले लें इतिहास हमारा, और उसके लिए बेस्ट बुक्स जो हैं, अगेन एक एलोपैथ ने लिखी हैं, प्रोफेसर वेलियाथन ने, वन ऑफ द मोस्ट रिनाउंड कार्डिक सर्जन्स ऑफ रिसेंट ईयर्स, और इनोवेटर भी रहा वो। तो उन्हीं ने ये जो सुश्रुत और चरक के जो एनालिसिस की, उनके डेटा की, उनके नॉलेज की, उनके जो पब्लिकेशंस की, एंड दे टेल द स्ट्रेंथ्स एक्चुअली। और आप उन किताबों को पढ़िए, 700, 800 पेजेस की, उनके जो अंदर के बीच के जो समरीज हैं उन्होंने बनाई है प्रोफेसर वेलियाथन ने, वो किसी भी मेडिकल आदमी को एनालिटिकल एनालिसिस करने में मदद करती हैं। तो क्या दिखाती हैं कि नॉलेज के लिए बहुत बड़ी बड़ी लेबॉर्ट्रियाँ बनाना आवश्यक नहीं है। ये आपकी ऑब्जर्वेशन है क्लिनिशियंस की। आज से कुछ साल पहले तक के भी, अब मैं 60-70s तक जाता हूँ, 50s, 60s, 70s, हमारे मेडिकल कॉलेजेस, साधारण मेडिकल कॉलेज, लेबॉर्ट्री में कुछ माइक्रोस्कोप, छोटा सा एक मोनोक्लो माइक्रोस्कोप होगा, उसके बल के बावजूद वहाँ के न्यूरोसर्जन्स, वहाँ के दूसरे फिजिशियंस, पैथोलॉजिस्ट अच्छी अच्छी ऑब्जर्वेशन छापते थे, और उनकी वजह से बहुत सारी बीमारियाँ कंटेन भी हो गई। तो लेकिन धीरे धीरे वो क्यों डाई आउट हो गया, अब क्या करना है उसके लिए, उस चीज़ों पे मैं थोड़े रिफ्लेक्शन दूंगा आपको अभी। लेकिन हमारे 69 ईयर्स, 70 ईयर्स बीत गए, हम नहीं कर पाए कुछ भी। हम कहते हैं अंग्रेज कर गए, अभी पाकिस्तान को ब्लेम करते हैं, पहले अंग्रेजों को करते थे, लेकिन करने के बाद निकला तो कुछ नहीं। 70 साल बीतने के बाद क्यों नहीं चेंज हुआ हम? मान लो हमारे पास पॉवर्टी है, हमारे पॉपुलेशन के प्रेशर हैं, डिजीज़ का बर्डन है, लेकिन ऑब्जर्वेशंस, साइंस की एनालिसिस तो कर सकते हैं। उसके लिए तो हर जगह के लिए लेबॉर्ट्रियाँ बनाना आवश्यक नहीं है शुरू में। कारण यही है, हमने अपना सारा एनर्जी वेस्ट को फॉलो करने में लगा दी। 99.9% वी आर फॉलोअर्स। हम उन्हीं की तरह चलना चाहते हैं, उन्हीं की तरह कॉपी बनना चाहते हैं, और उन्हीं की तरह जब वो कुछ करते हैं वो रिप्रोड्यूस करके दिखा देते हैं या नहीं करा देते कि नहीं चल रहा है, ठीक है, दैट्स इट। हम इंटरनेशनल बैनर के अंदर काम करने में हमारी प्रतिबद्धता है, हमारा दिमाग है, वो सभी देश का है, दैट्स नथिंग टू पेक्यूलियर टू गुजरात, बट ये माइंडसेट के अंदर, इशू के अंदर आता है। अब हमारे एक बात बनती है कि सक्सेस स्टोरी में देखिए, ये फार्मास्यूटिकल्स में हम दुनिया में 2nd नंबर पे हैं। बेस्ट मेडिसिन, बेस्ट वैक्सीन्स यहीं से प्रोड्यूस होकर सारी दुनिया में जाती हैं। गुजरात की भी इसमें कंट्रीब्यूशन है। लेकिन 2 हिस्से जो हैं, जैसे डायग्नोस्टिक्स बहुत सारे आए हैं, डीबीटी की मदद से, दूसरी की मदद से रिसेंट ईयर्स में आए हैं, लेकिन टोटल मार्केट के अंदर हमारा बहुत छोटा शेयर है। माइक्रो डिवाइसेस, मेडिकल इक्विपमेंट्स के अंदर बहुत छोटा सा है। जो प्रोफेसर बलराम भार्गव बोलेंगे अपने बारे में, आई डोंट नो उसकी इशू के भी शायद कमेंट करेंगे, वेरी निग्लिजिबल प्रेजेंस देयर एक्चुअली, जो हो सकती थी। हमारे नए प्रधानमंत्री, अब नए तो नहीं रहे, अब 2 साल पुराने हो गए, इनका जो पहली मीटिंग थी, इन्होंने भी उसी की चीज़ के ऊपर पूछा सबको। इट वॉज वन ऑफ पार्ट ऑफ हिज आइडिया, ड्रीम्स एक्चुअली, कि इसमें हम, हमारी डोमिनेंस क्यों नहीं है, इसमें हम क्यों नहीं छा सकते। तो इशू पैदा होता है, साफ है कि नहीं प्रयत्न किया गया उतना। उसके लिए बहुत सारी दिक्कतें हैं एक्चुअली बीच में, जिनको लांघने की कोशिश नहीं की गई, बेसिकली लैक ऑफ डिटर्मिनेशन। अब बात आती है, क्या हमने किया है कुछ नहीं इस पीरियड में? ये गलत है टोटली। हमारे पार्टिकुलर क्लिनिशियंस, उनकी बहुत सारे उनके नॉलेज है, यहाँ से जनरेट हुआ इस इन सालों में भी। ट्यूबरकुलोसिस के कंसेप्ट, लेप्रोसी के थेरेपी के कंसेप्ट्स, बहुत सारे मेडिसिन, सर्जरी के पार्टिकुलरली इन्यूमरेबल डिस्कवरीज। शिरोधकर टैंक से लेकर छोटी सी चीज़ थी, सर्वाइकल इनकॉम्पिटेंस, सबकी अबॉर्शन थर्ड ट्राइमेस्टर का एक धागा बांधने से वो ठीक हो गया। दुनिया को नहीं समझ आ रहा था पहले वो धागा बांधना। शिरोधकर साहब के दिमाग से बात आई है। प्रोफेसर पी के सेठी का ले लीजिए, प्रोफेसर टंडन का एग्जाम्पल लीजिए, उन्होंने न्यूरोट्यूबरकुलोसिस के जो पब्लिकेशन 60s के हैं उनके। तो आपके पास बहुत सारे, अभी भी आज के लिए किसी भी सब्जेक्ट है, सर्जिकल डिसिप्लिन में पर्टिकुलरली, हमारे सर्जन्स आर देयर इन द फोर फ्रंट ऑफ इनोवेटिंग प्रोसीजर्स। हर साल खुद निकलते हैं यहाँ से, लेकिन वो हमारे नाम पे नहीं चलते, क्योंकि एज ए कंट्री वी नेवर बिहेव एज ए कंट्री एक्चुअली। एक दूसरे को खींचने में व्यस्त, डाउन किया, लेकिन रेफरेंस फॉरेन वाले का साइड करेंगे। सो दोज आर द थिंग्स, दोज आर माइंड सेट इशूज विच अगेन, यहाँ जब गुजरात में रिवाइवल की बात करेंगे हम, मेडिकल कॉलेजेस की, तो ये मन में रखनी पड़ेगी कि यू विल हैव टू बिहेव एज ए ग्रुप, एज ए इंडिविजुअल्स कोई फायदा नहीं है। अब बात आती है कि जब चलो हमने ठान ली कि करेंगे कुछ, ट्रांसलेट करेंगे, पहले नॉलेज जनरेट करेंगे एपिडेमियोलॉजी का, क्लिनिकल का, एल्गोरिदम बनाएंगे, फिर कुछ चीज़ों को लेके हम बनाएंगे, कुछ प्रोडक्ट बनाएंगे, अप्लायंस बनाएंगे, कोई डायग्नोस्टिक बनाएंगे, कोई थेरेप्यूटिक बनाएंगे। तो उसके लिए बहुत सारे स्टेप्स हैं। ड्रीम है सबका ये। हम जब भी किसी भाषण को सुने, किसी राजनीतिज्ञ के, किसी अच्छे टॉप साइंटिस्ट के, ब्यूरोक्रेट के, बोलते हैं सब ये की बात, लैंग्वेज एक ही है सभी की, और एस्पायरेशन भी है बहुतों की, लेकिन इतनी सारी एजेंसीज की बैकिंग है उसमें, डीएसटी की, डीबीटी की, सीएसआईआर की, आईसीएमआर डीएचआर की, डीआरडीओ की, आईसीआर की, और मैंने बहुत सारे डिपार्टमेंट और लिखे हैं जो पार्टनर डिपार्टमेंट्स हैं, विच आर कंट्रीब्यूटिंग, स्पेस वाले, इंफॉर्मेशन टेक्नोलॉजी वाले, वुमेन चाइल्ड वाले, एनवायरमेंट फॉरेस्ट वाले। लेकिन अल्टीमेटली ना उतना नहीं कर पाए हम लोग। क्यों नहीं कर पाए? उन पर थोड़ी सी मैं, आई जस्ट मेक ए ब्रीफ कमेंट ऑन देम। आईसीएमआर में हमने ये कोशिश की। आईसीएमआर से पहले डीबीटी में काफ़ी ये मोमेंटम गेन का हो चुका था, लेकिन आईसीएमआर के सारे इंस्टीट्यूशन आर वर्किंग फॉर द बायोमेडिकल रिसर्च, लोगों के साथ हैं। तो हमने सोचा भाई आप इतना हर चीज़ क्लेम करते हैं, लोगों को क्या मिला? आपके नॉलेज से सर्वे हो गए खूब सारे, डिजीज बर्डन पता लगे, लोगों को क्या मिला? दैट वाज माय फेवरेट क्वेश्चन आफ्टर 2 वीक्स ऑफ माय एजम्पशन ऑफ ऑफिस। आई सेड, लोग रिस्पॉन्ड किए। 26 इंस्टीट्यूशन में हमने इनकी यूनिट्स बनाई परमानेंट, दे स्टार्टेड फंक्शनिंग ऑल्सो, हेडक्वार्टर में भी किया। हमने 102 लीड्स आइडेंटिफाई किया, उसमें कुछ इसमें 10 नए टारगेट भी थे। अब उन सभी के सभी में से हमने 52 को परसू किया। इनकी 5 साल परसू करने में से 20 रेडी हो गई, 8 रिलीज हो गए मेरे पीरियड में भी, तो अनदर डजन तैयार थे। क्वेश्चन व्हाट इट टेल्स, अगर 20 आउट ऑफ 52 बन के लोगों को तैयार हो के रिलीज भी हो गए, कंपनियों को भी कई चले गए इसमें, जो 8 दिन की मैं बात कर रहा हूँ, और कुल 100 करोड़ से कम। इट्स टेल्स पीपल आर रेडी, उनको वो ड्राइव नहीं दी गई। तो मेडिकल कॉलेजेस की जो फेलोर है, मैं उसमें मेडिकल कॉलेजेस को ब्लेम नहीं करता। मेरी एनालिसिस इट इज़ अ सेंट्रल फेलोर एक्चुअली। उसके ऊपर मैं कई किताबें भी लिखूंगा अपने बात, कैसे सक्सेसिव लीडर्स इन द टॉप दे हैव इग्नोर्ड दैट। उन्होंने मेडिकल कॉलेजेस को हाशिए पे पहुंचा दिया, नोइंगली अननोइंगली। लेकिन छोड़ो, इस बात का कहने से कोई फायदा नहीं है। अब आती है कि ICMR के बाद CSIR की बहुत सारी स्ट्रेंथ्स हैं, ट्यूबरकुलोसिस, मलेरिया, लिशमेनियासिस, डायबिटीज मेलाइटिस। और जो प्रेजेंट महानिदेशक हैं CSIR के, उन्होंने खुद क्लॉटबस्टर्स प्रोड्यूस किए हैं जो 2-3 साल के अंदर ग्लोबल मार्केट में छा जाएंगे। CSIR का टॉक्सिकोलॉजी, फाइटोमेडिसिन, फर्टिलिटी कंट्रोल, सब में रोल है। OSDD में भी रोल है, जो इसके बारे में प्रोग्राम बारे में लोगों ने सुना होगा। इट इज समथिंग वेरी इनोवेटिव प्रोग्राम। दे मे बी क्रिटिक्स ऑफ द प्रोग्राम, बट इट इज ऑलरेडी लेड टू द प्रोडक्ट्स विच आर इन द क्लिनिकल ट्रायल्स। DBT इस पीरियड का सबसे सक्सेसफुल डिपार्टमेंट रहा है रिसेंट ईयर्स का, और DRDO को छोड़ के इनका मेजर इम्पैक्ट है इसके ऊपर, हेल्थ केयर के ऊपर भी। सेवरल डायग्नोस्टिक्स, वैक्सीन्स, आप देख लीजिए, हेल्थ केयर प्रोडक्ट्स DBT की मदद से निकले हैं आगे, HIV से लेकर दूसरों एरियाज तक, टाइफॉइड में, सब में। ट्रांसलेशन हेल्थ रिसर्च इंस्टीट्यूट जो है, इससे दिशा परिवर्तन हुई है। सिवरी प्रोग्राम, इसका बड़ा इम्पैक्ट है इस वक्त। DBT के स्पेसिफिक इंस्टीट्यूशंस हैं, जीनोमिक्स के, स्टेम सेल के, जेनेटिक इंजीनियरिंग के, इम्यूनोलॉजी के, डायग्नोस्टिक्स के, जिसका आई थिंक मोस्ट ऑफ यू मेडिकल स्टूडेंट्स एंड मेडिकल जो टीचर आज आए हैं उन्होंने पढ़ा उनके बारे में। बट they are very important partners if you want to move on. You don't have to create your institutions, they are already existing actually. DST का भी एक important role है जो मैं सभी के मन में डालना चाहूँगा particularly. जब आप basic science शुरू करें कुछ, तो DST is the agency to catch upon. मेरे अपने कैरियर में वही किया बरसों पहले शुरू की सारी basic research was funded by DST. बाद में applied research, फिर वो जब मैडम सेक्रेटरी थी उसके बाद DBT का मेन रोल रहा उसमें। लेकिन DST इज द कोर एजेंसी जहाँ पे आज भी आप when you have a new idea there is a first place to start with। और साथ में नैनो टेक्नोलॉजी जैसे एरिया में भी उनका मेजर शेयर है। DRDO एक महत्वपूर्ण पार्टनर है एक्चुअली, और लाइफ साइंसेज में भी, नॉट ओनली डिफेंस। DRDO कंटिन्यूज टू वर्क टुवर्ड्स द सेल्फ रिलायंस इन द हेल्थ सेक्टर ऑल्सो। ट्रुप्स उनका मेन कोर बिंदु है, लेकिन ट्रुप्स को छोड़ के उनके बहुत सारे जो स्पिन ऑफ टेक्नोलॉजीज हैं, वुंड हीलिंग में, ये वाले हीट कोल्ड स्ट्रेस मैनेजमेंट में, पॉइजनिंग मैनेजमेंट में, बहुत सारे हैं। देवर अबाउट 45, बिफोर आई लेट ऑन द ऑफिस, हमने उनको 45 टेक्नोलॉजी जो बनी है यूज़ कर रहे हैं ट्रुप्स के अंदर, उनको ताकि उनको कैसे लाइसेंस मिलें, कैसे उनके क्लिनिकल ट्रायल हों, लोगों तक पहुँचे। दे आर देयर। सो आई थिंक एंड DRDO फंड्स रिसर्च एक्स्ट्रामुरली। हमारे ऑलमोस्ट ICMR के सभी इंस्टीट्यूशन में 1-2 प्रोजेक्ट उनके चल रहे होंगे इस वक्त भी। सो DRDO इज ए इम्पॉर्टेंट फंडिंग एजेंसी फॉर लाइफ साइंसेज टू। ये बहुत सारी एजेंसियां जिनकी मैंने बात करी, अब इन सभी को कोऑर्डिनेट करने के लिए DHR जब क्रिएट हुआ, DHR को ICMR को छोड़ के 9 फंक्शन नहीं थे, उनमें इंटर सेक्टोरल कोऑर्डिनेशन इसका एक महत्वपूर्ण रोल है। पहले डॉक्टर भान उसके चेयरमैन थे, फिर रामास्वामी उसके चेयरमैन थे। इस वक्त मुझे नहीं मालूम कौन उसका चेयरपर्सन है, लेकिन वो सारे डिपार्टमेंट्स जो 10 के 10 साइंस एजेंसीज हेल्थ को फंड कर रही हैं, उनको उनका इंटर सेक्टोरल कोऑर्डिनेशन का जिम्मा है वहाँ पे, और बहुत सारे कॉमन प्रोग्राम निकले हैं। तो आप अगर इंटर सेक्टोरल हिस्से पे काम करना चाहेंगे, देन यू कैन एक्सप्लोर दीज एवेन्यूज। जैसे कि जूनोसिस का प्रोग्राम ICMR ICR का जॉइंटली फंडेड प्रोग्राम है। फूड सेफ्टी का प्रोग्राम अगेन ICMR ICR का जॉइंट फंडेड प्रोग्राम है, पेस्टिसाइड्स के ऊपर भी। तो आप उन एजेंसीज को टैप करिए जिनमें इस तरह के प्रोग्राम चल रहे हैं। मैडम शर्मा ने एक बात रखी अभी आपके सामने, अब जब यहाँ से आप स्टार्ट करेंगे, ह्यूमन रिसोर्स है सबसे क्रिटिकल फैक्टर। बिल्डिंगें बनाना, लेबॉर्ट्री बनाना, जो उनके कमांड से आई थिंक शी पुट इन ए वेरी अप्रोप्रिएट लैंग्वेज, वो ही कोर बिंदु है। इंसान नहीं है काम करने वाले तो कुछ कर नहीं सकते। हमने आज फंडिंग क्रंच चारों तरफ एजेंसी में दिख रहा है, क्योंकि इकोनॉमी में फॉर ए वाइल स्लो डाउन आया, लेकिन जब पैसे सरप्लस में भी थे तो करने वाले नहीं थे। जब थे तो पैसा नहीं था, आइदर वे इट गोज ऑन। तो ये वाला बात जो है, लेकिन आज भी काम करने वाले नहीं हैं जो इंटरसेक्टरल बात समझते हैं। किसी को बायोकेमिस्ट्री अच्छी आती है, किसी को इम्यूनोलॉजी अच्छी आती है, किसी को अपनी क्लिनिकल सब्जेक्ट अच्छा आता है, किसी को सर्जरी अच्छी आती है। तो जो इंटरसेक्टरल इंटरडिसिप्लिनरी काम करने वाले कम हैं हमारे पास। तो आपको जो कोर बिंदु खड़ा करना है यहाँ पे अभी भी गुजरात के अंदर, वो आपको इंटरडिसिप्लिनरी टीमें बनानी है। आई थिंक इसके ऊपर सारे जो एम्स के स्पीकर भी आए हैं, सब लोग थोड़ा थोड़ा बोलेंगे, क्योंकि इन्होंने क्रिएट किया है सब कुछ। तो इंटरडिसिप्लिनरी टीमें बनाना ही और लोग तैयार करना ही बड़ा कोर बिंदु है, और उसमें कि मेडिकल लोग उसके अंदर शामिल हों। मेडिकल कॉलेज की फैकल्टी उसके अंदर एक कोर स्ट्रक्चर के रूप में चाहिए। आज क्या बात आती है, नॉर्मली हम कहते हैं मेडिकल कॉलेज वाले इंटरेस्ट नहीं ले रहे, संभव कोशिश नहीं किया गया, और 30 साल के पीरियड में रिसर्च उनकी हैबिट में नहीं रही। लेकिन आज वो वापस है एक्चुअली। आज मेडिकल कॉलेज से जब बात आ रही थी, मैं 2015 में 3000 प्रोजेक्ट्स थे जो इस वक्त किसी कारण थोड़े लटक गए। तो ये नहीं है कि वहाँ पे काम करने वाले नहीं हैं, आप में भी खूब सारे प्रोजेक्ट लिखेंगे आप तो, लेकिन वो इंटरसेक्टरल चाहिए, वो सारे इंटरडिसिप्लिनरी चाहिए, किसी समस्या का समाधान करके कुछ लोगों को देने के लिए चाहिए, नॉट फॉर क्यूरियोसिटी। आई थिंक ये वाली जो चीज़ है ये करना आवश्यक है। जो मैं लास्ट की लाइन बता रहा हूँ कि डेवलपिंग न्यू टूल्स जो लोगों को बेनिफिट करें, जिस वही उसी पे पैसा भी आएगा, इकोनॉमिक प्रॉस्पेरिटी भी उसी के अराउंड है। आई थिंक वो वाला कोर बिंदु चाहिए। आई थिंक ऑल साइंस डिपार्टमेंट्स, यूजीसी, एमएचआरडी, सभी को इसी के ऊपर देखना है, पर स्टेट आर द कोर, सो दे हैव टू लुक एट दैट। नेशनल स्टेज पे कुछ प्रॉब्लम्स हैं जो आप सभी को झेलेंगे। आप कुछ बनाएंगे तो पहला माइंडसेट को झेलेंगे, बिकॉज हम हर चीज़ फॉरेन की तरफ दौड़ते हैं। इंपोर्टेड लेंस, इंपोर्टेड आदमी, इंपोर्टेड सब कुछ, इंपोर्टेड जर्नल, इंपोर्टेड बुक। तो हमारी मानसिकता अभी बदली नहीं है, उसको आप झेलेंगे जब कुछ नया बनाएंगे। तो आपकी रिसर्च भी उसको देखनी पड़ेगी कि कैसे लोगों को एक्सेप्टेबल बनाना है, उसके लिए कैसा मीडिया ब्लेड चाहिए, मीडिया का कैसे आप लोगों का माइंड ट्विस्ट करेंगे, लोगों को कैसे समझाएंगे। सो मार्केट रिसर्च, सोशियो बिहेवियरल रिसर्च, टू मेक यू टू थिंक, टू पॉपुलराइज योर टेक्नोलॉजीज, दैट विल बी वेरी वाइटल। बहुत ही महत्वपूर्ण है वो बात। रेगुलेटरी स्ट्रक्चर इम्प्रूव्ड है आज बहुत सारी, लेकिन उतनी फ्रेंडली नहीं है जितना होना चाहिए। आप पुश करेंगे तो और फ्रेंडली होगी, क्योंकि इज अ पब्लिक प्रेशर। टेस्टिंग के लेबॉर्ट्रियाँ बहुत कम है, यू कैन क्रिएट सम, यू कैन मेक देम यूज। क्लिनिकल ट्रायल्स के लिए सब्सटेंशियल फंडिंग इस कंट्री में नहीं मिल पाती, लेकिन अगर आप करेंगे तो कहीं ना कहीं से निकल आती है। तो इनएडुकेटेड फंडिंग वर्तमान की थोड़ी समस्या है, बट इट्स नॉट एटर्नल स्टोरी एट ऑल। बहुत साइंस एजेंसीज ने अपने टाइम से खूब फंड किया है और बहुत सारा यूज़ नहीं हो पाया टाइम से, बिकॉज पीपल वर नॉट देयर। तो ये आई थिंक यू हैव टू डोंट वरी अबाउट दैट पार्ट। अब बात रही एक और चीज़ की, जो पॉजिटिव डेवलपमेंट्स हैं। अब हमारे पास हमने डेडिकेटेड इंस्टीट्यूशंस खड़े हुए, मेडिकल कॉलेजेस के अंदर स्ट्रक्चर बनाने की कोशिश की है काफ़ी, जिसके बारे में थोड़ा सा मैं बोलूँगा। पॉलिटिकल कमिटमेंट की बात आती है। जब भी चैलेंज लिया किसी चीज़ के लिए, चाहे H1N1 की बात आई, उसके लिए वैक्सीन्स बनाने की बात आई, डायग्नोस्टिक्स की बात आई, दूसरी भी किसी चीज़ के लिए जब भी चैलेंज दिया गया, इट्स ऑलमोस्ट 100% सक्सेस। सो व्हाट इट टेल्स, इफ वी गिव ए कॉल, पीपल आर रेडी। वी जस्ट डोंट गिव ए कॉल। हम ब्लेम करके निकल जाते हैं ऊपर से, हम हमारे कुर्सियों पर बैठने वाले लोग, लेकिन कॉल नहीं देते, पीछे नहीं लगते किसी के पीछे, और बनाने की कोशिश नहीं करते। मार्केट डिमांड्स के ऊपर छोड़ देते हैं हम। वैसे मार्केट डिमांड से कंट्री नहीं चेंज होगा, लेकिन यहाँ की जो जैसे आज माहौल है उससे साफ दिखता है कि बदल सकता है। अब बात आई थी जैसे मैडम शर्मा ने जो इंट्रोड्यूस की बात, जिस कारण आई थिंक मेरे से थोड़े मुझे इस पर मैं कमेंट करूँगा। ये बड़ा इंटरेस्टिंग थी सारी बात। प्रोफेसर टंडन इसके ड्राइवर रहे हैं। प्रोफेसर टंडन ने मेरे सेक्रेटरी के इंटरव्यू में क्वेश्चन पूछा कि अगर ये नया डिपार्टमेंट बना है, सेक्रेटरी बनोगे तो क्या करेंगे। मैंने कहा सर मैं मेडिकल कॉलेजेस को मेन स्ट्रीम में लाऊंगा, एक ही मेरी पहला सेंटेंस था। तो बोले यार सब ने बोला, ये इतने सालों से मैं सुन रहा, किसी ने कुछ नहीं किया। तो मैंने कहा सर नहीं, आप मुझे बनाइए, मैं करूँगा। बोले अच्छा क्या करोगे। मैं कहा सर मैं कम से कम 50 यूनिट्स मेडिकल कॉलेजेस में मल्टी डिसिप्लिनरी बनाऊँगा। बोले अच्छा ठीक है। तो जब मैं बन गया तो मेरी किस्म से वो मेरा सिलेक्शन मैनिफेस्टो बन गया। फिर मैंने कहा सर अब आपको मदद करनी है, आप ही को ये कमेटी चेयर करनी है और हमको ये प्रोसेस स्टार्ट करनी है। दैट that was the trigger and that was a push for which आई विल ऑलवेज रिमेंबर हिम। और उसके बाद भी उन्होंने उसको सिंसियरली पूरी मदद की मेरी इस कैंपेन को एंड तक ले जाने की, बहुत एनर्जी लगाई प्रोफेसर टंडन ने, उनका विजन है इसके अंदर। तो पहली मल्टी डिसिप्लिनरी रिसर्च यूनिट्स जो आई 80 अप्रूव हुई जिनका गवर्नमेंट से। मैं सारे मेडिकल कॉलेज में चाहता था, लेकिन लोगों का विश्वास नहीं है। सारे प्लानिंग कमीशन, मिनिस्ट्री ऑफ फाइनेंस सब बार बार घुमा के वापस भेज देते, कहते ये कुछ नहीं करेंगे, प्रैक्टिस में खोए हुए लोग हैं। हमने कहा यार ये नहीं करेंगे तो कौन करेगा, कितने एम्स बनाओगे, कितने इंस्टीट्यूशन बनाओगे आप, क्योंकि कुछ इंस्टीट्यूशन खड़े होने से 120 करोड़ लोगों की समस्या आप नहीं सॉल्व कर सकते। बट एंड में आई थिंक गवर्नमेंट कन्विंस हुई तो 80 बनाने की उन्होंने परमिशन दी। फिर दूसरी जो थी मल्टी डिसिप्लिनरी रिसर्च यूनिट, जो पहली जो है मल्टी डिसिप्लिनरी रिसर्च यूनिट्स, इंटरसेक्टोरल लेबोरेटरियाँ बनाने की योजना है। यू क्रिएट इन योर इंस्टीट्यूशंस इंटर डिपार्टमेंटल यूनिट्स, ग्रुप्स, which prepare projects, which send those projects to different agencies. तो कोर एरिया बनाने का ये फोकस है पहला। लेकिन NCDs इसका मेन आधार है, कम्युनिकेबल डिजीज वहाँ पे नहीं रखी। दूसरी यूनिट बनी है, एक घाटमपुर का एग्जाम्पल था जो अगेन DBT फंडेड था। DBT ने मैडम के टाइम में ही एपिडेमियोलॉजी स्टडीज फंड करी। ICMR के इंस्टीट्यूट आगरा में, हमारी वाइफ उसकी PI थी, तो वो वाले लेप्रेसी के ऊपर, ट्यूबरकुलोसिस के ऊपर, दूसरे डिसऑर्डर्स के ऊपर, those epidemiological studies, and then the 3 institutions working together, ICMR का इंस्टीट्यूट, मेडिकल कॉलेज और स्टेट सर्विस। इट शोड ए मॉडल कि आप इकट्ठे मिलकर जब काम करते हो तो मोस्ट एडवांस टेक्नोलॉजीज कैन गो टू द पीपल वेरी क्विकली। तो उसके 10 साल के शुरू की फंडिंग से DBT की, ICMR की, WHO की, कई एजेंसियों की फंडिंग थी, एक मॉडल यूनिट क्रिएट हुई। इट इवॉल्व्ड, बीमारियां 98% नीचे आई वहां पे। सो इट शोड ए मॉडल ऑफ इंटरवेंशंस। इंटरनेशनली बहुत ब्यूटीफुल पेपर छपे। तो साइंस फॉर द पीपल, टेकिंग द टेक्नोलॉजी टू द पीपल, तो एक मॉडल क्रिएट हो गया। और उसमें से 15 जब यूनिट ये अप्रूव हुई स्कीम, तो क्या सिर्फ 15 राज्यों में करो, अगेन अविश्वास कि ये करेंगे नहीं लोग। अब तीसरी बात आई थी नेटवर्क ऑफ वायरल लेबोरेटरीज। तो वायरल रिसर्च जो है NIB, NCDC के अराउंड, NCDC सर्विलेंस, NIB अपना कुछ करता रहता है जब कोई समस्या आती है, लेकिन हर बार कहीं समस्या हो तो उनको बुलाओ, हर बार कहीं समस्या हो तो वहाँ भागो। आई थिंक इट इज नॉट डूएबल एक्चुअली। तो ये वाली स्कीम आई जिसके अंदर 160 यूनिट्स, 10 रीजनल सेंटर जो हमेशा भारत सरकार के होंगे, जो सेक्टर यूनिट है मॉडल रूरल रिसर्च सेंटर, ये हमेशा ही गवर्नमेंट ऑफ इंडिया की रहेगी, लेकिन इट्स लेड बाई स्टेट। पहली यूनिट्स जो हैं 5 साल विल बी लेड बाई दी सेंटर, बट आफ्टर दैट विल बी लेड बाई स्टेट एक्चुअली। सेंटर की कुछ इसमें प्रतिबद्धता रहेगी। उसके बाद वायरोलॉजी में पहले 10 रीजनल सेंटर्स हमेशा गवर्नमेंट ऑफ इंडिया के रहेंगे, 30 स्टेट के और 120 मेडिकल कॉलेजेस के आफ्टर 5 years they have to be transited to state medical institutions, जिसमें कि they are such targeted, they are not surveillance centers, they look at the clinical aspects, they look at the therapeutics, they look at the epidemiology, कि कोई नई चीज़ आ रही तो क्यों आ रही है, कैसे आ रही है। एंड आई थिंक मोस्ट लगभग 40 के करीब लास्ट में आई हैं लेबोरेटरी, ऑलरेडी 45, दे आर डूइंग वेरी वेल। इसके छोड़ के अब ये 255 लेबोरेटरीज क्रिएट करने का 3 स्कीम है, जिसमें से 115 मेरे टाइम में ही हो चुकी, अब कुछ और पाइपलाइन में चल रही हैं। 2017 तक सभी की सभी 255 आनी चाहिए, होपफुली आएंगी। अब ICMR के जो सेंटर सब आपको पता है, 33 इंस्टीट्यूशन है, जिसमें कि नई यहाँ पे है आपके पास 111 फील्ड स्टेशंस हैं। 13 यूनिट्स जो DHR की स्कीमों में है 255 में से, वो स्टेट ऑफ गुजरात के लिए हैं, उसमें से 4 आ चुकी हैं। 2 MP शाह मेडिकल कॉलेज जामनगर में, सूरत में ये MRUs, जो वायरोलॉजी रिसर्च की लेबोरेटरीज BJM यहाँ पे आ चुकी है स्टेट वाली, MP शाह अगेन जामनगर में। 9 अभी आनी है। वो आप लोगों के मेडिकल कॉलेजेस के ऊपर है कि कैसे किस स्पीड से पुश करते हैं, बट दे कैन, दे आर ऑल अप्रूव फॉर द स्टेट। अब गुजरात की जो चैलेंज हैं क्या है, लास्ट वेरी ब्रीफ रिमार्क्स एक्चुअली। देखिए गुजरात में आज भी एमिनेंट क्लिनिशियंस हैं बहुत सारे, हर एरिया के अंदर। बायोलॉजिस्ट भी मिल जाएंगे आपको, काफ़ी सारी लंबी लिस्ट है उसकी भी, पब्लिक हेल्थ स्पेशलिस्ट की लिस्ट भी लंबी है। लेकिन जैसे बाकी देश की हालत है, बायोमेडिकल रिसर्च की एजेंडा गुजरात में भी डिफ्यूज है। ये किसी इज नॉट विजिबली फोकस्ड ऑन सॉल्विंग क्लिनिकल प्रॉब्लम्स। एक अभी सिकल सेल की बात आती है, लेकिन बाकियों में बहुतों में कम में टारगेटेड है ये। रिसर्च नेटवर्क्स बहुत कम है, वेरी फ्यू, कोई 2-2 4-4 आदमी कहीं काम करने वाले बड़े आपको 5 में नहीं मिलते पूरे स्टेट के अंदर। मोस्ट ऑफ द कॉम्पिटिटिव मेडिकल प्रोफेशनल्स आर नॉट एमिंग एट रिसर्च ऑन सॉल्विंग प्रॉब्लम्स। उनको लगता है कि कोई प्रोसीजर निकालेंगे, कोई मेथड ऑफ इंटरवेंशन निकालेंगे, वो शॉर्ट टर्म गोल हैं, विच आर गुड, नथिंग रॉन्ग अबाउट देम, दे शुड बी देयर। लेकिन उससे कभी वो साइंस का लेवल ऊपर नहीं आएगा, उससे कभी वो परमानेंट इम्प्रिंट भी नहीं रहेगा उसके अंदर। गुजरात के पास 65 बायोमेडिकल फार्मास्यूटिकल रिसर्च इंस्टीट्यूशन है इसके अंदर। ये हमने सर्वे किया था पूरा 2012-13 में, और कुछ मैंने अपडेट किया इसको, तब 51 थे, अब 65 हैं, जिसमें ICMR का नेशनल इंस्टीट्यूट ऑफ ऑक्यूपेशनल हेल्थ यहाँ पे है। 20 मेडिकल कॉलेज हैं, 27 और दूसरे मेडिकल इंस्टीट्यूशन हैं, जो कोई आई पे है, किडनी पे है, एंडोक्राइनोलॉजी पे है, पब्लिक हेल्थ पे है, हेल्थ सिस्टम्स के ऊपर है, पूरी लिस्ट है मेरे पास उसकी। 12 एकेडमिक एंड इंडस्ट्री बेस्ड इंस्टीट्यूशन फार्मास्यूटिकल एलाइड साइंसेज के हैं। 6 यूनिवर्सिटीज हैं बायोमेडिकल रिसर्च में एक्टिव हैं। और लोगों का टेम्परामेंट कुछ करने का है यहाँ पे, लोग इकट्ठे मिलकर कर लेते हैं यहाँ पे काम। सक्सेसिव प्रोएक्टिव गवर्नमेंट्स नहीं है, आज भी हैं, कल भी थी। तो सवाल है कि ये सारे के सारे 65 इंस्टीट्यूशंस बायोमेडिकल में एक्टिव होना इज़ नॉट ए स्मॉल थिंग। 20 मेडिकल कॉलेज अब मान लो आज क्लिनिकल में हैं बहुत सारे, लेकिन वो रिसोर्स तो हैं, दे आर एसेंशियली बायोमेडिकल इंस्टीट्यूशंस, दे कैन बी इन एक्शन एनी टाइम। अब करें क्या इसकी बात? सबसे पहला इशू जो पैदा होता है कि आप किसी समस्याओं के ऊपर केंद्रित करिए। क्रीमियल कॉन्गो हेमरेजिक फीवर का मैं एग्जांपल दे रहा हूँ आपको, बार बार इसका पता लगा पूरे राज्य के अंदर है, अलर्ट थे तो रुक गया वो। लेकिन इसमें फिर क्या चाहिए होगा आपको? मेडिकल वेटनरियन का इकट्ठा चाहिए होगा, आपको इंटरसेक्टोरल प्रोजेक्ट्स बिल्ड करने हैं। अगर आपको क्लिनिकल एपिडेमियोलॉजी वर्क करनी है तो ICMR और आपका ICR चाहिए ज्वाइंटली, और जूनोसिस में ये पिकअप हो गया वहाँ पे। नेशनल एजेंडा में भी क्रीमियल कॉन्गो हेमरेजिक फीवर आ गया, जो इंटरसेक्टोरल कमेटी बनी उसके अंदर फंड करने के लिए ऐड भी आ गई। क्या गुजरात से कोई प्रोजेक्ट गया है क्या इसके अंदर? मुझे नहीं मालूम, पिछले 1 साल से मैं सीन में नहीं हूँ, लेकिन गया या नहीं गया मुझे नहीं मालूम। तो सवाल पैदा होता है कि जिस स्टेट की मेन समस्या है कि उसने के प्रोजेक्ट सबमिट किए या आज करेगा, उसकी वैक्सीन बनानी है, उसके लिए डायग्नोस्टिक बनाना है, इट कैन बी योर मेन थिंग एक्चुअली, यू कैन बी ऑन द वर्ल्ड टॉप ऑफ द एजेंडा ऑन द वर्ल्ड एक्चुअली। कर्नाटका के साथ मिलकर आप KFD को भी साथ ले लीजिए, तो हेमरेजिक फीवर में इबोला तो हम चलाते रहेंगे, लेकिन हमारी जो अपनी समस्या है उसके ऊपर हम कर ही नहीं रहे कुछ भी। सो आई थिंक यू टेक दिस, यू कैन टेक कंसेंसस वन ऑफ द एजेंडा आइटम्स। लेप्टोस्पायरोसिस के एरिया के अंदर है, जेनेटिक डिसऑर्डर्स का जो बहुत अच्छा लगा मुझे सुन के, पूरा नेटवर्क क्रिएट करने की ऑलरेडी प्रतिबद्धता है। मैं पहले कई बार जब आया तो रेड क्रॉस के मैं सेंटर्स देखने गया, कई जगह देखने गया, लाखों स्पेसिमन आपने स्क्रीन कर मारे हैं। अब उनके बाद एल्गोरिदम ऑफ मैनेजमेंट क्या होगी? वो म्यूटेशन होने से जरूरी नहीं है बीमारी होगी आपके अंदर, क्योंकि कोर है एपिजेनेटिक्स। तो एपिजेनेटिक्स के ऊपर काम करने वाले लोग चाहिए साथ में कि ये आपको मैनिफेस्ट करेगा नहीं करेगा। चाहे वो जेनेटिक डिजीज है, NCDs हैं, उनमें वही समस्या चीज आएगी, NCDs के ऊपर डिफरेंट लोग बोलेंगे। लेकिन एल्गोरिदम डेवलप करना, प्रिवेंशन की स्ट्रेटजी बिल्ड करना, तो उसके लिए कंप्रिहेंसिव अप्रोच चाहिए। ऑक्यूपेशनल एनवायरमेंटल हेल्थ की समस्याओं के ऊपर इंस्टीट्यूशन है आपका, नेशनल इंस्टीट्यूशन यहाँ पे, और अधिकांश वो इंस्टीट्यूशन इज कॉल्ड ओनली फॉर द इमरजेंसीज। कोई इंडस्ट्री में क्राइसिस आ गई, हाई कोर्ट ने, सुप्रीम कोर्ट ने बोल दिया, लेकिन उनके साथ मिलकर एक मेडिकल कॉलेज एल्गोरिदम बनाए मैनेजमेंट की, उन लोगों के रिहेबिलिटेशन की, नई टेक्नोलॉजी जनरेट करे डिफरेंशियल डायग्नोसिस के लिए। तो वो होना जरूरी है आज। अगर दुनिया में छाना है, अपने लोगों की भी सेवा करनी है और दुनिया में अपना नाम भी बनाना है, तो देन यू हैव टू बी कमिंग विद ए सोल्यूशन विच शुड बी योर सोल्यूशन, नोन बाय यू, विच यूज्ड बाय योर पीपल, यूज्ड ऑल ओवर द वर्ल्ड ऑल्सो सेम टाइम। तो आई थिंक ये कुछ एग्जाम्पल दे रहा हूं मैं आपको, इन एग्जाम्पलों में से कुछ आपको क्या एजेंडा बनाना है वो आपके ऊपर है। सभी में क्या चाहिए होगा? मैकेनिज्म्स अंडरस्टैंड करने की, पाथवे, डायनेमिक्स, ह्यूमंस में, एनिमल्स में, एनवायरमेंट में। सोशियो बिहेवियरल रिसर्च मस्ट है, नहीं तो कभी समस्याओं के ऊपर पूरा अंकुश नहीं आएगा। गुजरात प्रॉस्परस स्टेट होने के बावजूद यानी कि कई हेल्थ चैलेंजेस खड़े हैं, मैं उन पर कमेंट नहीं दूंगा। अब क्यों नहीं है? क्योंकि वो सोशियो बिहेवियरल दूसरी चीजें हैं, उनको ऊपर ध्यान नहीं दिया गया। वो करेंगे तो आपकी टेक्नोलॉजी लोगों तक पहुंचेगी। स्टेट की कमिटमेंट, गवर्नमेंट्स की कमिटमेंट, उसमें कोई कमी नहीं। लेकिन साइंस की कमिटमेंट चाहिए। कैसे? सोशियो बिहेवियरल चीज़ डालिए कि लोग क्यों नहीं एक्सेप्ट कर रहे, ये लोग हेल्थ प्रोफेशनल क्यों नहीं इसको यूज़ कर रहे, लोग क्यों नहीं यूज़ कर रहे और क्या यूज़ करेंगे। तो आई थिंक दे आर वेरी क्रिटिकल एक्चुअली, बोथ फॉर इनोवेशंस एंड ऑल्सो फॉर द सक्सेस ऑफ द करंट प्रोग्राम्स इफ यू वांट टू रीच द टॉप। अब ये सब करने के बाद देन यू टारगेट दी बेटर मेथड फॉर क्लिनिकल डायग्नोसिस, एल्गोरिथम्स फॉर डायग्नोसिस, जो पेशेंट लेवल पे काम करें और पब्लिक हेल्थ लेवल पे काम करें। चलिए आखिरी स्लाइड, वेयर वी स्टैंड। वी नीड टू बी रियलिस्टिक एक्चुअली। आर वी मार्चिंग टुवर्ड्स सेल्फ रिलायंस इन द एरियाज ऑफ ओरिजिनल जनरेशन ऑफ न्यू नॉलेज, नीड्स, इंडिजिनस हेल्थ केयर टेक्नोलॉजीज जो हमारे इकोसिस्टम को सूट करती हैं, रूरल इंडिया को देखती हैं, हमारे रूरल, चाहे गुजरात लो रूरल इंडिया को देखती हैं। सिमिलरली दे दुनिया में कहीं एप्लीकेबल हैं। हैव वी बिगन द मार्च एंड गेनिंग डिजायर्ड मोमेंट, और इट इज सिंपली अ फ्लैग मार्च। हमारी जब कोई क्राइसिस आती है तो पुलिस का फ्लैग मार्च करा देते हैं, आर्मी का करा देते हैं, पैरामिलिट्री का करा देते हैं। तो हम जो आज कर रहे हैं कि एक फ्लैग मार्च है क्या, या हम जो जस्ट एक डेमोन्स्ट्रेशन करके चले जाएंगे? ट्रुथ यह है कि हमारी जब कैपेबिलिटीज हैं, हमारे अंदर कैपेबिलिटी हैं एंड वी आर डेमोन्स्ट्रेटेड देम टाइम एंड अगेन, लेकिन मोमेंटम नहीं बिल्ड हुआ अभी। तो इसलिए ये आज का दिन तो फ्लैग मार्च नहीं चाहिए। मेक इन इंडिया प्रोग्राम कैंपेन जो है दैट कैन बी यूज्ड एक्चुअली, मोमेंटम है उससे। बहुत सारी समस्याएं जो सेंट्रल एजेंसीज के लेवल पे सिनर्जी चाहिए, क्विक अप्रूवल चाहिए, वो आज हो सकते हैं सारे, क्योंकि हर चीज़ केंद्रित एक मजबूत हाथ में है एक्चुअली। वेरी एक्टिव प्राइम मिनिस्टर एंड ऑल दीज थिंग्स आर ऑन हिज एजेंडा एक्चुअली। लेकिन करने वाले कौन है? हम लोग, आप लोग। सो आई थिंक दिस इज द टाइम टू गेन मोमेंटम। आई थिंक गुजरात कैन बी हब फॉर डिवाइसेस, ड्रग्स, वैक्सीन्स। इसलिए डॉक्टर कलाम आई थिंक इस पीरियड के, हमारी इंडिया की स्पिरिट के, आई थिंक ही रिप्रेजेंट्स द सोल ऑफ द नेशन। उनका एक मैंने कोटेशन लिया इसमें, ड्रीम बिग, बैक इट अप विद द कीन ऑब्जर्वेशंस, हार्ड वर्क एंड विजिलेंस टू अचीव इट। तो सपना बनाइए, पहले सपने को प्रारूप दीजिए, एजेंडा बड़ा केयरफुली करना है हमें चूज। आई थिंक लंबे समय से सिस्टम को स्ट्रेंथन करने के लिए, जैसे मैडम मंजू शर्मा का योगदान रहा, प्रोफेसर डॉक्टर अमित घोष, दूसरे घोष, सभी ने योगदान किया है इसके अंदर, बहुत से औरों ने किया है, आप लोगों ने यहाँ लोकली बिल्ड किया है, यहाँ की बायोटेक्नोलॉजी इस ऑर्गेनाइजेशन ने बिल्ड किया है। तो इकोसिस्टम बनाने की तो कोशिश हो रही है, लेकिन गाना गाने के लिए लोग चाहिए। तो गाना गाने के लिए लोग चाहिए, तो वो इंटरडिसिप्लिनरी रिसर्च के लिए आपको तैयार होना है, टीमें बनानी है, पूरी चेन को वर्कआउट करने की बनानी है। सिर्फ एक मॉलिक्यूल, एक एपिटोप, एक जीन, सिलेक्टेड अप्रोच से कभी भी समाधान नहीं आ पाएंगे लंबे लॉन्ग टर्म पे। जब हम बायोमेडिकल रिसर्च की बात करें, बायोमेडिकल रिसर्च इज डीलिंग विद ए डिजीज, नॉट विद वन एस्पेक्ट। तो आई थिंक वो दिमाग में रहेगा हमेशा पास। हमारे पास ये स्ट्रेंथ्स क्या है कंट्री के अंदर, वो दिमाग में रहेंगी। आज मैंने सबकी एजेंसियों के बारे में कहने की इसलिए कोशिश की क्योंकि वी हैव टू थिंक ऑफ द स्ट्रेंथ्स ऑफ द कंट्री, और कंट्री की मजबूती है। जहाँ पे 10 साइंस एजेंसीज, 10 में से 6 तो अपने को साइंस एजेंसीज हैं, 10, 4 दूसरी डिपार्टमेंट्स हैं, वो लगे हुए हैं उसके अंदर। स्टेटों के अंदर प्रतिबद्धता है। यहाँ जैसे गुजरात जैसा वाइब्रेंट स्टेट है और आपने ठानी है कि आज से करना है, तो कुछ समय नहीं चाहिए इसके लिए। क्लिनिकल रिसर्च व्हेन यू से इन टर्म्स ऑफ द क्लिनिकल ऑब्जर्वेशन, डेवलपिंग द एल्गोरिथम्स, बेटर ट्रीटमेंट मेथड्स, उसको तो आज कभी भी स्टार्ट कर दो आप। उसके लिए लेबोरेटरियाँ बनाने के लिए थोड़ी वेट करना है आपको। जिन उदाहरणों से मैं स्टार्ट किया, सुश्रुत चरक, वो किसी बड़ी भारी उनकी एलिगेंट जीनोमिक्स लेबोरेटरी में तो नहीं काम करते थे वो लोग। सो आज से 30-40 साल पहले के क्लिनिशियंस किसी चीज़ में थोड़े काम करते थे। इंडियन चाइल्डहुड सिरोसिस आज कंट्री से एक्सटिंक्ट है, तो उसके लिए जो शुरू की ऑब्जर्वेशंस जो आई, 1887 का पेपर, 1954 के पेपर, 55 के पेपर, वो कहाँ से आए? क्लिनिशियंस ने तो बनाए। इस प्रेजेंट युग के भी जो बहुत सारे लोग हैं, वो कौन थे एक्टिव काम करने वाले? क्लिनिशियंस हैं रिसेंटली। कुछ एका दुका पैथोलॉजिस्ट दिखेंगे, कुछ एका दुका दूसरे दिखेंगे। तो वो जो कहना है कि हमारे पास समय नहीं है, हम इसमें बिजी हैं, उसमें बिजी हैं, सब बहानेबाजी है एक्चुअली। आज भी ये 3 ये लोग बोलेंगे आपके बाद तो ये बहुत, इनको कोई रात के 8 बजे तक टाइम नहीं मिलता, फिर भी साइंस करते हैं. तो आई थिंक just have a determination, प्रतिबद्धता, determination and the will to succeed, and you will win. तो आशा करता हूं कि आज का दिन यादगार रहेगा सबके लिए और कंक्रीट प्रोग्राम में एमर्ज करेंगे. कुछ बातें मैंने अपनी शेयर करी. दिस नथिंग, दे नीड नॉट बी अ सैक्रोसैंक्ट एनीवे, एक्चुअली दे आर ए ओपिनियन ऑफ इंडिविजुअल एक्चुअली, बट आई थिंक दे करने के लिए बहुत कुछ है और कर सकते हैं. तो इसी पॉजिटिव नोट के साथ धन्यवाद. जय हिंद.
Thank you very much, sir, for that inspiring. I request sir to again present a memento to Dr. Manju Sharma. Thank you, sir. We will now break for a quick tea break, not more than 15 minutes because we are lagging behind time. Make it as fast as possible and please come back so that we can start with the technical session. Thank you.
Welcome back to this one-day seminar on biosafety. We would like to resume the seminar with the technical sessions. We will begin. We would welcome our first speaker of the technical session, Dr. Balram Bhargava. Before we begin, I would like to give a quick introduction of Dr. Balram Bhargava. Dr. Balram Bhargava is an Indian cardiologist, medical educationist and innovator, known for his expertise in the trade and for his social commitment. The Government of India honored him in 2014 by awarding him the Padma Shri. Dr. Bhargava is a leader in the field of biomedical innovations in India. He was the force in the establishment of the stem cell facility at All India Institute of Medical Sciences. He has founded the Stanford India Biodesign Center, the Indian chapter of Stanford Biodesign, and is its executive director. The organization has set goals to promote innovators of medical technology through fellowships and also to conduct internships. His contribution in low-cost technologies for cardiology have placed India in the map of biomedical innovation. Let's hear a huge round of applause for welcoming Dr. Balram Bhargava.
Thank you. Thank you for the very kind words. After a very inspiring talk by the previous speakers, by Dr. Katoch and Dr. Manju Sharma, it's difficult, but let us see what we can talk about. I often start my talk by telling, as what Dr. Katoch has pointed out, 69 years of independence and 70 years of independence and what India has achieved in these 70 years. And when I pose this question to people, they say India has done well in IT and India has done well in mobiles. And they stop at that. I ask them more, then they say India has done well in cricket, India has done well in Bollywood. But what they don't say India has done well in, India has done well in pharma. And this is the very ground where pharma, I mean, Gujarat has been the state where India has become the pharmacy for the world. India has done well in agriculture. First Green Revolution, late 60s, and the second Green Revolution, which is still on. And we have become dependent on, independent as far as food grain crisis is concerned. Medical treatment, no one talks about it. India has done so well in medical treatment that it is ranked number 2 in the world for medical tourism, and no one has to go out of this country for any treatment. It is available in this treatment. Having said that, there are problems. It is expensive, the cost of medical treatment has gone up in this country, and it is not available to all. Emergency medicine is an area which needs to be developed, and that is a big frontier which the next generation has to take care of. And is it not audible?
No,
Yeah,
it's
okay, sorry. So that is an area which really needs to be developed. And I will talk a little bit about the biodesign program, where we are trying to develop low-cost medical devices and trying to set an example so that India can replicate what it has done in pharma, it should do in medical devices. Exactly what has been done in pharma should be done in the next 10 years or 15 years in medical devices for this country, and India should become self-sufficient on those things. So I'll start with a complicated slide showing the full healthcare information of statistics of the world, where we talk about the GDP. Only 4% of the GDP is spent on healthcare in India, compared to 18 to 19% in the US, and 9 to 10% of the GDP in most of the developed worlds, like countries like Canada, Brazil, Germany. So 11-12% is what. So we are still at 4% of the GDP. So that is the utilized GDP, and our infant mortality rate, maternal mortality rate are still a huge big problem. Look at the infant mortality doctors, number of physicians, number of beds are all very low as compared to much of the developing countries like Brazil, Chile, South Africa, and much lower than developed countries like UK, Germany, Japan, Australia. So our number of physicians is 0.7 compared to 3.9 in Switzerland or 3.8 in Sweden. But having said that, we see much larger number of patients, so we can make up for that. I think that is not a huge big problem, number of physicians. The problem is infant mortality is on 41 compared to 2 in Sweden, 4, 7, 8 in UK. Maternal mortality rate is 190. So these are real problems. Having said that, we've still not been able to take care of our infectious diseases like malaria, filaria, leprosy, tuberculosis, and we've got the second non-communicable diseases burden of coronary artery disease, diabetes, cancers, hypertension, and obesity. So these are big problems. So we've got a double burden of not only the communicable diseases, but also the non-communicable diseases, and we really are struggling with getting healthcare to everyone. And that is where our problem is, providing healthcare to everyone. As I mentioned, no one has to go out of this country for any treatment, but giving healthcare for everyone still remains a major challenge. Now, public hospitals like this, the civil hospital, 30% of these public hospitals cater to 80% of the population. People may say that the healthcare is 70% is private and 30% is government, but 30% of these hospitals cater to 80% of the population of this country, which is never brought out in a big way. These public hospitals lack maintenance and lack modernity. However, the Prime Minister program of Kaya Kalp has started, and some of them are being renovated, and also the state medical colleges are being channelized into this in terms of infrastructure. The private sector is unregulated and it lacks accountability, and it needs to be accountable, it needs to be regulated, so that the gap between the private and the public sector becomes narrower in terms of performance. Now, 39 million people fall below the poverty line every year in our country because of health-related expenditure, and most of these are medical devices or medical treatments, and 80% of the devices are imported, and these are only for really the 20% of the affording population who can utilize these devices. So medical devices is an area, is a sector, and all these devices are invented in the West and marketed in the East. So we need to get our act together in terms of, this is just a pie chart showing the number of devices utilized in different fields: orthopedics 14%, cardiology 11%, wound care, ophthalmology, and these are really a big problem in our country. So the strength, as Dr. Katoch had mentioned, that we rise to the occasion. That is the strength of our population. We have a large talent of doctors, engineers, and biomedical engineers. We are genetically endowed. I do not know in terms of, we have an innovative mindset as Indians. We are able to work under constraints and devise some things. So that is what our strength is. And we see more patients than any physician in the world. So we are definitely having far more, a broader perspective of the problems. And once we sit down and think about those problems, probably we can find solutions, effective solutions. So there is a greater belief in the country, and the innovation hubs are being nurtured. The government is realizing the innovation is a huge, big industry which needs to be nurtured, particularly for medical devices. We have the healthcare spending expected to be going up to $200 billion by 2025, and a large proportion of it would be directed to medical devices. So as I mentioned, that we wait and we wait a lot, and when the problems reach a critical mass, we have the impeccable record of solving these problems cheaper, better, faster, and in a scalable manner. So we find a solution which is simple, and it is cheaper, and it can be copied by other people and other countries in a scalable manner, because the solution is so simple. I'll give you some examples, and these are examples not only concerning biomedical or healthcare, it's just a general where we rise to the occasion. Look at our struggle for independence. Cheaper, faster, scalable, no bloodshed, no money involved. Food grain crisis, I talked about it, the Green Revolution. Our space, ISRO, the Mangalyaan, Mars, polio eradication. The Delhi metro and the metro which is being replicated in other cities is much cheaper, faster, scalable, being developed in our resilient banking system, mobile networks, several government schemes which have been introduced and are working phenomenally well. And Bollywood, we talked about it, generic drugs. So can we think of generic medical devices which are, as I talked about, thought in the West and deployed in the East? They should be thought in India, made in India, and ultimately deployed in the rest of the world. So we have to flip the argument totally. So this is a slide demonstrating how innovation has happened since 1980. And in the 80s, we thought only about, and Dr. Katoch mentioned about it, anything imported is good, and it was all imported innovation. So ideas were from the West, manufacturing was done in the West, and everything was sold in the East. 1990s onwards, we saw more export-led innovation where ideas were from the West. Some limited manufacturing was done in countries like China, India, Taiwan, and then exported to the West. And 2000 onwards, we found examples of end-to-end innovation happening in countries like India, China, wherein ideas were from here, manufacturing was done here, and it was deployed here. And then 2010 onwards, we are finding that ideas are there in the East and the West. Manufacturing, we have to do it together. There are some advantages. We have some advantages the West have, and it can be deployed in both parts of the world, whether it be the developing or the developed countries. So this is where we are, and I think 2015, 2020 onwards, we'll see more bulbs in the emerging economy, so more ideas here, because sure, larger number of people, larger number of ideation, larger number of cerebral hemispheres working on the same problem. So frugal innovation is the philosophy which was the more for less for more, as a term coined by Dr. Mashelkar when he published this paper in the Harvard Business Review. And basically, the Indian consumer is very, very price sensitive, and we have a large middle class, aspirational middle class, who want good treatment, cheap treatment, effective treatment, and so the problem is big, and we not only have to concentrate when we innovate some new technology or device, we don't have to focus purely on shareholder wealth and profits, but we also need to focus on the people, on the society at large, because it has to be an affordable technology. It has to be useful in our context. So everyone knows about Thomas Edison and the concept of patents and the concepts of, he was the person who had the largest number of patents in the late 19th century, and he invented the bulb, and he is often interchangeably used with innovation, his name. So he clearly said that anything that won't sell, I don't want to invent. Its sale is proof of utility, and utility is success. While Gandhian innovation is, earth provides enough to satisfy a man's need, but not every man's greed. So we have to have a balance probably between the two. And Gujarat is known as the business hub of the country. And Gujarat is also known for Gandhi. So I think it has to be really balanced out in such a way that something which is useful for the population. Now, just giving you how Indians are genetically endowed and have that mindset. When the Starbucks coffee shop opened in Bombay for the first time, so people thought it's an American coffee, let's make a huge queue. So there was a big line for getting that coffee for days together. This gentleman realized that there is a potential, people are waiting in queue, and why not sell masala chai? So he started selling masala chai to everyone. And this was, although not a very strong innovation, but it was a spontaneous innovation, wherein for 7 to 10 days, he was able to make his money and with selling masala chai, were people waiting for coffee. And then he went on to some other new idea. So this is how we are genetically endowed, and we should utilize that. That is what I'm trying to say. Look at our Mars mission, which costs about 8 rupees a kilometer, compared to 63 million rupees per minute for that Hollywood movie Gravity. So we have a frugal mindset, and we are genetically endowed to innovate. So we should utilize them, and we have to remember, it doesn't have to be cheap innovation. It has to be frugal innovation, wherein the quality is still high, but the price is low. So if you look at the frugal innovations that have happened in India in the last 10, 15 years, 6 out of these 10 have been related to the medical device sector. The GE ECG machine, the 1298 ambulance service that was started in Bombay, Arvind Eye Hospital and their network, and the Arvind lens, which is costing about $3, intraocular lens implant. The Swachh water filter, which is utilizing rice husk to filter, marketed by Tatas. The Narayan Hridayalaya, the Jaipur prosthetics. So there are several examples of innovation in the healthcare space, wherein a lot of multinationals have also come in to utilize or tap the Indian mind and try to get ideas out of that. So if we look at the example, what happened with the pharma industry, and Gujarat is what has done so well in the pharma. If you look at this graph, which is showing the antiretroviral therapy, the triple therapy for HIV/AIDS, was costing $10,000 treatment for 1 year. Cipla came up with an originator, and the whole treatment for 1 year was $700 within 6 months time span. And then over the years, the treatment is about $130 per year. Even the multinationals reduce the cost of their medications. This has happened in the pharma industry. We need to replicate this in medical devices, and that's a huge open area where lots can be done. Another small example where we are genetically endowed, this is just outside where I live. There is, people come to give grain to the birds. In the morning, come to give grain to the birds. This gentleman realized that there is a huge business opportunity here. He started selling those grains so that people can buy small packets, 5 rupees, 10 rupees, 15 rupees packets worth of grain, and distribute them to the birds. Now, lots of people come, they buy the grain, they distribute it to the birds there, and at the end of the day, he sweeps it, cleans it up, recirculates some of those grains. So this is frugal, spontaneous jugaad innovation, which is our genetically endowed mindset. So the pieces of the puzzle are falling together in India. We have the talent, we have the capital, we have the problems which are huge, the opportunity is huge, and we have the policy, and the government is really supporting. And we heard an excellent lecture where we heard about the DST, DBT, DRDO, atomic energy. Everyone is ready to fund for research. in different areas, and particularly if it is interdisciplinary research, I think there is much more support available for that. So we developed, with the help of the DBT, started a small school of international biodesign at All India Institute and IIT Delhi, wherein we have been able to train 100 young innovators, which includes doctors, engineers, designers, and these people have been working together to develop different products, and some of them are now available in the Indian market. I'll give you some examples of that, and some of them are also FDA approved. So these are our collaborators for this program, and we have the All India Institute of Medical Sciences, IIT Delhi, and the School of International Biodesign. And this is the biodesign process, which was started by Stanford. Ultimately, we adopted it and tried to give it a frugal soul, wherein they identify a problem, and after identify the problem, they try to invent for that problem and then implement that solution. So identifying the problem is a group of 2 engineers, 1 designer, 1 doctor, move together in the hospital and note down ideas and come up with problems from the intensive care units, in the operation theaters, in the primary health centers, in the tertiary care centers, and they come up with say about 400, 500 unmet clinical needs, or ideas where solution could be found for, and then they look at they filter those ideas and work on few ideas after seeing what is available, what is the competitive landscape, how much is the impact, how much is the passion for those people to work on that problem and find a solution. And ultimately they come up with some ideas, they observe, they ideate at All India Institute, then they go to IIT, where they build the prototype, they rebuild the prototype, they iterate and test again at All India Institute, and rebuild and improve the prototype at IIT. So it's a process which is a long process to develop a product, which starts with research, development, and then ultimate translation. So there are problems which they face from this idea to the prototype to manufacture and ultimately commercialization, wherein they identify a need, early prototyping, technology transfer, project management, design for manufacturing, and quality of regulatory, human studies, and ultimately, once they get regulatory clearances, they do manufacture and then do the commercial launch of that product. Typically, for a new drug molecule to develop, it takes anywhere between 10 to 15 years. For a medical device, the incubation period is much shorter. It takes about 5 to 6 years from concept of idea to ultimately commercialization. So these are some examples of products which have been developed at our center by our students, and they've developed 11 startups. We heard about our director of the mission talk about startups, and we've been able to develop in these 10 years about 11 startups. And the first one is Biomedical, wherein we have catheters for collecting urine, but there's nothing for collecting stool other than diapers. So they've developed a self-expanding nitinol-based device which can be deployed by a family member or a nursing staff and can collect stool for 5 to 7 days in patients who are elderly, who are immobile, who are in the intensive care unit, and this has also got US FDA approval, and now is being marketed not only in India but also in the US. This is another. We have road traffic accidents. We have about 15 million road traffic accidents in India, out of which 5 million are related to the lower limb, and there is nothing to immobilize them. Earlier we used to use the Thomas's splint, which was made of metal and was expensive and not disposable and heavy. So the students thought of a simple idea from like making it like a cricket pad made out of cardboard, coated with a special plastic, and the same one can be inverted and used for the left or the right leg. And this you can use, immobilize the patient at the site of the accident, and this can be removed after X-ray, after CT, after MRI, only in the operation theater. So and then thrown away. So it's a simple device which I wouldn't call it a device. It's a simple immobilizer really, which costs 70 to 100 rupees. And it's now being marketed in 3 states in India, and the army is also looking for this. This is being marketed by Hindustan Latex Limited now. This is another simple device which is in patients of shock. Once you are not able to find a vein in about 45 seconds to 1 minute, then you can, in these patients of shock which are of road traffic accident or cardiac emergency or obstetric emergency or dehydration, you can, these are patients who have a very low blood pressure, you can, and not find a vein, then you can go for the upper end of the leg bone and give fluid into the bone. You can even give medications for up to 10 to 12 hours, and that is now the recommendation of the Anesthetic Society and other emergency societies as well. So we have electrical drills available, rechargeable. Now this is a simple mechanical drill which the students thought about it, design students thought about it from seeing their carpenter who utilizes that bow to make a drill. So they said, why not utilize that principle and develop this. So they developed this simple mechanical device which takes about 7 to 8 seconds, and you can give fluid immediately, and it can be given for up to 8 to 10 hours. So this is a simple device, now also been tested. Now here again we had to innovate a little bit. Getting permission for animal testing was a huge big problem. It would take anywhere of 2 to 3 years in India. So we said, let's go to the cadavers. And the cadaver testing was done at All India, and now we got permission for testing it in humans. So this is another biopsy device which takes a biopsy. You don't have to handle the specimen with the forceps. It just automatically goes into the green chamber, and it also injects a sealant where the biopsy is taken and arrests bleeding. So this is, if you open this, it's a tremendous amount of circuitry involved in this, and these are brilliant engineers who have developed it and have done some of the early manufacturing also has been done in China, and they have been able to, because some of it was much cheaper to do it in China. Now this is the foot-operated neonatal resuscitator for resuscitating newborns from respiratory arrest, and normally the ASHA workers use one hand to hold the mouthpiece and the other hand to pump the ambu bag, and they are not able to get a secure positioning of the mouthpiece. So here this is a foot pedal wherein they can secure the mouthpiece with both the hands or use it with one hand and have one other hand for doing other things. This is again funded by the Windmill Foundation and also the Bill and Melinda Gates Foundation. This is another device which we've developed. It's a complicated device. It's a cardiopulmonary resuscitation device. In patients of cardiac arrest, now the understanding is that you have to do cardiac massage for at least 30 minutes to 45 minutes before declaring them dead. That are the newer recommendations, and that has changed. Earlier it was 10 to 15 minutes, and that is because people have found successes even after doing resuscitation for up to 30 minutes. And after 1 minute of resuscitation, the efficacy drops about 80% if it's a manual resuscitation. So this is a mechanical device which we have developed. And some of these students who are engineers, they developed it in Bangalore, and this is now being in the process of licensing out to a multinational for the development. Another jugaad or simple idea, when you insert a nasogastric tube, sometimes it goes into the respiratory tract, and that has to be avoided, because if you give fluid into the respiratory tract in patients who are not able to swallow, then they can get into pneumonia and ultimately die with respiratory infections. So this simple mouthpiece ensures that the nasogastric tube, once it's being inserted, goes posteriorly into the trachea. It's just a simple plastic spatula sort of a device, but it is a genuine problem. So once you identify the problem, you can find a solution for it. And these are some other devices. This is another device which has got the full national formulary on the mobile phone and some drug interactions. So what is going to happen with MedTech in the next 10 years? I think there is going to be a lot of wearables. Fitbits are being developed much cheaper in India. And we have home health, some of which I do not really support whether home health is going to be, but it needs to be, again, regulated. And health insurance is going to increase. So the opportunity is immense for medical device innovation, particularly it's a $6 billion industry at the moment, and it's growing at about 15%. And there's 100% FDI in the medical technology route. In fact, the import duty on medical equipments has gone up. You know, finished products has gone up from 5 to 7.5%. And if you're importing components, the duty was anywhere between 5 to 30%, and that has come down, and it's fixed at 2.5%. So you can import components, but it has to be made in India by getting some of these components, which may be expensive to develop here. So in India, the medical device innovation show starts in 2025, but the tickets are being sold now. So I think people have to get up. And as our nation to succeed, we need to start preparing now. No time better than now. Thank you so much for your kind attention. So we can now, or I think, okay, thank you.
As a memory of today's seminar, we would like to give a small token of memento to Dr. Balram Bhargava. May I request our Mission Director, Mr. S.N. Tyagi, to give a memento to Dr. Balram Bhargava. Thank you, sir. Let's move to our next speaker, Dr. Nikhil Tandon. Dr. Nikhil Tandon is an endocrinologist and the head of the Department of Endocrinology, Metabolism and Diabetes at the All India Institute of Medical Sciences. He is a recipient of Dr. B.C. Roy Award, the highest Indian medical award in 2005, and was honored by the Government of India in 2015 with Padma Shri, the fourth highest Indian civil award. Dr. Tandon is a former Vice President of National Academy of Science India and a President and the incumbent General Secretary of the Indian Society of Bone and Medical Mineral Research. He has served as an executive committee member of the Endocrine Society of India and is its president. Please have a huge round of applause.
Just checking whether it's good morning or good afternoon. It is good afternoon. I'd like to start by actually thanking Professor Manju Sharma for having invited me to this. I think it's a very important event, and more so specifically because it gives us the opportunity to hopefully sensitize an entire community of medical practitioners to look at entering or at least establishing themselves in the field of biomedical research. And I think it's important here. I realize that this is being supported by the Gujarat State Biotechnology mission, but we're not talking about biotechnology alone. We are talking about biomedical research as a larger and a broader entity. I think the 3 or 4 points I'd like to make before I actually come to my talk. First, that there is this belief that we fragment our existence into he's a clinician, she's a basic scientist, he's a researcher. And I think therein lies one big problem, that we can't, the moment we start talking of research as a separate entity, which has no relevance to our day-to-day existence, that is not a sustainable model for doing any research. And therefore the critical part and I'm a clinician, right? And the critical part, therefore, for doing research has to be relevant to what you face as a clinical problem or your patients face as their problem in a day-to-day existence. And if it's drawn from that, it becomes relevant. If it's not drawn from that, it's just a separate, standalone idea. It really is not something for which you'll ever develop the passion to do anything about, and it's never going to be sustainable. I'm sorry to be sort of negative about it, but it has to have a focus of relevance. This is a problem faced by A, B, and C. I remember seeing a patient who had this particular problem. This is how we tackled the problem in this particular patient. It worked in that person. Why can't we evaluate whether it'll work in more people? Do we then know what's the best way of evaluating to do that? And then we come up with an inference, right? But you need a sort of a clothes nail to hang that idea on. You have to refer back to a human being. And that is the critical part. We've heard about tuberculosis research. Tuberculosis research, I remember, and I think I get thrown out of most committees because of the things I do. But so this was it was on health, right? It was and people kept talking of organisms, and I said organisms are not responsible for good health or bad health. There is a human being at the end of that process, and we don't seem to be talking about that human being. We're talking about, we are so far distant from that human being or animal whom we are supposed to do good for, that we lose focus of what we really set out in doing. So unless you do that, I don't think it's a sustainable model, and that's one thing which I think is very, very important. The second thing is, we've heard of all about the funding agencies, but we also heard Dr. Katoch make a very important point. There was a time when actually there was no DBT, it didn't exist. Research happened before that. There was no DST. It was not even created. Research happened before that. There was an ICMR which happened much, much before that. There was a CSIR which possibly came after the ICMR, and they gave, without disrespect, paltry sums of money. But those paltry sums of money were enough to actually solve a lot of problems. So if every time you're going to say, I need 5 crores to solve this problem, it's not coming. And therefore, you may think big, but you've got to start small. It has to be something which can be managed with a small amount of money, and there's a lot that can be managed with a small amount of money. And that's one thing. The fourth thing about research, which I think is critical to understand, is that if you already are dreaming of your next publication in the New England Journal of Medicine, before you started doing your first research project, it's not happening. There is a very long gestation period between your first thought and its fruition and its publication and its implementation and then its translation, right? So even before starting it, if you've already sort of started seeing yourself as a first or corresponding author in a 5-star journal, I think you're being a little greedy and perhaps a little impatient. And research is not about impatience. Right? It's deep pockets yet, but very, very, very deep patience. Because I can guarantee you that every time you start on something new, you are likely to fail. The second time you do it, you're still likely to fail. And so you've got to be prepared for that. So if you set out, and if you've not been in this field, and you set out and assume that you're going to start a research project today, and tomorrow things are going to work out fine, and by day after tomorrow you'll already be a star, and it's not happening. And the last thing, and I think this is important, and that's why this is very, very reassuring to see such a big crowd, is that for any institution to be, and I think Dr. Katoch made this very clear, it's not an individual game, right? This is not an individual sport. It's not playing tennis as a singles player. This is a team sport, right? And for that, you need a critical mass of researchers and investigators in the institution that you work, because you will find that you will land up in trouble. You need to know whose door you can knock on to get some advice, to get some mentoring, to get some guidance, and get some consolation that, it's not working, it's not been working. I've tried this experiment for, for the last 8 months and it's not working. You need a critical mass of researchers. And when we're looking at interdisciplinary, then you need 2 institutions with 2 critical mass of investigators, which is even much more difficult, right? So the Stanford Institute of Biodesign. So if you look at where we are located in Delhi, so there's AIIMS, there's IIT Delhi, there's University of Delhi South Campus, there is National Institute of Immunology, there is JNU. They're all about 6 kilometers from each other. We still don't very often go and talk to each other. It was 6 kilometers, right? AIIMS and IIT is like 3 metro stops away or something like that. So it's not, but you need to be able to speak to people. You need to be able to develop friends who are doing something which you can. Otherwise, it's again not going to happen. And you can only work with friends. And that's, you need to either have friends who are doing something similar, or you need to make friends who are doing something similar, because it's a long haul. You need people who can support you, and that becomes very critical. So I think this is what I'd like to communicate on the general feel of things. I'm not going to give a general talk from now on. I'm going to use examples from stuff which we've done or are doing to exemplify what you're doing. All of them actually relate to human disease. Why does one get it? What is the burden? What are the ways you can diagnose it? What are the ways you can treat it? And what are the ways you can prevent it? And as I said, if you're sitting in a busy OPD and you're seeing 50 patients and they all have the same problem and you're unsuccessful in solving the problem, it is a problem for you to address. Okay, so the 5 areas which I will cover are risk factor identification. I think I didn't know what Harold Varmus said. I'm a bit ignorant about what people in the field of cancer biology said, but risk factor identification is epidemiology, right? Laboratory measurements are very important. I work in endocrinology. I mean, if I can't measure a hormone properly, I can't really diagnose endocrine disorders. We're heavily dependent on endocrinology. Disease, natural history. So if you, and I will stick to diabetes and endocrinology because that's what I understand a little bit. I don't understand most other diseases. But you need to know how a disease evolves. You need to reassure a patient that, this may happen, but it's going to become all right. Or you need to warn the patient that you're at the threshold of disaster, because we know that patients who have this sort of evolution end up with this sort of problem. But unless you've seen that, right? We taught medicine from English textbooks, English language textbooks, who've drawn on experiences of their patients, and very correct experiences. But these are not my patients. They behave differently, they come from different backgrounds, they react differently. I mean, I look after people with diabetes and they'll all say, कि इन्होंने चीनी बंद कर दी, लेकिन हम गुड़ तो खाते हैं, गुड़ में कोई खराबी नहीं. That's cultural, right? Now, there's no good business happening in the US. They don't have to tell their patients that chini and gur is equally bad. You've got to do it. So you're very happy you've told them don't have chini. You think you've done your job because you were told to tell them that. But they've never stopped eating jaggery because you didn't tell them. Right? How do you manage patients in the clinic? We make a pretty bad job of this. I mean, I must confess, very bad job. Okay? And then prevention. So let me start with risk factor identification. I'm going to sort of take you through a small study that, well, it's not small, actually, it's a biggish study that we've done. But remember, I've used big examples, and I'm not saying that these are, if you're not in the business of doing biomedical research at this point of time, these could be aspirations, but these should not be your first steps, because a lot of us have reached this place by battling for 20 years, failing for 19 of those 20 years, and then managing to get something out of it. So always start small. So the first thing we realized was that if you look at epidemiological factors, we keep hearing that something causes something. You keep seeing in the newspaper that drinking coffee causes this problem, or drinking alcohol causes this problem, or doing this causes this problem. The first thing, and I possibly didn't learn it myself very well as an undergraduate student, that when you look at a bunch of people and you look at risk factors and then all that you're seeing is what they're associated with, you are not looking at causality. You are not looking at what is responsible for a disease. You're just saying that people who have diabetes are also people who are obese. You cannot, from a cross-sectional study, say that obesity is causing diabetes or is diabetes causing obesity, because you've just studied them at one snapshot, right? You can get an idea about causality if you are able to follow up people longitudinally, so that you know people when they didn't have disease, didn't have risk factors, acquired so-called risk factors, and then subsequently acquired disease. So you know this is causally linked because these risk factors came before disease manifested. So we decided to set up what we call a population-based surveillance cohort. And essentially, we looked at 3 cities. We had collaborators here. So we did Delhi and Chennai, one in the north, one in the south, and Karachi. we looked at 12,000 adults. We planned to do 4,000 adults in each of these 3 cities, more than 20 years of age. And we actually did this reasonably well in terms of representativeness, right? So as I was doing it, you can decide that I'm going to do a surveillance cohort based on all the people inside this auditorium at this point of time, right? Fine. You'll get some answers, you'll get information, but Madam is from Delhi, Doc Saab is from Bangalore / Jaipur / Delhi / Himachal Pradesh. We still haven't figured out where Dr. Katoch lives nowadays. We'll tell you one of these days. Dr. Amit Ghosh was in Chandigarh, now lives in Calcutta. Lalit did some education in Agra, now is in the... Half of you possibly don't belong to Ahmedabad. So what is the extrapolation that you're going to get from this, number one? Are you representative? Let's say all of us belong to Ahmedabad. Are you representative of Ahmedabad? You're clearly not. So for representativeness, you need to pick up your samples properly. You need to actually derive that information properly. And therefore, we went through a very painful task of a multi-stage cluster random sampling. And this is an example. So Delhi is based on the districts. Districts have got wards. Wards have got what are called census enumeration blocks. So we randomly selected districts. From that, we randomly selected census, the wards. From that, we randomly selected census enumeration blocks. We then mapped each household of each census enumeration block. And I would say proudly at that point of time that my map was better than any map in Delhi because my field staff had mapped every single household in that area. Household to household, person to person, everything was documented. And then from within households, who were randomly selected, we took people, right? So, fine, it's not everybody in Delhi, it's 4,000 people in a city of 12 million. You can say, well, this is useless information, but it's much more representative than taking a bunch of people who've, in this auditorium, or who've gone to see a Hindi movie or a Gujarati movie or whatever. So then you do sample that. And as I said, we met. And then we started working on this. So this is a surveillance cohort. It's a prospective study. So we started doing work in 2010-11, and we followed up this population ever since, right? So every year we go back to them. We don't have money to do lots of things, but every year we at least go and check, are you alive? Any problems? Have you decided? So we're interested in chronic disease. We're interested in heart disease and diabetes. That's our area of interest. So we go and say, have you been diagnosed to have a problem? Have you developed diabetes? Have you developed any heart problem? Have you seen a doctor in between? What medication have you started compared to baseline? And every other year, what we do is we actually go and get blood samples. So we have blood samples in the beginning, we have blood samples every second year, and at the moment we've reached the 5th follow-up, so we've got some information of these people, some of them who had no disease and just some risk factors, some of them who had no disease, no risk factors, but they've evolved. So we can tell you today, what is the incidence of diabetes in Delhi, in Chennai, what's the incidence of hypertension, and what are the factors which relate with it. You may not want to do the same thing in Ahmedabad, but you may actually want to look at a cohort of, let's say, again, I'm sorry for being restrictive. Let's say you run a diabetes clinic. You have a bunch of people who come to you who don't have any complications of diabetes. You're following them up every year. And some of them are developing retinopathy within a year. Some of them are developing retinopathy after 10 years. Some of them don't develop retinopathy for 20 years. You're seeing different things happening. You can actually study and see what is associated with or linked with better outcomes and what is not. And this is what I was telling you before, that cross-sectional surveys can give you only prevalence of disease, give you prevalence of risk factors, and we've got a lot of this information. Courtesy this particular ongoing study, we have now prevalence of diabetes, hypertension, heart disease, chronic kidney disease, dietary patterns, tobacco consumption, lipid parameters. We've just got truckloads of information. But more importantly, this was available before. I mean, in bits and pieces, maybe not that systematic, but it was always available. But we have longitudinal data. So we have incidence of diabetes, incidence of hypertension. which was virtually never available in. So you've heard of, most people who do any sort of chronic disease work would have heard of the Framingham cohort. It's based in a small place outside of Boston in the US. The Framingham cohort has essentially educated the entire field of medicine on cardiovascular risk, right? We believe this is our Framingham, right? And we will try and match that to get as much information for our people who don't live in Boston. They live here, right? Okay. But we decided to do something totally wacky at this point of time. And it's important. It's useful because, it's just like you get bored in the OPD seeing the same patient with, blood pressure. Every patient has a blood pressure. So you say, ye dawai thodi badha do, ye thodi ghata do, diuretic add kar do, ye kar do. So, but you need to do something which gives you a sense of excitement. So we said, but people live in households, but households are present in areas. And what do I need if I want to look at, let's say, diabetes? I want people, for prevention of diabetes, to walk regularly. I need people to eat properly. So what happens inside the house is important, but what happens outside the house is also important. I tell you, why don't you go for an evening walk or a morning walk every day? And you'll say, well, there isn't a place I can walk, right? So it's impossible for me to do what you want to say. You can keep giving me any advice. There are 60 fast food outlets in my colony. Every time I step out, I feel tempted to eat that stuff. Is that responsible for my becoming fat and diabetic? Could well be. So we decided that we'll use, and we've heard of IT, so we talked to a geographer, and they said you can actually, using Google Maps, identify all of the census enumeration blocks that we've done, right? So we stitched together a map. We then sent our field staff once again, not only to do households, but to do a physical mapping of that entire census enumeration block. So they came up and said, these are the parks, this is the roads, this is the walking paths, this is the food outlets, this is the hospitals, these are the alcohol sale outlets, whatever. So we have that information. So we have satellite imagery, and we have this. And then we said, instead of looking at mean glucose of an individual, we will decide on neighborhood fasting glucose, right? So we'll say, what's the average glucose of this entire colony? What's the average glucose of all attendees in this place? We said we'll also look at what's the average BMI in that area. We'll also look at what their physical activity clustering is, and then see whether there's any relationship between the two. And actually interesting things emerge. You can see that from the map on that side, whatever it's called, left, there's no place to walk, right? If you look at the map there, there's no green area. It's just a whole lot of high rises, and therefore, obviously, people can't walk. So it's a low physical activity cluster, and actually, as it turned out, it was also a high fasting glucose cluster. So it's important, because if you do something similar, you will tell the Ahmedabad Municipal Corporation and say, this area needs walkable paths. This area needs a park for people to walk. This area has to be secure, because if somebody wants to go for a walk, he or she shouldn't feel insecure going out. This area needs to be cleaned so that people can walk. This area needs to have better food outlets. So what I'm trying to say is managing chronic disease is not managing human beings alone, but their environment. Okay. I'm going to quickly take you through certain other examples. This is for the space of diagnostics, and this was done by an engineer. Most medical advancements in recent times have been technology driven, and you must acknowledge the fact that engineering has possibly done more for medicine than medicine has done for medicine. And the chemists have done a bit more because they've done drugs. So actually, clinicians haven't really done too much in the recent past, except they've also given up the art of observation, which is a problem. So this is a smart young engineer who essentially said, so you have these glucometers. So you have a glucometer for something, then you have another strip for something. So he's come up with this, and I'll show you that in the next device. So it's a small little device which gets plugged into your phone. So, the microphone port of your phone, it just gets plugged in. It's got a strip reader. Anything for which you have a strip, he's then started working on this. So at the moment, we have 6 different biochemical parameters which can be measured, which include glucose, HbA1c, cholesterol, hemoglobin, and creatinine. But it's the same. So it's one device. It's not a glucometer and an A1C meter and a creatinine meter. It's one device. And it goes into the phone, and you put your strip on, and it says, put a drop of blood, you put a drop of blood, and it gives you a readout. It gives you a readout which can get stored in the phone. It gives you trends. If you're connected through the internet, it can communicate to your doctor because the data goes up to the cloud, and you can actually end up. So this is just, we were involved only in the validation part, and we validated it, and it works really, really well. So, if you look at that part, the glucose thing there, that's what we validated, it works really well. So instead of buying a meter for something and a meter for something, you can actually do this. You can actually give it to the health workers and the ASHA who have a phone, and it can just go in there and it replaces that. So again, totally technology made for, we're cost sensitive, price sensitive was the word Balram used. But so it's been designed locally, it's been manufactured in China or someplace at the moment because it's just cheaper. But the issue is that it's potentially very, very useful for us. Okay. What about natural history? And this is important. This is work which was supported by the Indian Council of Medical, is still being supported by the ICMR. And we're looking at so we realize that we're getting lots of young people with diabetes. So this is a registry of people with youth onset diabetes, right? And this is simple. I mean, you can do it. This is a bloodless registry. It's just got a form. It's a questionnaire which takes down the name of the patient, whatever, parent's name, location, blah, blah, blah. When were you diagnosed? What were your sugars like? What is your follow-up like? It's just a paper form. But over a period of time, what we've done is we've taken a specific time period. So we started off on the 1st of Jan 2000. There are reporting centers across 8 cities. There are central coordinating centers or collaborating centers which acquire information from them. And people like me sit down, and we're central technical coordinating units, and we collate and make that data out. So over a period, we've got information of 5,500 people with youth onset diabetes across 6 to 8 cities. It just gives us a lot of information. So as I said, a lot of this has come from Delhi, Chennai, from Cuttack, from Dibrugarh, from Mumbai and Chandigarh, and now other states have also been added on. It tells us what proportion of diabetes at that age group is type 1, what's it type 2, is there any regional variation, which as it turned out there was there any differences in these patients, what are their complication rates, what seems to be associated with those complications, what is the incidence of complications which could be picked up because you have these patients on follow-up. We've just gone to doctors who see patients, your doctors who see patients. And all that you're doing is, instead of just doing an OPD card, you're just adding on some information onto Proforma. So it's not, you don't need high-tech instrumentation, you don't need to do genetics, you're doing nothing. A piece of paper and a pen, that's all. Because you're going to do their sugar values in any case because they're coming to you. You're going to measure their heights and weights. That's part of normal clinical medicine. You're not doing anything beyond what you are going to do as a part of patient care. So you're looking at all of these things in terms of complications, in terms of how they have comorbidities, what is the sort of treatment that you're giving, what are the treatment trends, what are the sort of insulins that they're using, what is their regimens of insulin that they're using. It is a very, very important repository of information, right? And types of oral agents which are being used, as I said, types of comorbidities, what proportion of them got a thyroid problem, what proportion of them got heart disease. It's just clinical information. But if you can then draw from it and come up with a sensible monitoring plan, and if required, a sensible therapeutic plan, that's research. Research doesn't mean looking at the 10 top single nucleotide polymorphisms of diabetes. I mean, I'm not against that. All I'm trying to say is, but that's research. This is also research because it's going to feed back to you and help you manage your patients better. Okay. This is an area which we've just sort of finished one phase off, and this was prompted by a clinical observation. The clinical observation was, and again, I'm sorry we're doing diabetes, and diabetes is not just too much. We'll do cancer next, so I'll feel less guilty after my talk. So what do you need to manage people with diabetes? You need to manage their sugars, you need to manage their blood pressure, you need to manage their cholesterol, you need them, if they're taking tobacco in any form, you need to stop them. Do we have medicines for sugar? Yes. Do we have medicines to manage cholesterol? Yes. Do we have medicines to manage blood pressure? Yes. Why is it that a vast majority of our patients are not well controlled? We know the problem. We've got medicines to fix the problems, but we do a really, really, really bad job. And I'm not talking of primary health centers doing a bad job. I'm talking of tertiary care centers doing a bad job. Everybody. At the best, 50% of people are managed well. At the best. And that's an exaggeration beyond all accounts. The same hospitals and same doctors, if you make them participate in a clinical trial, right? So everything is managed. You've got buckets of staff. You've got no shortage of money. You've got medicines. You have people ringing up the patients ki aapko to kal aana tha, aap aaye nahi, gaadi bhej dun kya? So then everything works well, right? But the healthcare system is not going to bhejo a gaadi, right? Healthcare system has got limitations. There's not too much staff. There's not so much medication. So what do? So we decided that we'll come up with an intervention study which is pragmatic, which is manageable in real life, and which is not expensive. Again, the most important thing. So the first thing we did when we looked at literature search was that there are studies abroad which have done it. There's a study in Denmark. Denmark has got universal healthcare. So it's like 50, 60, 70% taxation rates, but that is plowed back. Brilliant healthcare system. And they did a study in which they looked and they control all of these parameters, and they had 50 to 60% reduction in complications and mortality. We're not Denmark. We don't have primary health care, so we're in trouble. The thing which became very clear after a period of time was that most studies have looked at either glucose control or blood pressure control or hypertension control or lipid control or tobacco cessation, but nobody has actually ever managed to look at everything together. The patient isn't got a glucose problem. The patient has a problem which has multiple aspects. So why are we treating one of them? Right? So we then realize you need to do multiple risk factor management, and we need to look at the different barriers. The barriers could be the patient barriers. They can't afford costly medication. There's one group of patients who will come and say, Doctor Sahab, paise ki chinta nahi hai, mehengi se mehengi dawai de do. There's another group which says that I have no money to buy a 2 rupee tablet or a 50 paisa tablet. So you've got to straddle that line. There are doctor problems because doctors have inertia. They don't like up titrating. They're scared that if they increase the medication, the patient is going to run away. In diabetes specifically, they're really scared of starting insulin because they're really scared that the patient is going to shift to another doctor. One less customer. It becomes a problem, right? There could be, do we understand risk? Do we know our natural history? Are there guidelines which help us manage? They're all barriers and we don't know the answer. So we need a multi-pronged approach. And for that, what we decided to do was, we said we'll have, if you go to a shop to buy something, there's a makan malik who's sitting at the counter, paise leta hai wo khali, right? And there's a lot of little boys who are running around, ki udhar se leke aana, wo madam ko sari dikhana, wahan se piche se chane ki dal lana. So they are helpers, right? And the helper model is really good. You don't need doctors to do 90% of healthcare. So we decided we'll create a non-physician healthcare person, anybody who's like a graduate in anything, right? And then we did something, we said we'll create an electronic health record, and we will, on that electronic health record, piggyback a treatment algorithm. It sounds very fancy. I made it on the back of an envelope. I said, if this is fasting, this is A1C, we'll do this. If this is systolic, this is diastolic, we'll do this. If this is LDL, we'll do this. And then, of course, you give it to a software provider who has to convert it into language, which the computers understand. But essentially, it was whatever you do in your clinic, right? If you see a patient who comes with some sort of sugar problem and their sugar is uncontrolled, what do? You see what they're doing, what are they taking, and you increase the medication. That's what we did. So we had a composite intervention of a non-physician care coordinator, decision support, and an electronic health record, and tried to see if that's better or worse than managing people. And we looked at about just under 1,150 patients across 10 sites. I won't go into any of all this design business, but essentially what we did was this. In a standard OPD, the patient comes, right, goes to the registration desk or whatever, somebody measures or somebody may not measure their heart rate or whatever. Then they go and see a doctor. The doctor says, take this medicine, come back after 3 months with these tests, and then the patient goes off. We said, no, we'll just turn this around. We'll say the patient in the intensive arm will not go to the doctor first. The fulcrum of care of this patient is this non-physician healthcare provider. So if I'm that non-physician healthcare provider and you're the patient, I will call you and say, मैंने आपका blood test fix कर लिया, please आ जाइएगा, right? Then I'll say that, your next clinic appointment is a week later. Come to me. I will at that time do your height, weight, whatever I need to do, blood pressure. I will enter that data into the software. The software then comes up with an advisory. It says, this is what the patient is taking, this is what the patient is doing, these are the current medication, patient is well controlled, do nothing. Same treatment to continue. Or increase glucose medicine by something or reduce blood pressure medicine by something. Then me, the non-physician healthcare provider, and the patient go to meet the boss, who's the doctor, right? Doctors are the bosses, doctors can prescribe, doctors don't like listening to anybody, right? So the doctor will then say, you think I'm going to listen to a computer? Forget about it. Since this was a formal randomized control trial, the doctor was told, do what you want to, agree or disagree. If you agree, great. If you disagree, please write down why you disagree. Do what you want. But if you disagree, let us know. Right? That's it. Then the patient goes back. Doctor actually is very happy with this because all this had happened before they enter the doctor's room. Doctor needed only 2 minutes to sort the problem out. Doctors were happy. Patient was happy. Patient was getting a lot of bhav. Right? Phone जा रहा था, आधे घंटे को बैठ रहे थे, कोई कुछ नाप रहा था, कोई कुछ कंप्यूटर कर रहा था, कोई कागज निकाल रहा था. Everybody was happy. Right? And what really happened, and I'll just cut to the chase, and so this was an example of what the advisory was. It said, this is the A1C, this is it. The A1C is bad. The computer says, increase the dose of insulin. The doctor says, patient wasn't even taking insulin for the last 2 weeks. And that's real life. So I'm not going to do anything. I'm going to continue the same, right? So I will now just show you what this study did. This is completed a 1.5 years ago. We've cleaned the data, I've analyzed. Entering into this resulted in a 2.5-fold increased likelihood of meeting targets, right? And I'm saying 2.5-fold. If I wanted to sort of be arrogant about it, I would have said 250% better response. That's what people say, right? 30% improvement in this, 20% improvement in this, 20%. This is 250% improvement in outcomes. And we paid a salary which was for a graduate, whatever the salary is. We had a software which we made once and that's it. And it didn't add to cost significantly. And I'll just stop by my last bit, which is prevention, which I think is equally important because you will end up as doctors seeing a patient who comes to you for something else, right? So he's come to you for a cough and cold and you'll find the patient weighs about 150 kilograms. This patient needs to lose weight. You're missing an opportunity to prevent another disorder while you're treating the disorder for which the patient has come for. So prevention becomes critical. And this is, again, something which my engineer friend has done, and we're actually now in the process of testing whether it works, but this is a simple thing. So what we've done is we've made a diabetes prevention plan, and we've come up with lessons. So one on diet, one on exercise, one on stress management, one on something, but converted each lesson into like a reality TV. So each session is like an episode of a serial, right? One episode of Kyonki Saas Bhi Kabhi Bahu Thi, that's what that each episode is converted into. If you're participating in this prevention program, you need to have a smartphone. That's the limitation. We give you an internet coupon which lets you download that program, right? You must download them in a certain sequence. The system doesn't allow you to download it in any other sequence. There are also people who are monitoring the fact that you haven't downloaded it. You can download and not read it or see it. That's another story. We have no way of checking. You can download and somebody else in the family is seeing it. We have no way of checking. But it's there, right? But that's real life. You buy so many things and you don't use them. And then you have a health coach like in a back office who's sitting, and you get reminders and emails and prompts. So this is again harnessing technology to try and prevent progression of diabetes in a person who has a tendency towards diabetes. So as I said, so remote coaches, food information, activity, weight, just like Balram mentioned about the medicine formulary, this has the nutritive value of Indian food. So if you say I had 2 chapatis, 1 katori dal and 1 chammach of aloo gobi, it translates that into calorie, protein, fat, because we've got that information already into the system. So you know what you've eaten, right? So it's an assist. I'm not saying this is a solution. Again, this is just one of possibly a 15 million solutions for the problem. So I think what we need to do, now I'm stopping here, is to first understand that research is not something which is done en masse. You know, it's not that somebody does it sitting somewhere else. The process of your analyzing your own patient information or data is research, right? We don't need to make it fancy and esoteric and financially sort of disabling. It is your ability to extract information from what you do on a day-to-day basis, think about it, analyze it, and then make sense so that you can use it once again to do what you want to do. I want to see patients and manage their disease. That's all I want to do. But I need to make it more meaningful for them. They've come to me to be beneficiaries, right? So it has to be context appropriate. Now, yes, we got 3 patients of Ebola because they came in from somewhere, but do we really need to spend a lot of money on Ebola? We don't. Let the Americans do it, we'll take that from them, and I have no problems in that. Do we need to do work on Kala Azar if you're sitting in Gujarat? Maybe not. But if you're sitting in Bihar and we are not working on Kala Azar, then it's unfair to the people who have reposed their faith in you as a medical practitioner to solve their problem, right? It needs to be affordable. The price sensitivity is very, very, very important for our country. It has to be adjustable. You know, the jugaad is in the innovation, the adjustable part, you know. Thoda sa adjust kar lijiye. We live on adjustments in this country. But you must do that. I mean, it needs to be modifiable to suit the slightly different cultural context. It has to be adaptable, so it must be adaptable, so once it's proven its efficacy out here, it can be adapted to other milieus. Otherwise, it will not become globally relevant. But you must start with local relevance. You may have global aspirations, but do it with contextual issues. I'll stop here by just thanking Siddhant, who's the engineer, and a whole bunch of my collaborators. Thank you so much.
Thank you very much, sir, for sharing your profound knowledge with us. Your session was full of zeal and valuable information. Now, I would like to request our Mission Director, Shri Yashan Tyagi, to present a memento to Dr. Nikhil Tandon as a memory of today's program. Now, I would like to welcome our next distinguished speaker, Dr. Lalit Kumar. Dr. Lalit Kumar is a medical oncologist who has contributed to the development of low-cost medical facilities in Delhi. The Government of India honored him in 2014 with the award of Padam Shri. Sir is a professor and head of Medical Oncology Department and Dr. B.R. Ambedkar Institute, Rotary Cancer Hospital, All India Institute of Medical Sciences, New Delhi, where he focuses on multiple myeloma and gynecological malignancies. During his tenure at AIIMS, Dr. Kumar is known to have developed cost-effective treatment protocols for sustained bone marrow and stem cell transplantations. We welcome you, sir, for the presentation. Yeah. Yeah. This one? Yeah.
What happened? This is. This is okay? Right. Well, good afternoon, and I think I'll probably try to summarize a little quickly and take you on the slightly different path. Before that, I want to tell you two stories. What Professor Katoch started, and Dr. Balram and Dr. Nikhil. Most of you must have listened about the APGAR score, isn't it? All of you who have done your PEDS and Gynae APGAR score, and I hope you know how it was derived or developed. Does anybody know about it? This was by Virginia anesthetist who saw when the time of delivery, he found some children, some infants, they were pink, some were immediately responding and some were not. And he just noted down, like what is so kind of thing. And this became the famous APGAR score, which really changed the whole scene of like looking after the newborns. So that is the research, right? Another example, hand washing. In fact, this is by the end of last century, this was a Hungarian obstetrician. In fact, there is a statue, if you sometime happen to go to Budapest in near future. This is now a place of tourist attraction also. And this gentleman, I don't really remember the name, while doing the delivery, and like it's about more than 100 years old. So, and women were just dying of puerperal sepsis within the next few days. And what he simply saw that in some cases, he found they washed hands in between, just not with the soap and water, just went with the tap, just washed their hands, and they did the next delivery. And he found some of those infants and some of those women survived. So he was very perplexed. He just recorded this and he made a rule in that unit he was on duty that time, that you will, in one group, he just washed hands, allowed the staff, colleagues, that you have to wash hands, and in another group, just what they were doing earlier. And there were a huge, huge difference. That's the actually beginning of the hand washing. In fact, people call him lunatic. And he was kind of discredited for a number of years. This is only after many years people realized that what he said was really true. So that's the research actually. Okay, I thought you speak a little loudly. So that is actually what you do every day to day. From the morning to evening, what you really look after as in the medicine in your hospital, that's what you really do, that's research. You just have to observe those ideas keenly, put them record them systematically, and then see what really have done. So what we normally say, like at the end of the day, you really think what you have done the whole day. So if you do in that way, so you will be able to realize that something I did good, something I did not do good, probably I could need to improve. So that's what really research is. Okay? So now going back to this, now in the field of cancer, now after the cardiovascular diseases, this is the number 2 killer today. And you know what are the common causes or common factors which are responsible for this? Tobacco is the number 1. In any form, we always talk of smoking, either bidi or cigarette, chewing tobacco, but even the pan masalas, gutkas, and so many different forms, they are equally responsible. 50% of cancers in men are due to tobacco.
These are clearly preventable. And another 20% of cancer in women, because women also do use different forms, these kind of tobacco products are again preventable. So if you stop tobacco in any form, you will do the huge saving. So that's the one. Secondly, both my previous speakers emphasized on the lifestyle related factors. Obesity. Obesity is another important region emerging in the modern India as an important cause of cancer. Almost 25% of the cancers today are contributed by the obesity, whether it's uterus cancer, breast cancer, colon cancer, pancreas cancer, prostate cancer, they all have obesity is one of the major contributor. Diet, which again interlinked with the obesity, lack of physical activity. About 20% to 25% cancers are because of the infections. And you know the clear example of HPV, human papillomavirus. So these are some of things, so we really can do like, if we can really stop some of those things, we really need not to discuss about such of these topics. So like if you can really intervene, if you can think about those, can use those kind of the observations, what Nikhil just said, you just have to find the risk factors, you have made your observations and put them into different kind of categories, that will be the kind of research. You can really do a good job in your thing. I'll take you on a little different path, multiple myeloma, which is one of the hematological malignancies. So it will be a little more specific, but I'll see that how I really make you to understand. Now this is the data on myeloma incidence over the past 3 decades from the various cancer registries in India. We have now 29 population-based cancer registries and another 29 hospital-based cancer registries, which shows clearly that in all these registries, even though incidence of myeloma is small, and this is like per 100,000 population. But you can see like in Delhi, which has been highlighted, thus gradually increasing over the last 3 decades, both in men as well as in women. Now I have the data I just collected for your benefit, which has been in the red color for Ahmedabad. This is the data we have only from Gujarat. This is the data from Ahmedabad, which is contributed into the cancer registry program of ICMR. So this is the most recent data which has been released on 18th of last month. And you can see the incidence of myeloma in both in men. Here in fact it's like city like Thiruvananthapuram, which has the highest number. Then Kollam district in Kerala again, the Delhi number 3 per 100,000. So you can imagine like if you have a population, so a huge population, but the number looks very small, the number of patients which will be having that particular population or overall in the country, it can be very high. Unfortunately, we do not have data from other metros of Gujarat, except one paper which I found from the Patam district about the cancer incidence. Now again in women, again you can see in the pink, in Ahmedabad again, compared to this, the Kerala, the Kollam district tops the list, followed by Delhi. So Delhi and some of these areas, they really have a much higher incidence of multiple myeloma in the country. Now we did analyze some of the data on the patients who had labeled as plasma cell dyscrasia at our institute over 15 years time, and close to nearly 600 patients, and multiple myeloma was this is the whole spectrum of diseases under the plasma cell dyscrasias. And I chose this topic because I thought maybe like it may be interest to physicians, orthopedics, neurologists, endocrinologists, and so many other, because really covers the all kind of specialties here. And you can have the monoclonal gammopathy simply, and sometimes just plasmacytoma, and plasma cell leukemia rarely. And that's how we really, classically we always have been taught. If you find a person with the anemia, simple backache, most of us keep on treating with the simply painkillers, and then after a few weeks, they okay, do the X-ray, and then you really figure out that something is wrong. So if you have some middle-aged person, 50s, 60s, or 70s, if he has backache persisting, if he also has anemia, and if he has the high ESR, think of multiple myeloma as a possibility and you investigate. And some of the other investigations which have been shown here, the classic presentation, what we see in the X-rays, the punched out lytic lesions in the flat bones, long bones, compression or collapse of the spines, and in the bone marrow and the electrophoresis, we do serum and urine, you find a separate band which made out on your right side. That's called the monoclonal peak or monoclonal spike. And these are the usual symptoms. And occasionally you can have the rare presentations, even like in this case, which we saw a few years back, lady was diagnosed to have breast cancer initially. It was only after doing the FNAC we figured out this was a plasmacytoma, and we investigated that he had the other systemic manifestations of multiple myeloma. On your right side, you see another picture of macroglossia, which you can see in multiple myeloma, was the classical of amyloidosis, which is another plasma cell dyscrasia, and you have the typical Congo red stain on your right bottom, showing the birefringence. Rarely, the myeloma patients can also present like a lung cancer. As you can see in this case, the both CT scan in the black and the PET scan, which shows the bright yellow spots, showing the large mass lesion as it arising from the rib. It was a big plasmacytoma which was arising, giving a mass lesion arising from the rib, giving the appearance that could have been a case of lung cancer. It turned out to be multiple myeloma. So these are some of the odd presentations which I showed you. We also looked like what are the differences in our population compared to one of the largest work which has been done from Mayo Clinic, Robert Kyle. They had published some time back of more than 1,000 patients data. In India or in our population, the median age was more than a decade earlier or younger population, which possibly is made out because we have young population. Our 65% of population is under 35 years of age. So all the diseases which we see, whether it's a cancer or even the other non-communicable diseases, you see it at a younger age. We have 12% of people who were under 40 years of age compared to 2%. We hardly had any person with the asymptomatic. Any person, they all came only when they had symptoms, compared to almost 1/3 of patients in their population were diagnosed when they were asymptomatic because of routine screening or some test done because of some other reason. So we have higher proportion of people who came with the problems like bone pains, anemia, or renal failure. So this is actually explains what happens in multiple myeloma. The myeloma cells, they are derived from the B cells, germinal B cells, and then you have a series of, now what we believe that in each situation, each case of multiple myeloma, you first have the monoclonal gammopathy of uncertain or unknown significance. So in fact, like the Mayo Clinic done a huge amount of work. They followed a particular county in the Rochester, and what they did the blood sampling, and they found that above the age of 50 years, 1% of their population did have the M band or myeloma band in their serum on serum electrophoresis. In fact, one of my colleagues from the lab, she recently collected 600 samples from the cardiology department where the people go for their routine blood test for their cardiac workup, and we found 36 patients were found to have the M band positive, and they were subsequently sent to us, and 3 of them turned out to be fulfilling the criteria for multiple myeloma. So as the age goes up, like if you do it 70 years, the proportion can be up to 2 to 3%. This could be a simple, good research model for people here. Like if you are working in any smaller hospital or district hospital, you are doing the blood sampling for people. You can just see their blood sampling at they were 50 years or 60 or 70 years. While you are doing for the workup for other things, you can also do the serum electrophoresis. And if you find that so many % of patients comes out to be positive, they can be sent for further investigations, whether they have frank myeloma or just the M-band only, and they need to be followed up. So this will be the kind of simple basic research which can be done by any one of you. Now, following MGUS, there could be phase of so-called asymptomatic or smoldering myeloma, and followed by the classical or what we normally know as the multiple myeloma. Rarely you can have people presenting with just extramedullary disease or localized myeloma, or rarely about 3% can have plasma cells in the blood we call plasma cell leukemia. Behind all this, the most important thing which really drives this is the genetic events or damage which is happening there, the number of chromosomal changes which are really finally giving rise, making the cell immortal and giving rise to the whole picture of multiple myeloma over the years of time. Now, and as a result, people have identified that you have a certain kind of chromosomal abnormalities or translocations which can be called at high risk, and some can be called so-called the intermediate or good risk. And one of the data which we analyzed, we have like hypoploidy in almost 5% of the patients which we examined at our place, and we also look for the 13th chromosome. Almost 56% of people did have this abnormality, and 16% patients did have the 414 translocation, which is one of the high risk abnormality seen in multiple myeloma. So therefore, some of the markers for poor outcome or poor prognosis in multiple myeloma, one, the genetics, the cytogenetics findings, which I just mentioned to you. The stage 3, I'll just come to that. Presence of renal failure, which could be in almost 1/3 of patients. In another 1/3 of them, it could be reversible if provided you take the adequate steps as soon as you diagnose these patients. Or apart from this, the presence of plasma cells in the blood and high serum LDH, which again marker of proliferation, and if somebody has an extramedullary disease. Then these are some of the markers, simple clinical markers, many of them could be used in the routine practice to really identify which sort of patient need more aggressive therapy, which sort of patient need probably less aggressive therapy. And this has now become a kind of international staging system which takes care of beta-2 microglobulin, again marker of proliferation, and simple serum albumin. Based on these two parameters, in addition you can add these genetics and LDH level, and you can really figure out patients who have so-called stage 1, they have almost more than 55% chance of at 4 years remaining disease-free or relapse-free, compared to 24% who have the so-called the advanced stage. Now, so far, I just mentioned to you about the plasma cells, which are malignant cells. They're responsible for this. What is now understood is that thus not only the plasma cells, but the milieu around them in the bone marrow, the stroma of marrow, which is equally responsible. It's a kind of changes which keep on happening in the milieu of the bone marrow, which finally leads to this some sort of orchestra and leading to the whole symptoms and signs or the investigations which we normally see the abnormality in multiple myeloma. So this is like all your and as a result you have in the center plasma cells, genetic changes which acquire these kind of cumulative genetic abnormalities. In the so-called bone marrow stromal cells, adhesion molecules, and finally a number of cytokines. These are some of the cytokines which have been identified. There are many more, and these lead to the number of pathways which get activated and make these plasma cells kind of give them growth advantage, the development of drug resistance, and finally the plasma cells from bone marrow start migrating to the other parts of body and lead to the picture like plasma cell leukemia in some patients. And this is like one of my colleagues. She had just measured some of these cytokines in the newly diagnosed patients, and also some of the patients who have been treated and the time of relapse to see what really happens, which includes interleukin 6, TNF alpha, B cell activating factor, and rank ligand, which is one of the key cytokine for the bone changes which we see in the multiple myeloma. Similarly, we also compared the pre and post treatment, what really happens to these cytokines after the treatment. And some of these cytokines do go back to the normal range when after the treatment. And this really has implications in the treatment of multiple myeloma. So far, you see on the left side, we have the cytotoxic drugs. Most of you may be familiar. Some of those who were in the initial years, the only treatment for myeloma used to be melphalan and prednisolone. This is still used in some patients in the elderly population. But what we really have in the last 15 years, the drugs in the second column and third column. This is all because of the understanding which improved, which I showed you the picture, the various mechanisms, how the really plasma cells are responsible, how the surrounding milieu in the bone marrow is responsible for developing this picture. And thalidomide, you know that some of you must be knowing the old story. This was one of the drug developed by a German from 1952 and promoted as a treatment for morning sickness. This was after within 2-3 years they found that the phocomelia is one of the major side effect and the drug was banned, and this is in 1909 when they found that this was being used for leprosy in lepra reactions. But then one of the patients who has failed multiple lines of therapy, they tried this drug as an immunomodulator, and they found the person lived for 3 years time with the good remission and subsequently became the first line drug. And then the synthetic compound lenalidomide, which was synthesized and which is now one of the key component of the therapy for multiple myeloma. Then we have the series of other compounds which have been discovered, and what now recently on your extreme right, we have the monoclonal antibodies against some of the immunophenotype which are expressed on the plasma cells, are now being used in the phase 2 and phase 3 trials and likely to be available very soon they are already, one of them is daratumumab, is already available for the treatment of relapsed and refractory myeloma, but these are likely to be available for even for the first line treatment next 4 to 5 years time. Therefore, the multiple myeloma is one model which gives you like initial therapy, what we call so-called induction therapy, followed by consolidation and then maintenance therapy. All patients of myeloma, we normally give them the supportive treatment like with the bisphosphonates, and if there is any severe anemia, then need to be blood transfusion, and the infections which need to be adequately controlled. Now this is the usual kind of algorithm which we follow in our day-to-day practice. People who are 65 or 70 years of age, no major issues. After initial treatment of 4 to 6 months, you take them for the, if they respond, you take them for the stem cell transplant. Now, number of therapies which are being used, I said the steroids are one of the key component, and along with this, we use one of the immunomodulators and also the proteasome inhibitor. So currently, the 3-drug regime is one of the choice of treatment for all patients of myeloma, especially those who are 65 to 70 years of age. And this is what a small trial which we completed 2 years back. We compared thalidomide because that was the one which was available in Indian market and to us, and then subsequent 2006, LAN came in the market, and that time we did not have too many other drugs. So we just compared because thal is very cheap for us. LAN also is relatively cheaper in India. In fact, nowadays lenalidomide is being exported to many of European countries and to the US. Also many patients do get from here because it's very expensive there. So this is because of the generic brands by pharma companies in India that we really have this kind of liberty. We use them routinely for almost everybody. And we found that there were really no difference in their response rate between the two combinations. And both also in the survival, both overall and progression-free, we did not find any major difference. Subsequently, now we are doing a combination, the comparison between the proteasome inhibitor along with the previous combination of lenalidomide and dexa with two drugs. Again, the response rate seems to be, this is still too early data, there is difference in the complication and side effects, but there seems to be probably, they both seems to be almost similar, both in terms of response as well as in the survival. But we really have to just follow, this is ongoing. Let me just take you to another path, the autologous stem cell transplant. Now, stem cells are responsible for the hemopoiesis. Right? Very simple words, we all know about it. And myeloma is the #1 indication internationally today for stem cell transplant, hemopoietic stem cell transplant, and they are followed by the lymphomas at the autologous stem cell transplant. And we have now Indian Stem Cell Transplant Registry, which collects the data, and till year 2014, we have almost 9,000 transplants which have been done. The data for 2015 is, I don't have the slide, but nearly almost 14,000 patients have, whatever the record we have undergone stem cell transplant in the country, which also includes the data from GCRI by Dr. Sandeep Shah. And this gives you the picture of autologous versus allogenic. We have almost half of the patients of autologous transplant are being done for the multiple myeloma. These are the various procedures. Like I just pass quickly, these are some of the, we have to put a central line for the venous axis. I'm sure most of you must have seen this kind of thing. And subsequently, the stem cells are mobilized by giving the growth factors or GCSF. This again the apheresis machines, which again many of you may have seen. And subsequently, once you collect these stem cells, you take back to the lab, take a sample, do the CD34 count, which is one of the marker for stem cells, right? And what we have seen in our experience, on day 4, we normally do the stem cell collection on day 5. On day 4, if you do the peripheral blood CD34 count, which correlates with your stem cell yield on the next day. So sometime if you find your peripheral blood CD34 count is less than 20, there is almost quite high chance that you may not have the adequate collection next day. In those cases, you have to use the alternative methods. And subsequently, once stem cells has been collected, kept in the refrigerator, either at 4 degree, or you can store them if you are doing transplant later on, long term later, then either at -80 degree, which is reasonable for almost 6 months to 1 year, or even longer time, then you have to do the liquid nitrogen. And once you have done the chemotherapy, what we call so-called conditioning, then these can be brought back and given infusion through the central line which you have inserted. Patients do receive some prophylaxis with antibiotics, antivirals during the period of severe neutropenia and thrombocytopenia, which they will have briefly for almost a week. You can see this, like by day 5 or so, the blood counts, the neutrophils becomes 0 and remains so for almost 1 week, and then subsequently patient recover. During this time, they will need the quite utmost care, so any antibiotics, IV alimentation, etc., etc. At the institute, we have been doing transplants for myeloma. We have now crossed more than 300 transplants. This just showed you the number of transplants being done over the years. And I'll just give you a little data of first 225 patients we have the more than 2 years from the last transplant. In this, almost half of these patients do achieve complete remission. That means by immunofixation, you do not find any trace of ambient in these patients. And like if you see the survival, those who achieved complete response, the median progression free, that means there are no relapse, 89 months, more than 7 years. And at 15 years, 18% of patients were continued to remain disease free following transplant. And if you see the overall survival at 15 years, it was 38%. This is something quite good figure for multiple myeloma, the disease which till 1990, which used to be considered to be the so-called, the median survival used to be 2 to 3 years. And this is like what you see that patients on the top curve, the complete response, the both overall and progression-free survival, you can see compared to the other categories, there is significantly better outcome for these patients. And we also figured out patients who achieve complete response, they have significantly better outcome, and also the based on the stage and prior therapy which they have received. Following transplant, patients are given maintenance therapy for 1 to 2 years. You can, so far there is really no consensus. People can use either one of these drugs in the smaller dosage, which we normally give. And what has been shown that even with the maintenance, another 5 to 10% patients would upgrade their response. As we have seen, almost another 5% do convert it to the complete response. We also compared that patients who did not undergo transplant during this period. We just compared this is not a randomized trial, we just compared their data with the patients who were 65 years of age or less and whose kidney functions per creatinine was less than 2.5. And what we found, patients who underwent transplant had significantly better outcome compared to those who did not go under transplant except only received the so-called the medical therapy. I'll just pass on to this minimal residual disease because that's the, despite transplant, some patients of complete response who achieve, some patients continue to remain long-term survivor, but some patients do relapse. To address this issue, we did the minimal residual disease, which was based on the some of these markers or immunophenotyping, which is done by the flow cytometry. Those who have worked in the lab, they will have some idea. These are some of the immunophenotype which we took as one of the marker for myeloma to really see these cells, which they are expressed or not. And this is how we really defined. And the 71 patients, which one of our postgraduates did as a part of his dissertation. And what we really found that almost those who were MRD negative, nearly 46% of patients became MRD negative. The importance of this is like those who are minimal residual disease negative, that means they have further the load of the disease is much lower in their bone marrow. So this is almost comparable to another large study which was published recently. So to summarize, for all patients of myeloma today, those who are so-called transplant eligible, that do not have the major comorbidities, then one need to really give them 3-drug regime and maximize the response, followed by transplant and followed by maintenance. That's currently the model for what we really follow for multiple myeloma. And if you see the therapy outcome, patients who are receiving only conventional or drug therapy today, the outcome for myeloma has gone to 5 to 5.5 years with some of these new molecules. But those who undergo transplant, the outcome is median almost 9 years, almost nearly close to double. But those we still have problem with the patients who are elderly, more than 70 years, who are so-called transplant ineligible. There the median survival still remains like 3 to 3.5 years. So these are some of the kind of data which is, so what we really have seen in our experience, that biology of myeloma appears to be similar, at least, and it's not really different. We have just more advanced disease, and we need little more data whether the cytogenetic pattern is similar or really different. And the rest of the therapy response and the transplant outcome also appears to be similar. We still have about almost 1/3 of patients who have the either stage 3 disease or abnormal cytogenetics or so-called high risk. These are the patients who really have poorer outcome despite the transplant. And they we really need to really see how we can really improve the outcome. Thank you so much.
For sharing the valuable knowledge with us. I would request our Mission Director Shri S.N. Tyagi to present a memento to Dr. Lalit Kumar as a memory of today's program. I would like to thank once again all the eminent speakers for the wonderful sessions for the first technical session. Now we will break for a lunch, and since all our speakers have to board an early flight, I request all the participants to assemble back in 30 minutes so that we can start with the second technical session. Thank you.
Welcome you all on second technical session for the seminar Biomedical Research in Gujarat. We have slight change in the schedule. As Dr. Sharma has to leave early, we reschedule the lecture of that is New Avenue of Stem Cell Research earlier. So I would like to invite Dr. Alka Sharma. Dr. Alka Sharma has been handling the area of stem cell research and regenerative medicine, biodesign program, focus on implants and devices and in vitro diagnostics, genomics and clinical proteomics at Department of Biotechnology, Government of India. She has been instrumental in facilitating the making of guidelines for stem cell research and therapy. She has also been involved with preparation of DNA profiling bill for the country. Please have a huge round of applause for Dr. Sharma.
Thank you. Good afternoon, everybody. So this is a post-lunch session. So now the topic is stem cells in regenerative medicine. So now I will share with you the current scenario and future strategy for research, capacity building, and policy in the area of stem cells in regenerative medicine. First of all, I would like to highlight the salient features of National Biotechnology Development Strategy 2020 approved by the government. This is an outcome of the formal and informal consultations with over 300 stakeholders, including scientists, policy makers, industry, NGOs, regulators, and international experts. The strategy emphasized the need for building a skilled workforce and leadership. This includes a specialized training program for professionals, new career options for students, faculty improvement program, attracting skills for imbibing the scientists and postdoc. Details of the training programs and also for the students are available on DBT websites. Whosoever is interested in applying for these programs, please visit DBT website and you will find details. Building knowledge environment is one of the key components of this strategy. This covers establishing specialized centers in and around existing institutions, creating core facilities and instrumentation across the country, strengthening medical colleges, creating national institutions, data centers, and repository at various places based on the expertise and experience of the PI. The strategy also emphasized the need to extend support to basic science, promoting multidisciplinary research in biology, attract non-biologists to address biological questions, encouraging emerging technologies such as synthetic and system biology, nanobiotechnology, imaging, bioinformatics, stem cells and regenerative medicine, and also fostering global and national alliance. For nurturing innovation and entrepreneurship, broad principles for guiding principles includes to support translational research and also to build translational capacity in all major research centers, to provide support for business incubation, infrastructure, technology validation, testing, scaling of infrastructure, and also to promote public-private partnership and so on. As per the strategy, the emphasis is on promotion of excellence, innovation. Programs are being supported through various schemes such as Center of Excellence, global partnerships, grand challenges, public-private partnerships. Translational research platforms have also been created to facilitate technology development, validation testing, and product development. Bioclusters have been established at various places to share ideas, expertise, infrastructure, resources amongst the partnering institutions. Theme-based autonomous institutions have also been established across the country. Stem cells, autonomous institutions on stem cell science and regenerative medicine is one of them. It has been established as Bangalore by the Department of Biotechnology. So, under biomedical research, stem cells and regenerative medicine was identified as one of the thrust areas by then Secretary Ma'am Dr. Manju Sharma in 2001. Since then, efforts are being made to promote this area in an integrated way. So, as you know, stem cells are unspecialized cells, have capability to renew themselves. Since this discipline is only more than 1.5 decades old, research is being conducted all over the world to understand how these cells work and how the potential of these cells may be harnessed for therapeutic applications. Though stem cells are present during all stages of human life, right from fertilization up to adulthood, their plasticity varies based on source of these cells. At zygote stage, it is totipotent in nature. It can give rise to whole organism. At blastoid stage, it is pluripotent in nature. It can give rise to various cells and tissues, but not whole organism. At blastoid stage, it is multipotent. This slide shows the concept why there is why this stem cell research in exciting field of life sciences. Stem cell research is important due to various reasons. This provides scientific knowledge for embryonic development and also understanding prevention and treatment of birth defects. Potential therapeutic applications of these cells can be harnessed, as any disease where there is a degeneration can be a potential candidate for stem cell therapy. Research is also being conducted to use stem cells for screening of drugs and toxicity testing for pharmaceutical companies. Though clinical trials are being conducted all over the world using autologous and allogenic stem cells to establish safety and efficacy of these cells, researchers still have to go a long way to offer stem cell therapy. So, a strategy for stem cells in regenerative medicine has been formulated in consultation with national and international experts. As per the discussion held, this has been classified broadly under two categories, that is early translational research, which includes basic research to obtain research leads, and preclinical studies to establish safety and proof of concept. However, late translational research includes pilot studies and clinical trials for various human diseases. In addition, strategy also includes academic industry partnership, capacity building, and to formulate an appropriate regulatory framework in the country. So, based on deliberations, short, medium, and long-term strategy have been formulated in this area. Short-term includes thorough basic research on all kinds of stem cells, that is embryonic stem cells, induced pluripotent stem cells, and adult stem cells, to understand how these cells work and how the potential of these cells may be harnessed for therapeutic applications. This also includes generation of human embryonic stem cell lines, reprogramming of adult stem cells, that is generation and characterization of induced pluripotent stem cells and its differentiation into different lineages, creation of animal models for various human diseases, also to support translational research, that is preclinical studies, pilot studies, randomized controlled trials for various human diseases. And in under infrastructure, the Institute for Stem Cell Science and Regenerative Medicine has been set up at Bangalore, where CMC, DBT Center, which was established in CMC before this institute, is now a translational unit of this institute. And also the strategy include creation of infrastructure and building capacity in the country in this area. And the last but very important, that to frame an appropriate regulatory framework in the country to handle stem cells. Medium and long-term strategy include understanding of developmental biology and disease biology, to explore potential applications of adult stem cells for various disorders, to continue support for pilot studies and randomized controlled trials, building partnerships with industries and also international organizations, to explore potential applications of stem cells through gene therapy approach, and to convert the existing guidelines into an act. This is medium and long-term strategy. This is already in the process in the government. This slide shows the geographical locations of the institutions, medical schools and industries where programs have been supported, infrastructure and facilities have been created across the country. A number of programs on various aspects of stem cells, that embryonic stem cells, induced pluripotent stem cells and adult stem cells have been supported. A separate task force was constituted to deal with the new projects and also the monitoring of ongoing projects in this area in 2003 by Ma'am Dr. Manju Sharma when she was Secretary in Department of Biotechnology. Now since 2003 we have this task force in place, and this task force is also actively working for formulation of a strategy, guiding us on regulatory aspects and also supporting programs on various aspects of stem cells. Under new initiative, the focus is on developing stem cell technologies for developing possible treatment for brain and blood disorders. The aim is to use stem cells technology to study genetic basis of mental illness. For this, a collaborative program has been supported at NIMHANS, Stem Cell Institute, NCBS, and 5 cohort studies have been supported under this. This will also have a repository of IPS and conduct genetic analysis. This program is conceptualized around the generation and characterization of induced pluripotent stem cells taken from the patient. Basically, it is a patient-derived induced pluripotent stem cell. So, induced pluripotent stem cells can be generated through reprogramming of somatic cells taken from the patient by introducing a set of transcription factor. Once we get this patient-derived iPS cells, then we can have a repository and then the studies can be carried out to study the underlying mechanism in brain disorders. Similarly, for blood disorders, program has been supported using patient-derived iPS cells to study sickle cell anemia, beta thalassemia, and also to try the possible treatment for these diseases, as these diseases are single mutation diseases, so gene therapy approach can be used here. And this also include to create a haplobank of HLA-matched homozygous individuals. So this is a concept on which this program has been supported under new initiative. So as we all know that allogenic hematopoietic stem cell transplantation has its limitation. So patient's own bone marrow cells, that is autologous hematopoietic stem cells, can be taken. Defective gene can be corrected using either genome editing approach or lentiviral vectors, and then we can get disease-free hematopoietic stem cells, and that can be transplanted back into the patient. Similarly, the patient-derived iPS cells can also be, the defective gene in a patient-derived iPS can be corrected using gene therapy approach that includes de novo editing and lentiviral vector, and we can get disease-free iPS that can be further differentiated into hematopoietic stem cells, and those hematopoietic stem cells can be transplanted back into the patient. At present, there is no regulation in the country to deal with this kind of study, but ICMR and DBT are working together to formulate guidelines and also take this guideline further with Ministry of Health and Family Welfare for approval, so that this work can be done, and this is something that will help us in finding possible treatment for sickle cell anemia and beta thalassemia. So coming to the translational research, as we all know, globally there are concerns about translational research, especially clinical trials. Too many small studies have been conducted so far. Some of them are even without control. There is a difficulty in measurement of safety and efficacy of these cells. So this strategy also promotes randomized controlled trials, where scientific scrutiny suggests that it is ethical and reasonable for the benefit of the society. But as you are aware, there are many issues that clinical researchers are facing at the moment. What would be the source of the cells, which organ, whether it's autologous allogenic, what would be the dose of cells, what would be the route of administration, what is the mechanism of action, and also the parameters to assess the outcome. So most of the questions can be answered by having an appropriate animal model for the human disease. So this is the flow diagram which we follow at Department of Biotechnology to consider any clinical proposal. Once we receive a concept paper or the full proposal for conducting clinical trial for any human disease, we invite experts in that field and for brainstorming. Based on the scientific data available globally and nationally in animal studies and also in some cases human studies, we are based on a discussion and the data, we decide whether we are ready to go for human studies or not. If we take that proposal further, then this proposal is being considered by 4 committees basically. Human Studies Committee evaluate the clinical research protocol of the proposal. Ethics Committee considers from ethical point of view, and then Stem Cell Committee from scientific technical point of view, and at the same time the proposal has to be cleared by the Institutional Committee for Stem Cell Research. That is the responsibility of the institution to constitute Institutional Committee for Stem Cell Research as per the composition given in the guidelines. Guidelines for national guidelines for stem cell research is available both on ICMR and DBT website. The composition can be downloaded from the website. Based on the recommendation of these 4 committees, the program is being implemented, and also depending on the nature of study, we also require approval from DCGI, the Controller General of India. For each clinical trial, it is the responsibility of the sponsor to constitute Data Safety Monitoring Board. We at DBT, we constitute DSMB for each clinical trial to monitor the trial, specifically the safety of the patient. Following this procedure, we have now implemented a number of pilot studies and randomized controlled trial. As I mentioned earlier, this is a picture of Stem Cell Science and Regenerative Medicine Institute at Bangalore, and they are focusing on collaborative research with the international organizations as well as in the country. And this translational unit, that is a center which was supported by DBT, this is now a translational unit of this Stem Cell Institute. They are working together. Translational work is being done at CMC, basic work is being done at INSTEM Bangalore, and the leads are being taken up further by them, the clinician at CMC, clinical researchers. So this slide shows the infrastructure and facilities created across the country. So clean room has already maybe that during 2006 and 7, these clean rooms were supported at SGPGI, PGI Chandigarh, KEM Hospital, LD Prasad Eye Institution. Now after that, some of the clean rooms were added, and now CGMP facilities have been supported at CMC Vellore and AIIMS New Delhi. Both the facilities are fully functional, and anybody is free to use these facilities. And if you want, I can give you the contact details of the individual who is dealing with these facilities. And the both CMC and AIIMS are utilizing this facility optimally. So this is we have number of schemes for human resource development at both undergraduate and postgraduate level, and also we have various scholarships, fellowships program for PhD students, and even after completion of PhD, we have DBT Welcome Trust Alliance, where there are fellowships are being provided at 4 level, entry level, middle, senior, and the distinguished. And the Ramalinga Fellowship Program is also a very attractive program for the people who are in working in international organization. They want to come back to India. So this is being provided, fellowship is being provided initially for 5 years to come here and also try to work with the institutions of their interest. Then we have a fellowship for innovation and entrepreneurship in biodesign, and there is a scheme called Rapid Grant for young investigators. So here I would like to emphasize that details are available on DBT website, formats are available for various categories, as I mentioned, Center for Excellence, R&D, Societal Development Program, and others. So please visit DBT website and also see that if you can apply under, depending on the nature of your study and also your interest, you can choose the format and also build a group and subgroup to discuss that and how to write a proposal in a manner that the scientific merit of the proposal is clearly articulated in the proposal. And as per, we have tried our level best to bring the topics under which you have to articulate your research problem and objectives and work plan. Even if you have some problem with any of the topics or format or any issue related with the project submission, you are free to send me a mail, and then I would be happy to help you in this. And we will, as our discussion held with Ma'am Sharma in the morning, will try to conduct a workshop where we can discuss this topic in detail, that how you people can write a multi-institutional, multi-investigator projects to deal with the issue which in the area you are working in. So, though efforts have been made to put in system in place, there are challenges before us in this area. This is an emerging field of life sciences. We all know it is a multidisciplinary field. So human resource of desired expertise is a limited factor. There is a need to promote interdisciplinary research by bringing scientists from other disciplines also, for example, developmental biology and animal veterinary sciences also, because for creation of appropriate animal model for various human diseases, we need veterinary science people in the group. And also we need to promote close interactions amongst clinicians, basic scientists and industry to identify important research questions. And there is also a need to create an interconnected, well-managed stem cell research enterprise for getting approval from clinical trials from the government. And this is now high time to convert the guidelines which have been formulated by the government into a legislation. So now briefly I will take you through a journey of the guidelines which have been prepared for stem cell research in the country, and it is very important for the scientists, clinical researchers and industry whosoever is involved in the field to follow the guideline strictly in this area. So I would like to mention here this the ICMR and DBT jointly formulated guidelines for stem cell research and therapy in 2007, and this and the public consultation was organized at 5 places in the country, and based on the feedback received from scientists, clinicians, patient group and industry, this document was revised and this was finalized in 2013. So the guidelines are available on ICMR and DBT website. That is a 2013 version, that is a revised version of the guideline. This is the cover page of the guideline. So in this guideline, it has been mentioned that these guidelines are only for research and not for therapy. If you can notice this in the earlier one, the title was Guidelines for Stem Cell Research and Therapy. But since it is not a standard care, as of now it is not a standard care medicine for in the system, so this has been now, therapy word has been omitted. And this the title of the guideline is National Guidelines for Stem Cell Research. And this applies only to use of human cells for basic research and translational research. No animal research using stem cells from animal is included in the revised guideline. Some of the chapters have been modified and also new chapters, for example, tissue engineering, IPS, translational research have been added in the revised guideline. These guidelines do not regulate use of hematopoietic stem cells for treatment of various hematological, immunological and metabolic disorders, as it is already well established procedure. And as I said, it is not a part of standard therapy. The word therapy has been omitted from the revised guidelines. So as per the guideline, the stem cell research has been classified under 3 categories, that is permitted. The research dealing with adult stem cells and umbilical cord blood stem cells falls under permitted category of research. Creation of zygote to derive human embryonic stem cell lines, clinical trials using human embryonic stem cells and IPS or any other stem cells after major manipulation has been covered under restricted category, and human germline gene therapy, reproductive cloning and so on are prohibited. This document also describes the roles and responsibilities of investigators, institutions involved in stem cell research and the sponsor. So the investigator is responsible to generate robust scientific evidence by conducting clinical trials for various human diseases. This is it is the responsibility of the institutions to create and constitute in the institutional committee for stem cell research and also maintain registry of the investigators who are involved in stem cell research in the institution and maintain records for clinical trial using adult stem cells. Record has to be maintained for 5 years, and for human embryonic stem cells records have to be maintained up to 10 years. And the sponsor is responsible to monitor the programs and also clinical trials supported to the institutions, medical schools and industry. For all stem cells, it requires some degree of in vitro and ex vivo proceedings. So it has been classified under minimal, more than minimal, that is substantial and major manipulation. So basically under minimal it is clearly articulated that no intended alteration in cell population. Simply centrifugation, separation of cells and injection introducing those cells back to the patient. More than manipulation, that is substantial manipulation, includes alteration in cells population, that is expansion, ex vivo expansion, cryopreservation, and regulated differentiation of human embryonic stem cells and iPS cells into desired cellular products, that is differentiation into different lineages. Genetic and epigenetic modification of stem cells fall under major manipulation. So, Department of Health Research, and that is under Ministry of Health and Family Welfare, has constituted a National Apex Committee for Stem Cell Research and Therapy. This is a multidisciplinary committee, and the terms of reference of this committee is to provide general oversight and formulation of policy, review of specific controversial or ethical sensitive research and proposals for therapeutic use of stem cells. This committee is also responsible to examine scientific, technical, ethical, legal and social issues in the area of stem cell based research and therapy, and to review the revision and updation of guidelines for stem cells in regenerative medicine. So this is the website for National Apex Committee for Stem Cell Research and Therapy. Though therapy word has been omitted from the guidelines for national guidelines for stem cell research, but this is included in this committee because this committee is responsible to see that if any clinical trial is being conducted in the country and therapy is being provided by the organization or any labs or institution, it is illegal as of now because it has not been established as a standard care of therapy. So coming to the translational research, preclinical studies are essential before conducting clinical trial, and this is important to establish safety and proof of principle using stem cells. For small animal, approval is required from Institutional Animal Ethics Committee, and for large animals, the approval from CPC-SCE is mandatory. Clinical trials using stem cells should adhere to Schedule Y of Drugs and Cosmetic Act, GCP guidelines of CDCSO, and ethical guidelines for biomedical research. The cells being used in clinical trial must be of clinical grade, and for this we need CGMP facility for manufacturing, producing cells of desired source. And as I already mentioned that DSMB has to be constituted by the funding agency, and the independent members should be the part of DSMB, and these members should not be involved in any manner in the clinical trials for which they are in the committee. And these members should not be associated with ICSCR, that is Institutional Committee for Stem Cell Research, and National Apex Committee for Stem Cell Research and Therapy. So this approval and monitoring of clinical trial depends on many factors. Some of them are source and type of stem cells, nature of cells, whether it's autologous, allogenic, what degree of manipulation, what is the stage of research at international level and also in the country, and is there any evidence of progress of similar research at globally and also nationally, and whether the proposed cell-based therapy research intended for developing a marketable product or academic institution research for advancement of knowledge. So in my next slide, I would like to tell you the path which is the path given as per the process given in the guidelines. So for any clinical trial, it depends that what is the nature of a study. If it is academic trial and source of the cells, as I said that whether your experiments based on the minimal manipulation, more than minimal or major. If it is a substantial, that is more than minimal and major, approval from DCGI is mandatory, whether it's an academic trial or marketable product. Marketable product here is allogenic. So basically, nowadays you have heard that the mesenchymal stem cells are being stored and it is being used for various clinical trials to establish safety and efficacy of these cells. If it is an academic trial, then approval from ICSCR, Institutional Committee for Stem Cell Research, and also the existing procedure in the funding agency will be followed. As I showed the flow diagram, what we are doing in DBT, if we receive any clinical trial proposal, we follow that path, and also we ask for the approval from ICSCR. We have an independent task force, we have Human Studies Committee, Ethics Committee, and also it depends if it is, and it falls under substantial manipulation or major manipulation, this has to go to NAC-SCRT also. But if it is a marketable product, even in-house, it is not being submitted to any funding agency, in that case also it has to be submitted to DCGI and also NAC-SCRT for approval. So as of now, there is no approved indication for stem cell therapy as a part of routine medical practices other than hematopoietic stem cell transplantation, as I mentioned earlier. Accordingly, all stem cell trial other than hematopoietic stem cells should be treated investigational and should be conducted in the form of clinical trial after getting necessary approvals from the respective committees. So this is the message I would like to give, that any stem cell used in patient is investigational. It must only be done within the purview of an approved and monitored clinical trial and not offering it as therapy. Thank you.
Thank you. Thank you, ma'am, for sharing valuable insights on stem cell research. I would like to request Ms. Anshuya Lahiri Badilkar to present a memento to Dr. Alka Sharma as memory of today's program. Thank you, ma'am. Our next distinguished speaker, we have Dr. S.P. Agarwal. Dr. S.P. Agarwal is a distinguished orthodontist, implantologist and director of Green Park Dental Institute and Research Center. He has worked at All India Institute of Medical Sciences, New Delhi, and established new norms for Indian population for various indices used in dentistry. He has been conferred upon with a number of prominent fellowships, including the Fellowship of American College of Dentists in 1998. He is also recipient of the National Excellence Award in the field of surgery in 1997. Dr. S.P. Agarwal has been bestowed upon the honor of being appointed as Honorary Dental Advisory Consultant to the Armed Forces Medical Services, Ministry of Defense, Government of India. Apart from mentoring for many companies, he runs an implant course at the Green Park Dental Institute in the New Delhi. Please welcome, I welcome Dr. S.P. Agarwal for this session.
Good afternoon, friends. सबसे पहले मैं डॉक्टर मंजू शर्मा जी को मेरे को यहाँ बुलाने के लिए इस गैदरिंग में, एंड मिसेस अंसुया लाहिरी जी को जो बार बार मेरे को फ़ोन करके कह रही थी, सॉरी, किस समय आप आएंगे, क्या है, आप लोग जो यहाँ सुन रहे हैं इतनी देर तक, उससे मैं सब हटके हूँ, मेडिकल साइंस से थोड़ा सा हटके हूँ। पूरा आधा घंटा लूँगा, 1 मिनट भी ज़्यादा नहीं। कोई भी प्रेजेंटेशन से पहले माई ट्रिब्यूट टू माई फादर and sincere thanks to my Guruji who gave me the masters from King George's Medical College, Lucknow. Start with, सबसे पहले त्यागी साहब ने आज बताया पैसे की कोई कमी नहीं है हमारे यहाँ, तो कोई कमी नहीं है, जितनी ग्रांट चाहिए। और हम सब जानते हैं पॉपुलेशन की कोई कमी नहीं है। इंडिया इज, एंड वी नो इट, द इंडिया इज नंबर 1 इकोनॉमी इन द वर्ल्ड। तो किस चीज की कमी रह गई? उसी चीज को मैं भी आपको बताने जा रहा हूं, किसी चीज की कमी नहीं है। जब मैं लखनऊ में पढ़ रहा था तो बॉस ने मेरे को फाइनेंस किया था स्टडी के लिए। ये छोटा सा क्लिनिक था कुछ समय पहले। कमी है खाली विल पावर की। आई केम टू इंस्टीट्यूट, और अब इंस्टीट्यूट के बगल में ये मेरा प्रेजेंट इंस्टीट्यूट है। आज जैसे ललित साहब ने मल्टीपल माइलोमा के बारे में बताया, बलराम जी ने बड़ी छोटी छोटी चीजें, सुंदर सुंदर नई नई टेक्नोलॉजी। इसी तरह से मैं आज कुछ एक पॉइंट को लेकर डिस्कस करूंगा, क्या कर सकते हैं। दिस इज अ प्लेस वेयर वी कंडक्ट द कोर्सेस, नंबर ऑफ देम। सो व्हाई आर वी हियर टुडे? Biotechnology, application of the principles of engineering and technology to the life sciences. अब जब भी हम इसकी बातें करते हैं, whenever we talk about, we only talk about bones, heart, lung, stomach and muscles. ये कहाँ छूट गया? ओरल कैविटी। जब एम्स में थे तो हर कार्डियोलॉजिस्ट, हर कार्डियोथोरेसिक सर्जन सबसे पहले कहता था डेंटल क्लियरेंस लेके आओ। फोकाई कहाँ है? अगर फोकाई होगा तो नहीं करेंगे। सबसे ज्यादा टीकेआर, टोटल नी रिप्लेसमेंट का फेलियर का कॉज मुंह में है। अगर देखना चाहें तो फिर से एक एक करके, व्हाट इज द माउथ बॉडी कनेक्शन? द फर्स्ट क्वेश्चन, थिंक अबाउट इट। माउथ इज द मिरर ऑफ द होल बॉडी, वी ऑल नो अबाउट इट। कहीं कुछ रह गया? क्या रह गया? एक एक करके डिस्कस करते हैं। हार्ट का हम सब जानते हैं, खाली एक चीज किताब में लिखी होती थी, साबे साबे, सब एक्यूट बैक्टीरियल एंडोकार्डाइटिस। उसके बाद 50 चीजें आ गई, एक नहीं है। कहां से? ओरल बैक्टीरिया एंटर द ब्लड स्ट्रीम, अटैच टू द फैटी एसिड इन द कॉर्नरी आर्च एंड ऑल। व्हाट दे कॉज? बेसिकली क्लॉट फॉर्मेशन। भाग के जाके बाईपास कराई, एंजियोग्राफी, एंजियोप्लास्टी। किसी ने मुंह में झांक के देखा? क्लॉट फॉर्मेशन तो यही है। कितने पेशेंट आते हैं, सर ब्लड थिनर नहीं बंद कर सकते, डॉक्टर ने मना करा 6 महीने साल भर, तो मुंह में जो पस पड़ा उसका तो ट्रीटमेंट हो ही नहीं सकता, हो ही नहीं सकता। कभी सोच के देखें बाएं तरफ से, बहुत सारी चीजें। डायबिटीज, डॉक्टर साहब निखिल साहब ने इतनी डिटेल बताई, एक एक चीज। इन माई ओपिनियन डबल शॉट। मेरे पास कितने पेशेंट हैं जिनके मुंह में पस पड़ी है, ब्लड शुगर जम कर रहा है, HbA1c 11 है, 12 है, नंबर ऑफ थिंग्स। सब जानते हैं सेप्सिस से ब्लड शुगर बढ़ती है, ब्लड शुगर से सेप्सिस बढ़ता है। छोटी छोटी चीजें, ये सब पिक्चर हैं जो आप देख रहे हैं, जिंजिवाइटिस, पेरिडोंटाइटिस। हम लोगों ने सर्वे किया ऑल इंडिया बेसिस पे, जो हमारे अर्लियर डीजी थे SP अग्रवाल साहब के साथ मिलके, एंड वी फाउंड प्रैक्टिकली 99% पेशेंट में पेरिडोंटल प्रॉब्लम है। कैंसर को छोड़ दीजिए, ओरल कैंसर तो जो डॉक्टर साहब ने बताया आज कि कितना ज्यादा है, बिकॉज ऑफ पान मसाला, सुपारी, वो अलग चीज है। बेसिक यहां पर है, इससे 2-वे रिलेशनशिप। इसी तरह से लंग डिसीजेस, COPD, सारा बैक्टीरिया कॉज तो यही है। ओरल कैविटी इज मोर इन्फेक्शियस देन एनल कैविटी। कभी एक बार झांक के तो देख लें, सोचें, प्रेगनेंसी में ये दवा नहीं खाना, वो दवा नहीं खाना। कहा गया एंटीनेटल चेकअप में, क्यों नहीं खाना दवा? बुक्स में लिखा हुआ ये दवा खाली मना है, सब खा सकते हो। 2-4 दवाएं जो है फार्मा की किताब में मना है। तो हमने क्या करना क्या है इसके अंदर? इन सब चीजों का ध्यान रखना है। गम डिसीजेस, दे कॉज द बैक्टीरियल इन्फेक्शन, बैक्टीरिया प्रोडक्ट्स एमनियन एंड अल्टीमेटली प्रीटर्म लेबर एंड लो बर्थ वेट बेबीज। वेल एस्टेब्लिश्ड। GIT का पहला सिस्टम कहाँ है? Ever thought about it? Oral cavity. आप एंडोस्कोपी कर लो, कुछ कर लो, जरा इनको पिक्चरों को तो देखो. ऐसे दांत से stomach has teeth? No. So my submission is कि हम कैसे पेशेंट्स को दांत दे सकते हैं. जब तक वो च्यू नहीं करेगा तो आप दुनिया भर के अल्सरेशन और बाकी सब चीजें करते रहेंगे. कहां से होगा? इंडाइजेशन. बायोटेक्नोलॉजी का जो पुराना समय था, इट्स डेट्स बैक. अगर पुराने फोटो देखें तो पुराने जमाने में भी लोग सब दांत लगा के रोक देते थे. अब ये नहीं हो सकता. What are the options to replace missing teeth? And very simple. Either you give them the dentures. आज की डेट में कोई लाइक नहीं करता. ब्रिजेस, जिसमें हमें दो साइड के दांतों को सपोर्ट करना पड़ता है, और अगर दो दांत नहीं है तो वो भी बेकार है. So what we come for? Implants. So what are the dental implants? It's the height of biotechnology. The maximum you can think about it, something we implant into the bone. Dental implants are proof of man's power to create reality from imagination. किसी ने सोचा, he is not a dentist, he is not a physician. P.I. Brennemark, 1952, accidentally he saw टाइटेनियम के ऊपर बोन ग्रो कर गया. 12 साल तक क्लिनिकल ट्रायल के बाद पहला पेपर उसने पब्लिश किया 1965 में. And I have the rare honor to assist him. He gave the term osseointegration, something which integrate to the bone. So simple the things he did it. Number of words he mentioned. Osseointegration means permanent incorporation of the non-biological component into the human skeleton with the capacity to carry out unlimited functional load in replacement of structure and function. We use titanium all over the body these days, whether it is a mesh or in the implant or in the bone, invented by a physicist, not even a doctor. So, history 1952, I'm not going into detail of it. But there one point that whenever we place the titanium, bone grows around it, soft tissue grows around it. And very clear, there's a relation between, if you read this, clear that spatial relationship between pure titanium that promotes activation of osteoclast and osteoblastic activity, and on top of it, in presence of pure titanium, it may stimulate stem cells to differentiate into osteoblast and osteoclast. They are all well-established things. Now, just I'll show you one or two cases, what we can do. Like this is one lady, she came to me, we gave him long back, full mouth bridges. On one side, if you see, missing teeth are there. What can you do? You can give a partial denture, which nobody likes it. You can give a cantilever bridge, which is not workable. तो हमारी मजबूरी है सबकी. We had to place 2 implants. And after 3 months, we put abutment and we loaded them. That's what perfect scenario. That's what we are teaching, that's what we are doing. The same case, you can see this. Perfect post-op X-rays. So why you need implants? Very simple question, because alternative is not very good. We are not providing the implant that patient has titanium deficiency. We are giving the implants to the patient for comfortable chewing. And it is established that denture has only 10% capacity of a chewing. So we are not left with anything except the implants. We are giving implant for confident smile, for perfect speech. Those who know about the speech, the most important part of the speech besides respiration and phonation is the articulation. The Hindi language has the best form. A we speak from the throat, ka from the kawa, what we used to call uvula, cha from the soft palate. There are certain words which we have to speak through the teeth only, dentolingual sounds. So it's a long-term solution. When we give the implants, bone remains there. The best slide, you can see it. Wherever there are trees, there is a soil. Same thing. जब तक दांत है तब तक वहां पर बोन है. दांत निकालने alveolar bone गायब हो जाएगा. कटिंग एज इंजीनियरिंग। सो ये सब कौन बताएगा पेशेंट्स को? हम ही बताएंगे। इन सब के ऊपर होता है एक पर्सनल सेटिस्फेक्शन। 36-year-old बॉय केम टू मी विद मिसिंग टीथ। बड़ा आसान है, उसको आप डेंचर लगा दें। क्या वो डेंचर पहनेगा? नहीं। सो व्हाट वी टोल्ड हिम, विल प्लेस 3-3-4-3 like implants here. Leave it for few months. When they are fully accepted, like this, we place the crown on top of them. Like that. Finish. These teeth are just like natural teeth. ये टेक्नोलॉजी है जो 1952 में बाहर कहीं पर इन्वेंट हुई, इंडिया में 1982 से हम कर रहे हैं इसको, एंड वी आर ट्रांसफरिंग इट। एक बहुत अच्छी स्लाइड बलराम जी ने बताई थी, वो है मेडिकल टूरिज्म के लिए। वी आर सेकंड इन द वर्ल्ड। अगर हमारा इंडियन मेड इम्प्लांट बाहर नहीं एक्सेप्ट हो सकता, कोई बात नहीं, वो आदमी यहाँ आके इम्प्लांट लगवा सकता है। एंड वी ऑल नो इट कि कितने लोग इंडिया में आके डेंटल ट्रीटमेंट कराते हैं। पर्पस इज द सेम। DRDO made implant, Indident, many of the institutions they made implant, they are as successful as any other implant, because titanium जहां होगा वहां bone बनेगी ही बनेगी, whether it's locally made or abroad, कोई टेंशन नहीं है। So what are the new avenues? Bone augmentation, bone regeneration, maxillary sinus lift with special intelligent drills. ड्रिल भी इंटेलिजेंट हो गई, मैं भी आपको दिखाऊंगा। PRF, जब एम्स में थे तो वी यूज टू यूज PRP लॉन्ग बैक, फिर PRF आया। मालूम पड़ा 6 महीने पहले PRF गायब हो गया। अब क्या आ गया? CGF, कंसंट्रेटेड ग्रोथ फैक्टर। 6 महीने बाद ये गायब हो जाएगा। हाउ अप टू डेट वी आर। आप सोच सकते हैं 1700 डिग्री सेंटीग्रेड पे मुंह में वेल्डिंग कर सकते हैं। 1700 डिग्री सेंटीग्रेड मुंह में वेल्डिंग। I'll show you a few of the cases. अब ये बड़ा आसान था जो मैंने आपको केस दिखाया, नीचे बोन थी, उन्होंने इसके अंदर जो है आराम से 2 इम्प्लांट डाले और लोड कर दिया, कोई दिक्कत नहीं हुई। अब दूसरा देखिए, जस्ट अपोजिट, व्हाट वुड हैव डन इन दिस केस। साइनस में ऊपर बोन नहीं है, साइनस की लाइनिंग नीचे आ गई, देयर इज नो प्लेस टू प्लेस द इम्प्लांट। तो क्या करेंगे? ऑप्शन क्या रह गई फिर हमारे पास? वही जो हमने पहले बताई, या तो डेंचर जो पेशेंट पहनना नहीं चाहता, या कैंटिलीवर, सामने के दांतों से एक आध दांत एक्स्ट्रा कर दो जिसका कोई यूज नहीं। सो वी आर लेफ्ट विद ओनली वन सॉल्यूशन, एंड दैट सॉल्यूशन इज कि साइनस के अंदर बोन डालें। सो सक्सेस ऑफ इम्प्लांटोलॉजी हैज बिकम मोर प्रेडिक्टेबल विद टाइम, ऑल थैंक्स टू बायोटेक्नोलॉजी। सो इसके अंदर हम लोगों ने साइनस लिफ्ट किया, बोन डाल दी, सिर्फ पूरा साइनस में बोन भर दी। दिस वॉज अबाउट 10 years earlier. I'll show you the latest after this. Right? After 4 months, bone is accepted. We place the implant and we place the crown. Someone must have thought about it. आप जैसे और मेरे जैसे कुछ लोगों ने सोचा इसको, and someone who cared for the details. अभी हमने जो दिखाया था पूरे में बोन भर दी थी। अब आप देखिए क्या होता है। मसाई, व्हाट इज मसाई? अगर मैं यहां पर डेंटिस्ट जितने किससे पूछूं, हार्डली एनीबडी नोज अप, बिकॉज दे आर नॉट दैट अप टू डेट। मसाई इज मैग्नेटिक साइनस आर्टिफिशियल ऑगमेंटेशन इंटेलिजेंस ड्रिल। ड्रिल इंटेलिजेंट कैसे हो गई? ड्रिल ही 2 टुकड़ों में कट गई बीच में, नॉर्थ पोल सामने है, जब प्रेस करते हैं तो स्टार्ट कटिंग द बोन, द मोमेंट सॉफ्ट टिश्यू टचेस it stops cutting. This is the drill. You can see number of drills cut in between this. So like this was the case which I did it in Beach Candy on 17th of October. They called me. X-ray we have taken. We took the CT, reflect the bone. I didn't want to go into detail of it. This is Masai. You cut it on the sides of the sinus. You cut it. You see it won't cut the sinus lining. You go further down, it won't cut the sinus lining. How you see it? You can just reflect the bone like a window. Harvest this bone. If you want, raise the sinus lining. Things become so easy in 2 minutes. If you want, you can have the another cut. 2 windows. Simultaneously, we place the implant. 1, 2, and we place the bone. and we place the same window back, and on top of it, we place the PRF, right? Platelet-rich in fibrin. And this PRF, within a week, it has all the growth factors. What we have earlier, PRP, then PRGF, now PRF, and now CGF. We place the PRF and 3 implants. The things which we used to do in months together, same thing we did it in 15 minutes. We saved 6 months of a patient's. Otherwise, we would have loaded after 6 months. So this is ultimate at the moment in sinus lift. See this instrument, dent weld. You weld inside the mouth. Only tips weld. Weld and joint titanium to titanium. Used to splint your implant abutment. How they splint? Like we place the implants. I just showed you because the slide, 4 implants, we join them together. We take out in one piece and we make the denture out of it like this, and we can immediately screw it. Even if you want, in 1 hour time you can give it. If you want, you can wait for 2-3 days, let little healing takes place. All sutures are inside. Patient is happy with the teeth because it is implant supported. This is what we are talking these days. We can do it. Another case, this lady came from Canada. She had a black tooth, and on top of it, if you can see the round, root is coming out. They said, we will place the bone, wait for a few months, then we again put an implant, then after 3 months, we place the crown. She landed, we simply started, we took first our OPG. We have our own CBCT machine. CBCT, like you do CT scan. You do hundreds of cut and they join. CBCT is cone beam technology. It's mainly for dentistry right now, not for the medical, where we take 4 centimeters, 6 centimeters. And just like OPG, but it cuts into section. So hardly any radiation. I got my own CBCT. First in India, we got it. We took the CBCT pictures and how this picture comes, like this. And the person in Canada, they were right. There was hardly any bone, root was coming out. But we are seeing the bone on top of it, which I'll show you in this. We removed it, the tooth. And we clean it thoroughly. We have plenty of bone on top of it. I don't have to wait for 6 months. We placed an implant, 18 mm implant. We have a bony defect. We saved it. We saved even the small part of the bone from there, right? We place healing screw on top of it, place the bone, and for fast healing, because the lady was in India for 2 weeks, we took the PRF. I told you earlier it was the PRP, platelet-rich plasma. Then we have plasma rich in growth factors. Then we have platelet rich in fibrin. Within a week, soft tissue forms. Patient's only thing. We took out this patient blood, made the PRF membrane like this, and we place it on top of it. We suture it back. This is PRF, you can see all membrane there. Suture. Now we remove this healing screw, and immediately the lady went with a crown. It doesn't look nice at all without teeth in the front segment. We took this X-ray, perfect into position, and now you can see she came like this and she went within 10 days like this. No problem. Everybody said it won't survive. I said, don't worry, it will survive. 9 millimeter inside the bone is not going to go anywhere. She came back after a year and the perfect bone is formed. We took the CBCT again, you can see that. Perfect. Where is the problem? No problem. Pre and post after 1 year. She came back after 3 years, the same. Sir, I have no problem. So my submission here for a very small talk here to all of you, I don't want to take long time. I'm very particular about it. Remember, often the challenges in life don't need a very elaborate solution. Don't need anything. Just think about it, a smarter one, and you can run. Don't give him so many big things. This is my present scenario. The few slides which I want to show you, that in India, in anywhere, you can do the wonders. This is the present place where I am working now. I'll just quickly show you the slides. This is my teaching institutions, where all the dignitaries from abroad, they come and they take lecture. They conduct courses in my place. Few of them I have slides here. This is the teaching institution I have. I am blessed with my two sons. They are dentists. Their wives and my wife. We are all dentists. This is a place. My elder son, orthodontist. This is the place where we work. Anybody comes to India, love to come and visit this place. Why I want to show it? You can do it. Sab kuch hai. Be smart, keep learning and seek blessing of your gurus every day. I worked with Professor P.I. Brenamark, 1994. I worked with number of them. I went to Israel, worked with Professor Umri, and then I called him within few months, and he lectured in my place, and much lesser amount. He taught about 25 of our students. The next, Dr. Shasha, UCLA chief, came and lectured in our place, conducted courses on animal bones. We can do it here, all animal bone studies. We can do it, no problem in any chance. Istavan from Loma Linda University, same thing in our place. Just to finish with it, Egon from Milan University, they are all coming. So here I conclude with quotes from my father of nation, incidentally from Gujarat. What he told me, दो ही लोग अपने विचार नहीं बदलते, एक मूर्ख और एक मृतक. दो ही लोग विचार नहीं बदलते. और कभी भी कुछ नया काम करोगे, first they ignore you, then they laugh at you, then they fight you. And ultimately you are the winner. So my submission, if you want to be successful, success comes from vision. Think something about bigger. We are here, thanks to once again Dr. Katoch and Dr. Manju Sharma. A big teamwork. I'm there in Delhi to do anything. Every day we put number of implants, number of surgeries. Have patience, perseverance. How small you may be, how small town you may be. Wherever there is a will, there is a way. Luck, we always pray Almighty. Let's pray Almighty for our success. Success is not winning each and every battle, is winning the ultimate war. Thank you very much for my patience listening to all of you. Thanks.
Thank you, sir, for such a resourceful session. Now, I would like to request our Mission Director, Shri S.N. Tyagi, to present a memento to Dr. S.P. Agarwal. After such an insightful and interesting presentation from our eminent speakers, all participants would have a lot of questions popping up. Let us address them in the panel discussion. May I request the dignitaries, Dr. Katoch, Dr. Manju Sharma, Dr. Balram Bhargava, Dr. Nikhil Tandon, Dr. Lalit Kumar, Dr. S.P. Agarwal, and Dr. Alka Sharma to please come on the stage.
The audience has thinned down now, but still whosoever is present. The panel discussion is not that we are going to discuss something, but we want you to ask questions from the specialists who are here, and any doubts you have on or if you want any suggestion for how you should go about, any question is welcome. So one can raise hand and ask. Even बच्चे पूछ सकते हैं. हाँ, आप लोग भी पूछ सकते हैं. कोई इंटरेस्टिंग बात हो.
Thank you, ma'am, for such a wonderful talk from all of the speakers. And I am Manish Jaiswal, Dr. Manish Jaiswal from Sumandi Vidyapeeth, Chief Research Officer. I would like to ask one question, that is there any policy through which we can...
ठीक से हम सुन नहीं पा रहे हैं. हाँ.
I would like to ask one question.
हाँ बताएं किससे?
Related from all the persons, like from DBT as well as from the funding institutes, is there any policy through which private institutes are promoted to collaborate with higher institutions like IITs, AIIMS, and other government institutions? Because private players having limited resources, and they want some collaboration with those institutes who are pioneer in their field.
Okay.
So it would be good for private institutions that they have, intellectuals are available, but for resources, if they get some institution like IITs and AIIMS, it would be good for them to collaborate and utilize their potential in different areas.
डॉक्टर जायसवाल, पहले इसका उत्तर में स्पष्ट है कि प्राइवेट इंस्टीट्यूशंस को कोई भी मनाही नहीं है कि वो नहीं करेंगे. अभी प्रेजेंट गाइडलाइंस, इवन जो फंडिंग की बात भी आती है, फॉर एग्जांपल यू कैन कोलैबोरेट विद एनीबॉडी, देयर इज नो बार, लेकिन इफ इट अमाउंट्स टू आस्किंग फॉर ए फंडिंग, तो उसके लिए सिर्फ DSIR या आप DHR, इनकी रिकॉग्निशन चाहिए कि आपका इंस्टीट्यूशन हेल्थ रिसर्च के लिए रिकॉग्नाइज्ड है. You can choose any partner, you can apply directly for funding of your own, you can apply for a funding in collaboration with the institution जिनके साथ आप collaborate करना चाहते हैं. कोई बार नहीं है एक्चुअली.
Okay.
हाँ, अच्छा, सिर्फ इंफ्रास्ट्रक्चर सपोर्ट की बात आती है.
Yes.
See, most of our government agencies, we tend to support the infrastructure in the government system, क्योंकि वो हमारे लिए अकाउंटेबल है, वो सोशल सेक्टर है. लेकिन साइंस के लिए कहीं मनाही नहीं है. In none of the agencies.
Yes, sir, you are right. But one of the questions there, that when Center of Excellence is provided in government institution, most of the instruments, as you mentioned, that they are not utilizing completely. Some of the instruments are even.
नहीं, पर आप एक specific इंस्टीट्यूट या एरिया के बारे में कहिए, तो आपको हम सजेशन भी दे सकते हैं कि किसके साथ आप कोलैबोरेट कर सकते हैं.
Say for example, ma'am, in MS University there is Center for Excellence, MS University Baroda. There is Center for Excellence institution, means many instruments has been provided. But if we want to get some work from their institution, they are generally reluctant to do that work because of their maybe manpower issue, or they don't want to work with us, or they don't want to provide that support. It is a general tendency that I have seen many places.
See, if you want to establish a Center of Excellence, the Department of Biotechnology has a major program, including also DSP.
Absolutely.
But you have to identify the area, you have to identify your partners, and which institute with which you want to collaborate.
Okay.
Supposing there is a university or an institution or an industry, whosoever is going to be your partner, you must identify.
Okay.
But the most important part is that you must write a good research proposal.
Absolutely.
You see, that is the crux of the whole thing.
Absolutely.
If the proposal is not well written, no funding agency will accept it.
Okay.
Even justify the infrastructure.
मैम, इन्होंने एक और क्वेश्चन रेज किया which is very vital. हम इंडिया में whenever any facility is funded by any government agency, even हम अपने साथी को भी नहीं मदद करते. हाँ, आप कुछ दूसरी बात कह रहे थे, हमें समझ आ गई बात. वो मानसिकता बदलनी है.
Absolutely, sir.
See, the national resources are for nation. So people should be open in letting them getting utilized.
Absolutely.
ये लेकिन हमारे इंडिया में प्रॉब्लम है एक्चुअली. एक लैब वाला दूसरे को नहीं देगा, एक डिपार्टमेंट वाला दूसरे को नहीं देगा. आप तो प्राइवेट और गवर्नमेंट की बात कर रहे हैं. वो इशू नहीं है इसमें. वो इशू नहीं है. वो बड़ौदा यूनिवर्सिटी के जो सेंटर के हेड हैं उसके दिमाग की प्रॉब्लम है. तो अच्छा,
Yes, and this is a nationally prevalent disease.
So that's why I'm asking
अच्छा,
to the
हाँ, तो
authority.
इसलिए सवाल बन रही है कि जब और सेंटर बनाए,
जी.
प्लीज बी ओपन. This is advice to everybody.
So sir,
इसमें तो पॉलिसी नहीं आ सकती, भगवान नहीं बना सकता.
So should I consider it as a right of a common person or a person of faculty of anywhere that he can go anywhere to get the facility?
ठीक है.
I will say something slightly different from what Khatod Sahab has said. I ran a national laboratory. The problem is, when these people come, they are unwilling to take any responsibility whatsoever. The problem is, you have the equipment, say I have a national lab, I have the responsibility of running it well, maintaining it, and making it available to you with your taking any ownership. And that's where the problem comes. Khatod Sahab, what he has said is very correct, but it operates on the other side as well. I can say that from personal experience. So ये एक साइड का नहीं है डॉक्टर साहब.
But just to add to this, nowadays for all major facilities which are being funded by DBT, we write very clearly in the sanction order, this will be treated as national facility. Earlier it was not the case, but for the past few years, we are writing in the sanction order indicating that, so no one can deny that. So it's already written, it's a government order that it has to be treated as a national facility.
Okay. Good evening. I am Dr. Devkar from MS University, Baroda. I was just listening to the comments. Actually, I am a basic scientist and I am looking for a clinician. I am not able to find one who is inclined towards research, honestly. And so far the central facility is concerned, yes, there are problems, and I think people are more open to help the outsiders rather than insiders. So if you go there, if you go there, I think you will be preferred over me. Take my word. Yeah, but then there are certain problems, as in, if the instrument is highly sophisticated, say a fax machine, for example.
What is your question?
Madam, I was just trying to answer to his statement, and one statement that I want to make is that, well, if a person is there who is from the clinical field and is inclined towards research, please, I am searching for one. Thank you.
Yes.
To the Dr. Agarwal sir. Sir, thank you very much for such an interesting and encouraging presentation. Sir, my question is related to the implant, the titanium implant. As it affects or induces the stem cell, as you said in your presentation, are there any complications regarding like cancers and all, if you have seen any?
No, so far with implant, with titanium, no cancer is reported.
Okay.
So far no reported in literature.
Any other complications?
There are thousands of complications. It's a normal surgical complication.
Okay.
But cancer is not there. Okay. Complication like infection.
Okay,
body
so
success rate is about 3.
So this is a misconception, means many people have.
No, I'm doing since 82, so there is no complication.
Okay, thank you.
Thank you.
Yeah.
Yes. I think she raised her. Just a minute. इनको दीजिए आप.
Very good evening to one and all present. My question is to Dr. Tandon, that he has presented an excellent cohort study which has given us a lot of suggestion, but after that also we are having 7 registries. Basically I am dealing with cardiac research. I am from UN Mehta Institute of Cardiology, and we are having 7 cardiac registries. We are running it since 1.5 years. The biggest problem we are getting is to get a follow-up. Patients are coming without papers. There are n number of drug defaulters. So whatever data we are getting, the initial pro forma which we have prepared, we are unable to fulfill the things. So whatever data we are getting, it is around, you said 20 or 10% of data which we have aimed initially. So how to tackle this kind of issue? Because we are giving free medicines and other stuff, then also the people are reluctant to come and follow.
Yeah, That's an absolutely valid observation. You're not so registries usually are dependent entirely on a voluntary participation by residents. And if you look at when we started the Young Diabetes Registry, we I think had mistakenly assumed that since youth onset type 1 is not often addressed by many doctors, we'd assume that these patients will come back regularly. Attrition rate is huge. I wouldn't know, 1.5 years is very small. We expect an annual follow-up for the registry purpose, but you lose about 50% every year. So by the time you're reaching towards 10 years, you've virtually got nobody left from the first cohort. Unfortunately, in a country where the health system allows you huge amount of flexibility as to where you can go, it becomes very, very difficult to ensure a completeness of follow-up in registry. If you look at a socialist, let's say if you look at the NHS in the UK has a patient ID. Even if that patient moves from one part of the country to the other part of the country, they are identifiable on the basis of that ID. The US has a youth onset diabetes registry which is geographically run. Again, it is got near complete ascertainment because there is a referral system which ensures that you go to certain institutions. We have absolutely no referral system. There is no compulsion of anybody to go in any direction, which may have its own advantages. But clearly for a thing like a registry, it becomes impossible. The only thing you can hope and do is that if you can acquire that information telephonically and if the person is willing to respond, or that you have a social worker who can do a house visit, you can do it. Otherwise, it's very difficult to compel people to come back only for this purpose. They'll do what they want to do, yes, and you can't influence that.
Yes, definitely.
Address of the patient and either their mama or some uncle. So that if the postcard, when we posted, say after 6 months or 1 year for follow-up, like how that person is doing, so it comes back, then we send to mama. So somehow at least you could get some follow whether that person is alive or not, kind of thing. Nowadays, actually, for mobile phones, even though people change, so one suggestion could be like you can have about 2 or 3 mobile numbers, and that also gives at least 20%. You can figure out whether that person how he is doing. For us, I mean the denominator is different, like alive and dead and those kind of things, whether he's on treatment or not. Cardiology may be some different perspective. That's one way to catch up those people.
You wanted to Dr. Nikhil Tandon, sorry. Sir, so I'm also looking forward to do some sort of a survey of this sort, but I understand that it must be a really tedious and long task. Are there any permissions that we're supposed to consider before we start such a survey? And are there any ethical issues that we should consider before something of this sort?
So it's a human contact survey, so immediately comes under the purview of bioethics. So you will need an institutional ethics committee which will need an approval, because even if you're not doing a biospecimen, the very fact that you're actually talking to another human being and collecting health related information from the human being will require a bioethics or institutional ethics committee permission. That will be mandatory. You shouldn't proceed without that. So it's where do you work? Sorry.
I'm a student in the University of Gujarat.
Right. So I would assume that the university will have an ethics committee, because the university will have graduate students and will have master's students who will be doing research like this. So the university would have their own ethics committee, and you would need to. If you're a student, it's always better that you apply along with whoever is your mentor, or at least a faculty mentor, and apply to an ethics committee and take permission before you do any such thing. Because you need to be reassured that you're not doing anything which is going to land either you or your subjects or participants into any difficulty later on.
I have two questions, if you allow me. First, from the Lalit sir.
Oh, I am Dr. Satish. I would like to ask two questions. First from the Lalit sir. Sir, it was a very nice experiment where just by the electrophoresis you can see the change in the heavy chain. I would like to anyway pursue this thing for my further research. I would like to know if at all, if the small marker in the secretion, as you said in the myeloma, the same, since you work with the amyloidosis, if these amyloidosis simple markers are there, which from the, those things we can just develop some biosensor and we can predict the early onset of this amyloidosis well in advance. Because in the case of particularly in the Alzheimer's or Parkinson or cystic fibrosis, where you need a CNS, cerebrospinal fluid, it's very easy to take the secretion from the saliva or something else, and this early marker, maybe with the MAP kinase or maybe it will the earlier protein secretions, which can be used for the early detection of the amyloidosis, which can be used for the any other disease also.
Yeah, for amyloidosis, apart from the heavy chain or intact molecule, we have the kappa and lambda light chains, which can be used. But honestly, I'm not aware about whether anybody has tried in the saliva or other secretions. I mean, we have that kappa and lambda chain has been standardized for the serum as well as the urine. We take the ratio, which is if it is abnormal, then you really see from that point of view. So that is much earlier than you get into the serum. Or the M protein.
So at the earliest, what can I start with? For example, if I want to continue this, and I know these things can changes due the course of the time. It might happen in the, for say, 12 years, maybe at the 30 years, maybe 46 years, because the early onset of this neurodegeneration can still happen in the embryonic stage also. There are many work has been published, even the embryo has been seen the amyloidosis. So, at what is the possible stage when the people can start looking all these things? I'm not want to be very precise, but approximate time window where we can search with.
Let me make it clear. To best of my knowledge, the systemic amyloidosis or what we call AL amyloidosis is different than what you are showing the amyloid material in the Alzheimer's disease. That's totally different diseases. That's called amyloid material in Alzheimer's disease, but the nature-wise or chemistry-wise, that's different protein there.
Right.
Here, this is the protein misfolding with the major
exactly.
Deposition leading to the heart, kidney, and other organs in the body.
Yeah. So because it's a very relative to the lysozyme, for example, which have people have seen a 20 kg of amyloidosis in the liver. Although it won't cause any ill effect, but it will just accumulates and it leads to the replacement of the normal liver cell.
Yeah, it's a slow-growing disease, so probably it's a couple of years before the clinical florid manifestations do start. But as of now, kappa and lambda chain estimation is probably the earliest you can pick up.
Another question is with our ex-DG. Sir, do you think that in India the medical service is over-medicated? For example, if I go to doctor for the normal symptom also, he will give me 5 medicine. I don't know all 5 are required or not. But for the small age group to the larger age group, they will give a lot of medicine. I want to share my experience. When I was...
नहीं, आपको experience की जरूरत नहीं, हम वैसे उत्तर दे देते हैं. ये देखिए, see, this is a national problem again. Because, our sector is not regulated. No guidelines. And, most of the time, it is a faith between the doctor and the patient. So I think in that faith, you just don't know who's doing what actually. Because they'll give 5 drugs, they'll give 4 drugs, one may be required, one may not be required. So that, for the common diseases where there's no complication, 2 days, 3 days problem, there's no problem. But if it's a chronic diseases or some infectious disease like tuberculosis, there the trouble arises. There the persons, they end up spending a lot of more money, more toxicity, more trouble. So eventually what you need, you need standard guidelines. The way the NICE has done in UK, several other countries have done their countries. So there, even if you purchase equipment, you use equipment, they are the one which are properly required actually. And you spend on the drugs which are really required. So that kind of culture has not really built up in the country. Though various agencies, they make guidelines from time to time. Various actually societies also make the guidelines from time to time. It is not a nil situation. But the people are not in the habit of looking at them in general. Good clinicians, good doctors, systems, they do look at. But as a country, we have to build that culture. Generate your own data, generate your own evidence, analyze that own evidence, which works on your own population, use only the drugs which are required. This has to build up, but this will take time. What we have done in the meantime, we have created a medical technology assessment board. It is on the same model as the NICE model. So there we did even the countrywide scanning also, which diseases people will like to work on. The guidelines should come first. And the different states in the union, they have given the preference for 15 diseases, which they think that they spend a lot of money spent on them. And doctors have given, academicians have given from major institutions. So the process is just building. And I tell you, it will take 5 to 10 years to build it up before the things become a habit and the governments enforce. So what you are telling, you need not tell me, because that is a problem with everybody.
Because it's become more problematic if I go for my 5-year kid and he'll give antibiotic. He's just giving antibiotic. I tell sir why it's required.
See,
आप ही जानते हैं.
Dr. Katoch has already answered your question. Yes, please.
I will take precedence. Thank you, madam. It's an ethics-related question. I am a professor of pediatrics at Bhavnagar. One NGO came to me and they said that they want to find out the patients of bleeding in the whole district or 2 districts nearby. So they will go into all the villages and asking, is there a patient of bleeding? Is there a patient of bleeding? And then I came to know that this NGO is sponsored by the company who is manufacturing the anti-bleeding factors. So I asked them whether you have taken anybody's permission, collectors or district authorities or state authorities, and then they said no. Then they disappeared, but I find that they are still continuing this survey. So is it, can anybody do such kind of survey ethically?
ये तो statement है, question नहीं. Yes.
It's a question that how can I force them to, or is it required? Any ethics permission is required before doing a survey in villages?
Yeah, for everybody. Yeah, whether it is an NGO or an academic center, they have to take. It has to be approved by some ethical committee. Yes.
Oh, that's. And just one short answer for is what we are trying to do is prescription audit. We collect the prescription, do the audit, and send it data as a group analysis to all, not individual, as a group analysis. So they would learn gradually. But patients also demand.
Sir, I am Dr. Pillai from Government Dental College Hospital, Ahmedabad. So my question is to Dr. S.P. Agarwal. Sir, dentistry is a growing branch. Simultaneously, biotechnology also is growing. Sir, as you said in your lectures that today what is new is going to be older tomorrow. So like that, do you feel any end for implant with the advent of biotechnology on one side? Like when biotooth concept comes in the future, so what will be the scope of implant in the future?
Good question. I'll answer you in a very simple form. अपने समय में अमलगम होता था, सिल्वर अमलगम, कहाँ गया? सिलिकेट होता था, कहाँ गया? जब नई चीज आएगी तो पुरानी चीज गायब, फीट एम्बेसडर गायब हो गई. तो अगर इम्प्लांट का सब्स्टिट्यूट आ गया तो ये भी गायब हो जाएगा. नथिंग टू वरी. जब तक ये चल रहा है फीट चलाओ. राइट, थैंक यू.
फिर भी सर अभी भी कुछ लोग बेंचेस तो बनाते हैं,
जो बनाते पुराने तो कोई दिक्कत.
But I can give a little relative answer to this. See, all the technology may be important, and obviously the new technology, if it is better than the previous ones, should be preferred. But some of the older things can still have their place. For example, like in antibiotics, we keep on writing very heavy priced antibiotic. Sapran, which is just ₹1.35 tablet, it still works very well. But people don't want to write such a cheap. People, every patient expect they must be 15, 20 rupees or 30 rupees, 40 rupees tablet. So thing which you can do in 10, 15 rupees. So for example, about his technology, somebody in the Bihar or Gujarat remote area, the older technology will still work for him till he comes to Ahmedabad and gets the new technology. Isn't it?
और आप पूछिए.
I'm Dr. Prabhudas Patel from Gujarat Cancer Research Institute. All the experts today are connected to all the funding agencies, so I have 2 humble submissions to make to them. One is, few years back, ICMR organized one workshop on project writing that was somewhere either in Jaipur, and yes, and I mean that workshop helped me in getting 2 ICMR projects in my institute. So such more and more workshop of such type will be useful either from DBT, DST, ICMR. And the other point I have noted is many times when the project is denied from the funding agency, the reviewers' comments are not passed to the investigator. If it is passed to the investigator, that will help him in improving the project.
Anybody else?
Myself, Dr. More. I am head of the department in a dental college, oral medicine branch. I have a question to Madam because I am doing some studies on regenerative dentistry. So pertaining to stem cells, I have a question. Madam, nowadays we hear lots of autologous stem cells, lots of practices are going on in Delhi, Mumbai, Chennai. So just wanted to know whether are those legal things or illegal things? Because whatever you showed was like we cannot do any clinical trials or we cannot use it on patients, it's only a laboratory procedures. So just wanted some comment on from your end.
So, as far as government is concerned, government has issued guidelines for conducting stem cell research. Whether it's legal or not, it's difficult to check by the government. Unless we receive any proposal, how can we say that whether it's... But as I mentioned in my presentation, actually as of now, it is not a standard care of therapy. It has to be conducted in the form of clinical trial. So they have to conduct this in the form of clinical trial, and they should not charge the patient for these clinical trials. And they have to follow the guidelines appropriately, what is mentioned in the guideline, and they have to, otherwise there are bodies to check whether these are legal trials or not, and whether they are offering therapy. But no one can offer therapy as of now, as per the guidelines.
Sir, may I add something? For, like you mentioned, you are from dental college. There are lots of things are going on in stem cell therapy in AIMS and outside also. I am associated with few of them. So far, we are not able to make any tooth. So what ma'am mentioned in all her slides, it is only clinical trial, no therapy, please. Few of the, hospital, they are charging. They're taking out your tooth and they charge hefty amount that okay, whenever you need, we will make the tooth or we will make the, many structures and all. Absolute, in my opinion, illegal. So far government has not given permission, we should not, in fact, in my opinion, we should not do it.
I think nowhere in the world so far this is under clinical approved thing. This is still in the experimental stage all over the world.
Can I have the question?
Yes.
I'm Dr. Rakesh Rawal from Gujarat Cancer Research Institute. It's a general question aiming towards Professor Balram and Dr. Alka Madam. That if any scientist in due course of his work, if he comes out with a process involving biotechnology or a product involving biotechnology, how he can proceed for patentization, or is there any funding support for the process or any guidance from DB?
Yeah, I think it's very simple. We all have that mental block that getting a patent is difficult. Once you have a novel idea or a product, you write a A4 sheet of paper, simple, and file a provisional patent. Provisional patent costs 4,000 rupees. Once you file the provisional patent for 4,000 rupees, after that you have one year to protect. You are protected for 1 year, and during that 1 year you can develop it further and relocate it, and then have file your full patent. And that's how it is to start with. You have any point to add?
Yes, Chandramani, you. Hey?
It's okay. ICMR, DHR.
For process and product development, under that you can apply for this.
Hello, myself Dr. Kiran from KMC Dental College, Sumandi Vidyapit. My question is to Katoch sir. Sir, I just want to ask why ICMR has stopped this STS scholarship from 2016? Because
I retired on 28th February 15.
So that's why just I am asking you question.
So I can't answer that question, yes.
Ma'am,
You should give, you
one
have,
more question to Alka ma'am, DBT related. Actually ma'am, many of the programs supported by DBT for funding, we saw that there is educational qualification required as a PhD investigator only.
Sorry?
PhD investigator, PhD should be there for the eligibility criteria as
investigator
education.
should be holding
Yeah.
PhD degree.
Yeah.
Okay.
So ma'am, what about those who are like postgraduates, or is there any programs which are particularly for those who are not PhD?
So for them, there are scholarships and fellowships. For projects, the person should be holding a permanent position
For
in the institution.
especially like MDS, dental related sites.
Yes, MBSc, there is a provision for that.
Okay.
So in an MBSc case, there is no need for PhD, but fellowships are available for UG and PG students, for postdoctoral and also doctoral students.
My question is, today's seminar is biomedical research in Gujarat. This is for generating new projects between the various academic institutions and medical fraternity. Now, when research is made, researchers actually do not make much money. Money is made by the industry, because once a technique is developed, the technique is actually converted into a product or a process, and that is where the money generating thing comes up. Now my question is that when you have taken the components of medical fraternity and academia, you have not spoken much about the industry component. If there is a tie-up from the beginning for developing a product or a process or a drug, for example, several technologies were mentioned by Professor Bhargava. Now, these technologies will have to go to the market, and continuously they will be sold, and the man who will be selling it will continuously innovate. The technology will not stand at that particular place. Any technology taken never stays at that particular place. Continuously it innovates. And changes have to be considered as a very important factor, and this is what normally industry does after taking the technology. So my question is, how you are going to accelerate the formation or the conceptualization of a technology involving the medical fraternity, the academia and the industry.
ये तो स्टेटमेंट है बहुत कॉम्प्लिकेटेड सा, पर डॉक्टर भार्गव इसको ज़्यादा अच्छी तरह बता सकते हैं पहले अपने इंडस्ट्री से कैसे.
I think this is a very important idea. In fact, many of these industries have, in fact, 4 or 5 of the multinationals have set up their own innovation centers in India, whether it be Johnson & Johnson, whether it be Philips, GE, or Boston Scientific. And they've set up very big innovation centers in India. So, and their job is only to scout for new technologies and get on to it. So, if the collaboration with industry, medical school and engineering school starts from the very beginning, I think it's a great idea. It is working in the US in some, but we are in the beginning of stages yet, and it will take time to mature. Sure.
Let me inform the House that government of Gujarat is coming up soon with a policy where you will find incubators in the universities, and the industries will be supported not directly by funding, but the money will go to the universities. If some industries wants to do further research, develop some product, they will come to the universities, and universities will be helping them, but the money will go to the universities. This is soon coming. I think within 15 days or so, government of Gujarat is declaring its policy on biotech. And friends, at present, we have a bioincubator at Savli. Most welcome. We are waiting for your participation. Vacancies are there. We are waiting. Some doctors may come there who wants to work on some project or to develop some. This is a biotech incubator, the only biotech incubator in the state. And we have schemes for startup also. And soon you will find lot of incentives for startup, for incubators, but it is up to you how much interest you take in. Thank you.
मैं इसका थोड़ा सा एक्सपेंड करूंगा, दोनों का उत्तर बहुत सही था आपके लिए. सी आज के सेमिनार का जो बेसिक गोल है वो मेडिकल वालों को दूल्हा बनाने का है, वो दूल्हा बनने को तैयार नहीं। सारा इशू इस बात पे है कि बायोटेक्नोलॉजी हैज़ डन वेरी वेल, बायोटेक्नोलॉजी से चीज़ें भी निकलेंगी, यहाँ पे से भी निकलेंगी, चाहे बेंगलोर से ज़्यादा निकले, गुजरात से कल हो सकता है टॉप पे आ जाए। वो इशू नहीं है एक्चुअली, वो करेंगे आप लोग का। बायोलॉजिस्टों में भी काफ़ी दम है, इंस्टीट्यूशन की सपोर्ट है, थिंग्स विल फ्लोरिश। आज का जो बेसिक गोल था, इसी वी वांट टू ब्रिंग द मेडिकल पीपल इनटू द मेन स्ट्रीम ऑफ साइंस। दे आर डूइंग एक्सेलेंस इन प्रोवाइडिंग द क्लिनिकल केयर, उसमें कोई प्रॉब्लम नहीं है, वो जनता की ड्रिवन है। तो मेडिकल के लोग डिजीज की प्रोसेसेस को, उनको या डिजीज की संबंधित कोई भी चीज को सॉल्व करने के लिए ग्रुप बनाएं, जिसमें बायोटेक्नोलॉजी भी आएगी बीच में, जिसमें दूसरी चीजें बाकी लोग भी आएंगे। तो आज अगर सेमिनार के अंत में आप में से कुछ मेडिकल लोग दूल्हा बनने के लिए तैयार हो जाएं, आपकी कोलिशन बना लें, उसमें बाकी बायोलॉजिस्ट जुड़ जाएं, तो दैन इट गुड स्टार्ट ऑफ ए प्रोसेस। एक्चुअली इंडिविजुअली यू आर डूइंग ग्रेट एक्चुअली, वो मैं उसको किसी की आलोचना नहीं कर रहा उस बात की। तो ये जो रिमेनिंग इशू है, बाद में इनोवेशन करके प्रोड्यूस होगा, आगे जाएगा। जिस स्टेज पे प्रोफेसर बलराम भार्गव या एम्स के बाकी कोलीग्स ने बातें रखी, वो दुनिया और दूसरी दुनिया बिग गैप है आज। एक्चुअली आपके अंदर कैपेबिलिटी है वही के वही, बट यू आर नॉट यूजिंग दैट। तो ये एग्जाम्पल थे सारे आज लोग शोकेस करने के लिए कि भाई आप बिजी क्लिनिशियन होने के साथ साथ भी आप ये चीज कर सकते हो। ये सारे के सारे इसी बात को उदाहरण थे सारे, राइट अप टू आवर डेंटल कोलीग इन द एंड। तो आज वो उस मुद्दे से दूर मत जाइए आप। आज अगर एंड में जाते जाते शाम को भी सोचिए, कल भी सोचिए, जैसे मैडम कह रही थी 6 महीने से पहले पहले आप प्रोजेक्ट डेवलपमेंट की भी बात करिए, तो मूव टुवर्ड्स दैट। क्योंकि आज का सेमिनार इज फॉर ए डिफरेंट माइंड सेटिंग एक्चुअली। ये जो छोटे छोटे किसकी एथिक्स कमेटी, वो कमेटी सब आपको उत्तर दे देंगे, आपको सबके रिटर्न जवाब दे देंगे, वो इशू नहीं है सारे कोई भी। तो अगर आज आप कहना चाहते हो तो भैया अपनी प्लान लेके आओ कि हम ये करने के तैयार हैं, हम इस चीज के ऊपर ये चीज करेंगे। सो प्लीज स्टार्ट थिंकिंग फ्रॉम दैट एंगल। सारे के सारे चाहे यंग स्टूडेंट्स हैं या सीनियर फैकल्टी जो भी आज आए, बहुत खुशी की बात आए, कुछ लोग तो आए, लेकिन यू स्टार्ट थिंकिंग फ्रॉम दैट एंगल, फिर वो फैलेगा, कल्चर चेंज होगा तुरंत ही। तो ये जो आज का है एक्सपोजर जो मैडम ने ऑर्गेनाइज किया, इज जस्ट टू शो यू दैट द अदर इंडिया एग्जिस्ट, विच इज किकिंग, विच इज शाइनिंग, बट यू आर नॉट कंट्रीब्यूटिंग टू इट। सो प्लीज बी अ पार्ट ऑफ दैट, दैट्स द कोर।
You are saying, sir, in the similar line, if today we have a very good number of policy makers and medico doctors who are themselves involved in active research, maybe we are able to suggest each one of you few, suggestions that other than individual research projects and groups, what should be the strategy that we can adapt? Model 1, model 2?
डॉक्टर जोशी, ये बात हम नहीं करेंगे, ये सोच रहे हैं, इनका काम है,
इनको करना चाहिए।
जो गाड़ी को जो ड्राइव करेगा ना उसका काम है।
No, because sir, as a state government, that is our objective. We want to support it, and that is why we are actually, sir, organizing.
देखिए, एक बात इसमें बड़ा important issue ये है कि one of the reasons why we got this one day meeting scheduled here is that, as I had said in the beginning, that biomedical research is lagging behind in medical colleges. The reason is twofold. One is that as the moment any medical college has a strong research backup, there are few doctors and clinicians who are doing research, the teaching itself improves. The teaching and patient care, there is improvement, but more so in the teaching, because the teaching you are update with the latest developments in research. So therefore a strong research support from your medical college for the teaching purpose, plus as Dr. Katos said, patient care. So that is one issue which we wanted to bring to your notice. And regarding funding, I don't think you should worry so much. GSPTM is willing to give you support to get started. DBT is always welcoming. In fact, we don't get, I was telling Alka that when I was secretary DBT, we used to analyze which states are sending the research proposals. We hardly got something from Gujarat, hardly got. In fact, this was one point we had raised in our parliamentary committee also. They said, why no proposals are coming from Gujarat? Very few proposals, either from medical colleges or research institutions, except MS University Baroda, which was very active in biotechnology. So one point which I want to emphasize again with you is that the moment you will start a biomedical research unit, a strong group of research in your medical college, it will automatically, you will see, it will get a different picture. Why AIIMS is so famous? What is the purpose? Why it is called the cream of the country goes there? The reason is they have a very strong backup. All what you heard from Dr. Nikhil Tandon or Dr. Bhargav, they are all doing, along with patient care, lot of research work. How can Nikhil get so much data if he was not involved in a research program? Or Professor Bhargav, he has set up the whole biodesign center. So the issue here is a strong research support. The second very important point, again I want you to remember, one of the difficulties I find that why proposals are not coming from states, some of the states, you don't know really, probably, I'm not saying that you don't know, but you have to develop an attitude how to write a research grant. In United States and all, professors take leave. They say, oh, we are writing an NIH grant proposal or an NSF grant proposal. 2 months we will sit together and write. So you have to get into that attitude how to write a research proposal. For that, Mr. Tyagi, I have a suggestion. The National Academy of Sciences has been organizing workshops all over the country on this subject, how to write good scientific proposals. This was in Bombay University, in BHU, Lucknow, Allahabad University, Madras University. All over the country they have organized. They have a group of experts, including people like Dr. Alka Sharma. From DVT we have Dr. Renu Sarup, and there are many others who can come and give a one-day lecture, this type of a meeting where you would know what is the best way to write a research proposal, which will get accepted by the funding agency. So I request Dr. Tyagi that you must organize one meeting, because otherwise today's effort will all go in vain. Nobody, they have heard all good lectures, but I'm sure next 6 months we will not receive any proposal. But if you are serious about it, then you will automatically start thinking and consulting these people that we want to write a research proposal.
Depending on your schedule, depending on your convenience, we will have some date where we will invite you for one day training or something.
आप अभी से इंटरडिसिप्लिनरी रिसर्च करने की सोचो, आइडिया सोचो, जिसमें 4 आदमी मिलके क्या करेंगे, 3 क्या करेंगे, कौन आपके दोस्त होंगे. जैसे डॉक्टर टंडन ने कहा, एक्चुअली यू हैव टू नीड टू योर फ्रेंड्स एक्चुअली, जिनके साथ आपकी बनती है. तो कंजीनियल एनवायरनमेंट के साथ किसके साथ आप बिल्ड कर सकते हैं, वो है, एग्जिस्ट करता है. 65 इंस्टीट्यूशन की लिस्ट बताई थी जो मेरे पास है इस वक्त. तो 65 इज नॉट ए स्मॉल नंबर इन वन स्टेट एक्चुअली. So you build it up. Yes. सारे देंगे, सारे करेंगे, जो अलग-अलग एजेंसीज के सारे.
और आप स्टेट के बाहर जाने के अलावा अगर आप अपने स्टेट में भी, if you look around, there is NIOH, one very good research institution of ICMR. Like that you will find there are some university departments.
65 within the state.
Within the state.
You can find out the date. If such training is there, we will fund your travel, we will fund your training.
Any question on this issue?
In fact, Tyagi sahab, I would even say that, go to the extent that rather than calling them everybody in Ahmedabad, you should go to each medical college and do a workshop there, so the people there can really participate and they get energized.
Today's medicine without biology and biotechnology is of no use, including bioinformatics. So ऐसा तो है कि medicine अकेले stand alone आप कुछ नहीं करना चाहते.
Ma'am, in this context, I'll just like to put across, we have been moving down, we have been going to all different universities and colleges and conducting these kind of sensitization programs about writing research proposals. number one. Number two, talked about industry interaction with the research fraternity. Under the aegis of a flagship program called as Research to Rupees, we have been going to various universities and connecting them. Ma'am, we could introduce some number of our innovators to Balram Bhargav Saab about it. Ma'am, quickly, if I can make a request, and this is a question for Dr. Alka Sharma. Ma'am, you talked about, and the point is very clear about the clinical trials not allowed into stem cell research. Ma'am, ये कुछ examples हम देख पा रहे हैं, जहाँ पर कोई parent देख रहा है कि बेटा जो है कुछ road accident में अब vegetative state में जैसे आ गया, कुछ ये cases हैं. There are some doctors जो कुछ और रिसर्च कहते हैं इसको ऑटोलॉगस मतलब करते हैं, क्या करते हैं, और जो उसके फीस है वो किसी एनजीओ को चंदा करके कुछ जाता है कि ऐसा सब. एंड देर आर सम प्रॉमिसिंग केसेस, मतलब कभी अखबार में गुजराती वर्नाक्युलर न्यूज़पेपर में हमको देखने को मिलता है कि देर आर सम सक्सेस स्टोरीज इनटू इट विच प्रोपेल सम मोर पीपल टू गो. ये मौका ऐसा है जहां पे बहुत सारे मेडिकल प्रोफेशनल्स इधर मौजूद है, कुछ ऐसे हैं जो बडिंग, जो कल को इसी प्रोफेशन में ये काम करेंगे. तो मैम इस पे थोड़ा सा आप और थोड़ा सा एलैबोरेट करिए, रीआइटरेट करिए कि ये स्टेम सेल बेस्ड रिसर्च जो कि पेशेंट्स के ऊपर किया जा रहा है वो कहाँ तक वाजबी है.
I don't think we should discuss this question. I would like to avoid this right now because it's very difficult to answer it in the light of the government guidelines. Former DG ICMR sitting here, Alka represents government. So these are individual cases one should discuss and not a generalized issue.
एक मैं थोड़ा सा मैडम जो करिए थोड़ा नो ऑफिशियल स्टेटमेंट फ्रॉम एनीवन. देखिए साइंस के पॉइंट ऑफ व्यू से जैसे आप कह रहे हैं हेल्पलेस सिचुएशन है, सी ट्रॉमा का है, स्पाइनल इंजरी से है, दूसरी और बहुत सारी कंडीशन है जिसमें कि रीजनरेशन का चांस कम है, न्यूरोलॉजी के प्रॉब्लम्स हैं, नीड है सामने उसको ना साइंटिफिकली डॉक्यूमेंट करने के लिए ग्रुप बना के उसको अप्रूव प्रॉपर कमेटियों से अप्रूव करा के. देखिए अल्टीमेटली कल 5 साल पहले तक तो कमेटियां भी नहीं थी. सिस्टम में अबंडन कर रखा था वर्चुअली रियलिटी में. आप कमेटी नहीं बनाएंगे तो कंसल्ट नहीं करेगा तो गाइडलाइन नहीं है, तो दैट मींस तो वो कहेंगे हम करेंगे नहीं. ठीक है. सो लैक ऑफ अप्रूवल फ्रॉम द गवर्नमेंट डजंट मीन द गवर्नमेंट डजंट वांट टू डू इट एक्चुअली. लेकिन यूजर जैसे आप कर रहे हैं, अगर आपको लगता है कि 5-7 आदमी लाइक माइंडेड है, वी नॉट मीन गुजरात इटसेल्फ, यू कैन बी वन, अनदर कैन बी अनदर प्लेस. एक स्टडी बिल्ड कर दीजिए. See, what government is not saying don't do it. Government is saying iski should be in a study mode. Study mode means it is observed, it is monitored. There is a board for that. Yes.
I think that's exactly, if you're able, supposing that patient who's paralytic in a road traffic accident, you want to give stem cell, and if you have a protocol wherein you're taking these kind of patients, the ethics committees are also very lenient on compassionate grounds. So if you can get an approval on compassionate grounds for few cases, maybe 5 or 10 to start with, and work together, the government is willing to help, I think.
वो प्रोवाइड नहीं कर रहे ना कोई, ऑल और नन है, याद रखिए.
So is there?
But patient should not be charged on this.
So that is very important.
Yes, sir. It has to be treated as clinical trial. Patient should not be charged.
So I have been told by the authorities here that we should close the session now. No, but in any case, I don't think there is any other question. Yes, आप बता दें. दो. अच्छा.
Good evening, ma'am. My question is to Tyagi sir. He mentioned something about biotechnology incubator. I'd like to know more about it.
आपसे पूछें. वो बता देंगे आपको बाद में. हाँ. आप पूछिए.
बहुत बड़ा इंक्यूबेटर, छोटा नहीं है.
24,000 square feet. I'm Dr. Das from Biotech Mission. My question is to all the dignitaries. There are a lot of information has been generated since long by different medical colleges, by daily practices. So what would be this big data which is already being generated by all the medical colleges, and how it can be gathered and accumulated? What would be the strategies to accumulate those data to make them used for the betterment of the life or betterment of human welfare from the government side? What could be the strategies you would like to suggest us so that all the data, whatever is available, can be used?
effectively. So I'm going to actually be a little provocative and going to ask you a question in return, right? All medical colleges have, well, most of them run postgraduate programs. Most of them will have postgraduate dissertations. Those are the stepping stones for training students how to do research, right? That's the whole idea of doing, at least in medical schools, the research is embedded within their MD/MS programs, right? I think the first thing that we need to do, and it's nothing to do with Gujarat, we need to do otherwise also, is what proportion of those dissertations translate into publications, right? Is there just inertia about not publishing them, which could well be the case? Is there just paucity of time, or is the data not good enough to actually make it into a peer-reviewed index journal, right? So if the data is good enough, it makes sense for compiling data. If the data is not good enough, then merging data is not going to sort of, it's just not going to give you the output which you so desire, right? So data needs to be collected in a systematic fashion with a prescribed objective, and once you have a project, and I'm using the word project very, very loosely out here, like even a DM or an MD or an MS dissertation, there should be fidelity in the way that data has been acquired with regards to what was the way written down in the proposal, right? Once you have that information and you're confident of the robustness of that information, then comes the step of combining it, or we're looking at big data. I don't think at the moment we've reached the realm of big data yet. I think we're all struggling to ensure that even our small data is good quality data, and I don't think we should be in a hurry to look at numbers. I think the first step is to ensure that the scientific rigor by which that data is acquired is intact, so that even if it's small data, it's good quality data and you can make sort of sense out of it. What was the strategy for making all the colleges together? Right. So that you'll have to do. Again, I'm coming back to the same thing. I think somebody will need to do an audit and say, if there are 100 MD and MS dissertations which come out from the colleges of Gujarat, what proportion of them in a finite period of time have reached the stage of a publication? Because that means there's been an external peer review over and above an internal review, which is the hallmark of assessing quality.
तो अब अगर हाँ बेटे पूछिए.
My question is to Dr. Balram. Sir, you have shown us some of the wonderful innovation and techniques. My question is that what are the ethical issues when spontaneously a technique is being developed? Like we are dealing with cardiac surgeons. They, in OT, they feel that it should be like this. This is the conventional technique, but in this patient, this should be appropriate thing. With the course of time, with 4 or 5 patients, they become master of that thing. They want to publish that data. When we are proceeding for that, the journals are asking us about the ethical issue. And then they says that we have not get ethical clearance because that is being developed by me and through a clinician's perspective.
Yeah.
This is with cardiac surgeon, cardiologist, and everybody who is involved in this.
Exactly. I think the first technique or a first patient that has been done by a special technique could be reported as a case report. Subsequently, one could apply for an ethical clearance that I would like to do a series of this patient, maybe 5 or 10 or whatever. And once you have that in board, then you can obviously collect the data of 5 or 10 patients and publish it easily without any problem.
But there won't be any issue if we are reporting one case report based on our
first case report is a
instinct.
case report. It's a clinical case report that you can report in any this thing. Now, for example, a new treatment you want to try by a newer, which could harm the patient, possibly a new treatment. In that case, you have to get prior, before even getting the case report, ethical approval.
Otherwise, in case report, there is no issue if I want to deviate from the protocol, standard protocol.
Yeah.
There is no issue.
Not a problem. I mean, supposing instead of making incision like this, you said I make an incision like this, but you're opening the same thing. So that is, and I find that you get more visibility by opening it in this direction. So those kind of is a human body. So those kind of variations are not a problem. And then if you want to establish that technique that it is superior, then you get a series of it and then publish them.
If my results are not good in first case, if I am facing a mortality, but with the course of time, with the mastery and other equipments, if that technique is performing well, then in that case, because based on first case, the ethics committee will not approve my technique.
So you will have to collect whatever data is in and around that technique and submit for ethical approval, and following which you can start it.
Fine. Thank you.
You can't do any thing that.
But ma'am, I'm talking about the spontaneous result. The surgeon is an OT and he feels that this should be done.
I'll answer this question. In oral cavity, we work one conventional method, one my own method. We have instruments like Ostel and all, which shows the stability of that system. Right? We have both the same. One, what you call the control study, one my study. And after 1, 2, 3, 4, 5 cases, like you mentioned, I get the mastery on this and this is better. I publish this and everybody accepts it. This is what Dr. Balram is saying. First was my case report. You like it or you don't like it. Then we start working and we have the same patient. One side is control, one side is what we are doing. So you have to develop some studies, some way out, and you have to publish an index journal. Definitely. Not like this is my experiences and I can cut through anywhere. It has to be published and accepted. Yeah. Sorry.
Thank you. So I think with this question we can now, I will request Dr. Katoch, instead of my making a concluding remark, I have already said the two things which I consider very important, and I would request particularly the people from medical college to consider that very seriously. Otherwise, the purpose of this meeting will be defeated if we, in the next 6 months, we don't get some proposals, some things. And we'll be very willing to help you out anytime you want. You can just tell Tyagi ji and he will organize, and either it is Dr. Amit Ghosh or PK Ghosh or any one of us sitting here, we'll be very happy to help you out if you want to develop a proposal. But please do consider that.
एक्चुअली और कोई एक्सपेक्टेशन नहीं है इसी से. आप अगले 1 महीने के अंदर यू थिंक ऑफ द आइडियाज़, उनके कंसेप्ट बनाइए, क्या टीम बनानी है, उससे क्या निकलेगा, वो 2-2 पेज के बना के सेंड टू डॉक्टर श्री त्यागी जी के साथ बात भेजिए. आप मैडम जैसे कहा है कि चाहे नासी के जरिए चाहे इनके लोकल सिस्टम के जरिए प्रोजेक्ट डेवलपमेंट की वर्कशॉप ऑर्गेनाइज करने की पूरी टाइम बाउंड कोशिश की जाएगी. हम में से जो भी मदद कर सकते हैं करेंगे, लेकिन आप पहले 1 महीने के अंदर सोचिए. 1 महीना भी एक लंबा टाइम है. आज सोचने शुरू कर दीजिए, टीमें बनाइए, दूसरों को भी बताइए. सो सक्सेस आज की सक्सेस होगी अगर महीने में कितने कंसेप्ट आप मेडिकल कॉलेज से जनरेट होते हैं. तो प्लीज गो विद अ पॉजिटिव माइंड एंड वी आर ऑप्टिमिस्टिक कि आप करेंगे कुछ. धन्यवाद.
Vote of thanks.
दोस्तों, विदाई का समय आ गया है. कुछ ही देर में हमारी मंजिल अलग होगी, आपकी मंजिल अलग होगी. मैं सबसे पहले अपने अतिथिगण को धन्यवाद देता हूं जिन्होंने अपनी हाजिरी में, अपनी उपस्थिति में हमें अनुग्रहित किया, अपने अनुभवों से हमें परिचित कराया, रूबरू कराया और काफ़ी कुछ उन्होंने हमें अपने विचारों से हमें एक दिशा देने की कोशिश की. सबसे इम्पॉर्टेंट लेसन, सबसे इम्पॉर्टेंट पार्ट उन्होंने जो दिया वो ये दिया कि दोस्तों हम अपनी दीवारों को तोड़ें, दीवारों के बाहर देखें क्या हो रहा है, और उन सब से वो लोग जो मेडिको नहीं बन पाए, जो किसी भी तरह से रखिए, वैज्ञानिक की तरह से रखिए, हम वो पूरी सपोर्ट आपको देने को तैयार हैं, उस प्रोजेक्ट के लिए पूरी तरह से देने को तैयार हैं. दोस्तों, हम किसी दिन बहुत ही शॉर्ट टाइम में, बहुत ही शीघ्र हम आपके साथ बैठेंगे, आपकी जो समस्याएं हैं उन पे सोचेंगे, आप हमें बताइए कि ये समस्याएं कौन लोग इसको हल कर सकते हैं, हम उनको साथ में रखेंगे और प्रोजेक्ट को हम कैसे डेवलप कर सकते हैं हम उसमें जुड़ेंगे आपके साथ। और इसके साथ साथ हम कितना भी आपको मदद कर सकते हैं, जो भी पैसे की मदद हम कर सकते हैं। दोस्तों, ज्ञान हम में उतना नहीं है, हम उस जगह बैठे हुए हैं जहां हमको उतना ज्ञान नहीं है जितना आप लोगों को है, आप उस लाइन के लोग हैं। हम तो सिर्फ एक फाइल चलाते हैं और कारकुनी दिमाग से हम काम करते हैं, क्लर्क के माइंड से हमारा काम रहता है। हम भले ही हों, कहीं भी बैठे हों, हम आपके साथ जुड़ेंगे, आपकी मदद करेंगे। आप कुछ आइडिया दीजिए, कुछ प्रोजेक्ट दीजिए। आपके लिए मेरे दरवाजे, मेरे डिपार्टमेंट के दरवाजे, मेरे विज्ञान और प्रौद्योगिकी के दरवाजे आपके लिए हमेशा खुले हैं। आप जब कभी भी आएंगे, हम अपना समय बिल्कुल खाली रख के बिल्कुल आपकी सेवा में होंगे। दोस्तों, ये जो आज का जो संगम था, इस संगम को फलीभूत करने में हमारी डॉक्टर मंजू शर्मा का खास मैं ऋणी हूँ। ये सब लोग जो आज आप यहाँ देख रहे हैं, स्टेज पे देख रहे हैं, ये मेरे बस की बात नहीं थी। ये उनकी ही महिमा में कहूँ, उनका प्रताप कहूँ, उनका इन्फ्लुएंस कहूँ, ये उनकी वजह से ये संभव हो पाया कि हम आज यहाँ पे उनके विचारों से अपने को हम रूबरू कर पाए। दोस्तों, ये एक दुर्लभ क्षण है और इस सभागार में मेरे ख्याल से, मेरे विचार से शायद ये पहली एक ऐसी गोष्ठी है जिस पे हम सब यहाँ बैठे हुए हैं और हमने बहुत कुछ ऐसा सुना है जिसको हम आगे तक बढ़ा सकते हैं। दोस्तों, आप सब हमारे निमंत्रण पे यहाँ पे आए, आपने हमें अनुग्रहित किया और आपने हमें जो है एक बहुत बड़ा आपने एक हमें विचार दिया, हम आभारी हैं। डॉक्टर कटोच, डॉक्टर बलराम भार्गव, डॉक्टर निखिल टंडन, डॉक्टर ललित कुमार, डॉक्टर एसपी अग्रवाल, डॉक्टर अलका शर्मा, डॉक्टर मंजू शर्मा और डॉक्टर सुनील कुमार, हम आप सभी के बहुत बहुत आभारी हैं। मैं सभी की तरफ से आपको आभार व्यक्त करता हूँ। हमारे ज्ञान में निश्चित आपने इजाफा किया है और हमारे आप बहुत अच्छे आज प्रेरणा स्रोत बने हैं। हमें बहुत सारी चीज़ें जो आपने बताई वो हमारे दिमाग में रहेंगी, हम उनको याद रखेंगे और शायद आप खुश होंगे जब ये आगे हम लोग कुछ प्रगति करके आपको दिखा पाएंगे। सुदूर से आए और नज़दीक से आए, हमारे अलग अलग मेडिकल कॉलेज से आए हुए प्रोफेसर्स, फैकल्टी मेंबर्स, मैं आप सबको धन्यवाद देता हूँ। आप हमारी एक चिट्ठी पे, केवल एक चिट्ठी पे आप यहाँ पे आए हैं और आपने उस चिट्ठी पे जो गौर फरमाई, शायद आपने वो चिट्ठी पढ़ के यहाँ पे आप हैं, मैं आपको बहुत बहुत धन्यवाद देता हूँ। आप रिसर्च में जुड़िए, कोशिश करिए, हम आपके साथ रहेंगे, ये हमारा वायदा है। आप बायोकेमिस्ट को जोड़िए, माइक्रोबायोलॉजिस्ट को जोड़िए, जोलॉजिस्ट को जोड़िए, जो भी बायोलॉजी की फील्ड से है आप उनको जोड़ने की कोशिश करिए, हम आपके साथ रहेंगे। मित्रों, आप सभी अपना महत्वपूर्ण काम छोड़ के आए, हमारे साथ यहाँ इकट्ठे हुए और आप अपने साथ कुछ मेडिकोज को भी लाए, उनको भी आपने इजाज़त दी, आप हमारे भोजन में हमारे साथ शरीक हुए, बहुत बहुत धन्यवाद। दोस्तों, आपको यहाँ लाने के लिए भी जो भी कोई परिवहन का जिसने भी दिया, आपके उन ड्राइवर्स को भी मैं धन्यवाद देता हूँ जो आपको यहाँ समय से लेके आए। मैं डॉक्टर शाह का धन्यवाद करता हूँ, उन्होंने यहाँ समय निकाल के अपने अमूल्य क्षण हमको दिए। डॉक्टर प्रभाकर का मैं धन्यवाद देता हूँ, ये सभागार जिसमें आप बैठे हैं ये उन्हीं की मदद से हमको मिला है। और उन सब अतिथियों के लिए जिन्होंने दोपहर की गर्मी में हमारे साथ रहे, दोपहर की इसमें हमको आश्रय दिया, स्पेशली डॉक्टर प्रभाकर को। उन्होंने हमें अपने चैम्बर में ले गए और वहाँ पे हमको भोजन कराया। मित्रों, जब मेडिकल के क्षेत्र में बायोटेक्नोलॉजी की जब कभी चर्चा होगी, हमें आज का दिन, आज के क्षण हमें याद रहेंगे। मित्रों, ये सब कार्यक्रम, पूरी व्यवस्था जीएसबी टीम के साइंटिस्ट ने, स्टाफ ने, अधिकारियों ने अच्छी तरह से संभाली। उसमें कुछ त्रुटियां रही होंगी, कुछ थोड़ी बहुत त्रुटियां रही होंगी, शायद वो हमारे ध्यान पे नहीं आई होंगी, क्षमा करिएगा। दोस्तों, ये सभी स्टेज को संभालने का काम, ये माइक संभालने का काम, भोजन की व्यवस्था, रजिस्ट्रेशन का काम और सभी को बैग डिस्ट्रीब्यूशन का, साहित्य डिस्ट्रीब्यूशन का काम ये किसी और ने नहीं किया है। ये इसमें मेरा ही स्टाफ है, जो छोटा सा स्टाफ मेरे पास था, उसकी मदद से मैं इस काम को संपन्न कर पाया। दोस्तों, हम ये जो क्षण है ये अद्वितीय है, ये अद्भुत है, और ये जो क्षेत्र है, ये क्षेत्र जो है अपने आप में एक असीम गति से ये बढ़ रहा है और समय दोस्तों आपकी प्रतीक्षा कर रहा है। हम आपकी मदद के लिए तैयार हैं, आपकी मदद का वायदा करते हैं। आप हमारी अनुपस्थिति को कभी महसूस नहीं करेंगे, आप हमारा रिकॉर्ड देख सकते हैं। हम शायद ही कोई यूनिवर्सिटी है जिसको हमने फंड नहीं किया, जिसके प्रोजेक्ट की हमने कदर नहीं की। मैं दूरदर्शन को धन्यवाद देना चाहूँगा, उन्होंने यहाँ की क्लिपिंग ली और वो रात को 8:30 बजे डीडी गिरनार से उसको प्रसारित करेंगे। दोस्तों, यहाँ जो भी कुछ हुआ है, अभी तक हुआ है, वो सारा रिकॉर्डिंग किया गया है और ये कल ही हमारी वेबसाइट पे ये डाउनलोड हो जाएगा। और जो लोग यहाँ नहीं आ पाए हैं और किसी कारणवश वो समझते हैं कि उनको भी इसमें शरीक होने की ज़रूरत है, वो उसको सुन सकते हैं। दोस्तों, ये जो हमारा सब कुछ प्रयास है, मैं बहुत ही स्पष्ट रूप से कहना चाहूँगा कि डॉक्टर प्रभुदास पटेल और डॉक्टर रावल, ये दो की अगर कोशिश ना होती तो शायद हम उतना सफल नहीं हो पाते। हम बहुत जल्द मिलने की आशा रखते हैं और अपने अतिथि जो हमारे आज हैं, हम उनसे भी गुजारिश करते हैं कि आप जब कभी भी आपको समय मिले, आप आइएगा, हमारे मेहमान बनिएगा और हमें अनुग्रहित करिएगा। खूब खूब शुक्रिया आपका, बहुत बहुत धन्यवाद।
Thank you, sir. I would request all the participants to join for a high tea which is arranged downstairs, and then collect your certificates from the registration desk. Thank you all of you for participating. I would like to request our dignitaries to please come on the stage for a group photo, sir. Yeah, and I would request GSBTM team to please come on the stage.